right. Good morning, everyone. So, my name is Nicolas, and this is John, and we're going to talk to you today about constraint layout, a new layout for Android.
Okay. Go ahead. OK. What's layout all about? Basically, you need to position widgets on the screen based on something that a UI designer might have given you, for example. So you have to lay them out in some particular fashion on a screen. But what happens if you have another screen that you have to lay out? If they're fixed position on the new screen, it's not going to look right. Things are too far away from the edges, things like that. Now, how many screens would you actually have to do if you had to do every screen out there? 5,400 is a rough number. That's 90 common screen sizes, 30 languages, landscape, portrait, many, many devices, and it'll take you a really long time. That's why from the very beginning, Android had layouts. They're able to adjust sizes and position things dynamically for you. There are a bunch of different layouts we can talk about. And you can divide them up into two basic categories: simple layouts and complex layouts. The classic simple layout is linear layout. Essentially, you put your widgets inside of it, and you have a row or a column of buttons or widgets. Now, you can build very complex layouts with just using linear layout by doing deep nesting. But deep nesting has its performance problems. On the other hand, if you use a complex layout, like relative layout or grid layout, it'll create shallow hierarchies. But without a good GUI builder to use them, it's actually very difficult to keep them stable. We need something new to help us with that stuff. That's why.
And so that's why we are now presenting you constraint layouts. So it's available on the new Android Studio 2.2 preview in the Canary build. And basically, it's a small unbundled library. It's actually backward compatible back to Gingerbread, to API 11.9. That means nearly everything out there. And it's designed to reduce deep hierarchies, and it's designed from the very beginning to work within Studio. And if you have started to look a little bit at constraint layout already, it might look a little bit like relative layout, right? You set relations between different widgets. And that seems pretty similar to what constraint layout does. Well, sure, but actually, constraint layout does what relative layout does, but more. And as it is more expressive, you should be able to reduce nesting. And as John said, nesting in general would not be a great thing for your performances. It's also packaged as an unbundled library, which means that not only can you use it from day one, but we will also be able to regularly iterate on it and push new versions and add new features, and you'll be able to get them instantly. It's also extensible in its design, which you don't care too much about, apart that from us, that allows us to easily add new features. And finally, it comes with a great UI builder. As I said, that was really created as the same team, actually. The same team worked on both the constraint layout and the UI builder. And we really tried to make a UI builder that is flexible and easy to use, and really try to help you. So when we started to think about creating a new layout system, because we're not super happy with the current design, we just started with something very generic. OK, we need an equation solver. And on top of that, we had equations. But the problem with that is with the equations, and we could have stopped there, right? We could have said, oh, you have equation, that's great. Just set your equation, put your layout, and that's it. But the issue with that is it's actually very easy, we found out, to create a system that are not only complex, may not perform really well, and also can even be unpredictable in the way they react. So that's why we built on top of the equation system a very simple but pretty expressive system of constraints. And that allows us to control all the type of constraints and the type of equation that runs and ensure better performances. On top of that, we then build the UI builder plus inference tools to create the constraint for you and a bunch of other tools that we will demo later. So very quick overview of the constraint model. If you want to create a connection, you just drag from an anchor to a target. And the other thing you can do is if you simply drag that widget, you can actually specify a margin. And that's all a connection is. It's saying, take one side, move it to a target, and possibly keep a specific gap. And you can apply those connections on, of course, top, bottom, left, right, or start and end for right to left languages. We also support baseline. And at first glance, that's it. The other thing that is different and particularly relative to relative layout is what happens if you actually set a connection on both ends, both on the left and on the right. And if you have a widget that actually is fixed size, that sounds impossible, right? I mean, the left side cannot be matching its constraint at the same time as the right side match the constraint if the widget does not resize. So what we do in that case is that we just center it. And because it's centered and we can tweak the result, we let you decide how much bias you want toward one side or the other. And you can also do that directly into the UI builder, just drag the element or use the inspector. Another option that we provide is, well, what if you want to resize a widget? And in that case, think about it like match parent. And actually, we do not support match parent. But what we do support, it's something that's more like match constraint. And what that will do is resize the widget so that the constraint that you define the size of the widget. Another important aspect that often comes when you try to do complex behavior in your UI is what happens when you want the widget to be gone. I mean, the first case is, OK, the widget is invisible. If you do that, nothing changes. That's easy. It's just not drawn on screen. But for gone, what we do is we collapse the widget that you marked as gone as a single point. And we discard its margins. So it completely disappears, but the actual hierarchy of constraint still applies. And so that allows you to have a lot more reactive user interface behaviors. All right, some of you might have wondered about what are the attributes. And yes, we did build a great UI builder. And we do think that that UI builder will really help you create those UIs and really make your life easy. But if you do want to use the XML or the programming or do the UI programmatically, you can still do it. It's a normal view group. You still have access to everything. So if you look at those attributes, it sounds like, wow, there is a lot. But actually, not so much. If you look at those ones are the usual ones. Just defining the width, the size, the text size, and stuff like that. Nothing to do with us, really. Then you got a bunch of attributes, and so we can discard those. Then we got a bunch of attributes that are actually, as the prefix indicates, for the tool. It's just for Android Studio. If you do things programmatically, you don't care about that at all. And in fact, when you push to a device, those attributes get stripped out. So really, the one we care about are those four in the middle. And really, on those four in the middle, the margin start and top, you probably know them already. So we only have two more attributes to just say you have a constraint on the left and a constraint on the top. So it's actually pretty tractable. That said, we really think that the UI builder is great. And in fact, if you have issues with the UI builder, if it doesn't work for your workflow, tell us. We really want to hear from you because we really want to make your life easy. All right, let's talk about the layout editor itself. So it's two-way editing, right? We can edit the XML and see the results directly live, or vice versa. You can, edit the UI, and that will directly translate to the XML. You can have both views at the same time, or you can stay in the design mode. It's directly integrated into Studio. And we really try to make it so that there is an immediate feedback. And so it's really easy to use. Things get predictable, and you're not surprised like you might have been in the past with relative layout, with whatever the layout decide, wherever it decides to put the widgets. And it's in active development. We just released it in 2.2 preview. It's in alpha. We definitely welcome bug reports. All right. Do you want to talk about that?
OK, one of the nice things that the new layout editor has is the inspector. This gives you an iconified view of a single widget that is you've selected. The arrows on the left and right, the lines on the left and right, and up and down show you which sides have been constrained. The numbers show you the margins that have been set, and you can actually just move your mouse over them and edit the margins directly. The sliders allow you to adjust bias if you're connected on both sides, so you have a bias. The little arrows inside show whether you're wrap content or spread or fixed width. OK, let's go to the demo now and on the laptop.
All right, so you can see that's Studio, right? And if you have played with it already, that should be familiar. And you can see here, this just shows the constraint layout. And I can switch to the design mode. And we have those two modes. We have the design mode where it shows what things look like on the device. And you have the blueprint mode. And you can also have both of them at the same time if you prefer. So why did we do the blueprint mode? Well, simply because sometimes what you show in terms of layout doesn't actually appear in the design surface. Like, for example, if you look at a button, the button shows smaller than what its actual bounds are. So the blueprint mode, think about it as it's an X-ray of your current layout and only show you the information that pertains to the layout. So with constraint layout, you can just go and drag wherever you want. And you do have some guidelines to help you position elements. We follow the material design guideline, for instance. And it's very easy to use. You can, without doing any constraints so far, you can still move it wherever you want. And it's really good when you are simply playing around or trying to design your UI, testing to see how things really fit. So if you create a connection, we just animate directly. And you can see that if I don't create a connection, we still show you what will happen if you release and create the connection. And that actually works with the entire system. So if I drag a button, and I attach this button here, and I kill this connection, everything moves together. So, and you can see here it's only constrained horizontally, so vertically nothing changes. And I can create a connection manually like that. You can destroy all the connection by clicking this. And just align your things and create those connections. There are two different modes to create connections. One is this manual one, and I think it's very important because we want you to be able to easily tweak the resulting UI. But there is another one that's a little bit more easy to use in some cases, which is the auto alignment. And if we go on auto alignment, let me go back on that. So auto alignment works with this icon here, this little U-shaped magnet. And what happens now, if that is on, is that if I put my widget on a guideline, it will create those connections. And you can see that there's this small animation. As long as the animation is not finished, I can still move things around. But if I let it go, then the widget will actually be constrained. So if I actually resize, oops, there's a bug. If I resize that, yeah, repaint bug, but you can see that the constraints are applied. And I think you will talk about the tools now.
Well, one more piece of auto alignment that you might have forgotten. One of the nice things about auto alignment is that when you put an object like this, the fact that you see the guidelines allows it to connect. So as long as you can see the guidelines, you'll be able to let it go, and it'll connect for you. So it can be a quick way, especially for very simple UIs to be built. The next thing I wanted to show you is what we call our tools. So because we are so much a rich UI layout type environment, we wanted to add tools that were a lot like the stuff that you would see in PowerPoint or any of the Visio, any of the graphical tools. So at the top, you'll see a collection of widgets. And they work in sort of standard ways where, let me undo the, where they would align left, right, middle, that kind of thing. There's a special mode. If you have the magnet turned on, when you issue those, it'll actually create constraints for you. So if you care about having the constraints very specifically left aligned, you can use this to sort of tell you how would that happen.
And in fact, it's kind of how we want the tool to be used. We want it to be used in a very flexible way. Some people might just, as they go along, just create the constraints. Or some people might just prefer to lay out the widgets, look, oh yeah, they're in a nice place, and then build the constraints. It's really up to you.
So it helps in a lot of situations like this, where you're just aligning things, putting things together like this, setting up, and you can see fairly quickly I can come up with a reasonable amount of alignment and packing of things in ways that we'd like to use it. OK, for the next piece, I want to go to the next one. For the next piece, I wanted to talk to you about inference. Now, inference is it's a fairly complicated system.
Once again.
OK. You're scaring me there. What we're doing, it's just one button, the little light bulb button. Don't press it yet. What we do when you press that button, we calculate the probability of all possible connections. And then we walk through a series of heuristically defined algorithms which will make connections for you. By the end of it, all things will be properly constrained. There are a couple of things, it's a bit magical, but there are a couple of things to remember about it. 3 things to remember. It'll never really move a widget on you. It will apply constraints wherever you've left your widgets beforehand. So it's not going to suddenly push a widget off the screen or something like that. It will do some small changes whenever there is trying to do an alignment of things, but that's OK. By the end of the pass, all of the things are guaranteed to be constrained. If you have a constraint beforehand, it will honor those constraints. So it will never destroy an existing constraint that you've created. So you can create constraints and then let it finish the job for you. And in fact, in the demos you saw, a lot of them were some manually created constraints. Sometimes it will do auto-constraint. Go ahead, Nicholas. Press the button. Let's see what happens. So there you see it. It made a bunch of constraints. It aligned everything. Now resize the widget. Resize the screen. So that was done just by drawing out the widgets in the right space, and it can align them. If you didn't like a particular constraint it made, you could change it yourself, or you can add a new constraint, add one.
Yeah, so for example, I can still go and just destroy those connections and say, actually, I really wanted that one to be connected on the top. And actually, here you can see that we have a couple of mods to create those connections. So by default, it creates, with the margin you indicate in the toolbar on top. But if I press Control, it actually will create a margin with the current distance. And sometimes that's kind of nice, because if you just want to create the constraint, but you are actually happy with the current way the widgets are positioned, that's a time saver.
So another thing you can do is, if you've already laid out and you added a bunch of constraints and stuff, but you needed one more piece of UI on the system, add some new piece of UI in there. Now,
that's OK.
Now you can just press the button again.
Yeah, and as you saw when I dragged it, because the auto connect was on, it automatically tried to create those connections. But you can also do it with auto infer.
And you see it added that all the constraints needed to fill in that other widget.
And you can see that the constraint that it created was not exactly the same as the auto connection one. And that's actually because auto connect only look at the elements that are close to you. So that's why it shows you those guidelines. And those guidelines, if you drop the widget at this moment, will create the constraints where the guidelines originate from. The auto inference, on the other hand, look at the big picture.
Yeah, so it might pick things from, based on alignments, the probabilities are fairly complicated, and in the future we would try to do like more advanced algorithms in there. Okay.
But and I want to repeat what John said earlier, and it's very important. The auto inference is not going to move things around. It will actually very hard try to keep the widget where you put them. So that means that if you're not happy with the result, you can still go back and edit it. And it also tries to make the connection that makes sense. That might not be the connection you had in mind, but that's a connection that makes sense when you look at the entire system. It doesn't go crazy. That's what I'm trying to say. And that's why also it's important to have those manual capabilities to edit the constraints, because we see it more as a kind of a symbiotic relation between you and the tool. The tool will help you, might get you there like 90% of the way, save you a ton of time, and you can just focus on what's left.
And even if it doesn't work out, you can always undo.
Yeah.
So.
All right. So let's simply build something common like a row. So if I want to create a row like that, I can start with, and I can use the tools as well. If I just want to center, I can just do that. And if I look at the recycle view now, it appears here. But of course, it's taking all the space. So if I mark now the constraint layout to be wrap content, you can see there is a refresh, right? And you can see how it's just integrate like that into recycle view. And you can just continue and add more stuff, and that's it. You can easily build your rows. So it doesn't automatically have to work with the entire UI. You can use it, of course, for your main UI, but you can use it for something as simple as a row like that. It is just a normal view group. And you can see the result. Let me just show you quickly how you create a new layout file. So you can, in Studio Preview 2.2, let's see, demo. You just go here and type constraint layout. And what that will do, it will create the file. It actually will automatically add, if that was not the case, the dependency to the support library that contains constraint layout. And you can then build something. And you can still use the design mode. If you actually prefer the design mode, that still works fine. We just, in that case, show the different constraint as an overlay on top of the system. Or you can just switch to Blueprint. I tend to prefer Blueprint because it just makes things easier for me when I'm working on layout. But the design mode is really useful to show you how things look. So if you want to just build like a typical dialogue like that, you could have something up just like that. And let's say a couple of, let's actually use email, and just plain text here, up, and then you can see that up, the connection works here, up, like that, and that's it. And without doing anything else, I got my dialog. And you can see it resize, up, if the repaint want to repaint. No, it doesn't want to repaint. Yep. Up, sorry.
You might want to infer.
Yeah. So, and you can still go back, kill all the constraints, do the inference, and you can see that the inference does a pretty good job as well. And you can note here that we constrain on the baseline, for instance. And I think that's about it for the demo. So we can go back to the slides.
Yeah. Go ahead. this stuff.
All right, so just to summarize a little bit what we showed you. So there is a new there is a new layout. It's called constraint layout. It's a small unbundled library. It's about 100 kilobytes. Because it's unbundled, we think we'll be able to move fast and add new features. It's really built on top of a flexible base. And what's good for us is that we can control how fast we can move on the development and to make sure that the performances will sustain. It's compatible with mostly everything out there, and it's in active development. I want to emphasize this point. We just released it this week. It's coming just as an alpha preview. We definitely encourage you to check it out, check the UI builder. And there's certainly some bugs. We'll fix them. But the reason we actually announced it at I/O was because we think it's ready enough to gather some feedback. And that's really something we are keen on. We want to hear from you. Our job is to make your life easier. On the UI builder, as you saw, the UI builder is kind of live, try to automatically react to your actions, to help you, to give you some guidance. And you can use the inference to create connections to really save you time. But you still have the manual edition. You can still go back and just edit things. And same as the constraint layout itself, it's in active development. It's the same team that works on both, which is why they are really well integrated together. So all of that I said for the constraint layout also applies definitely for the UI builder. And by the way, on Android Studio 2.2 preview, there is this new UI builder for constraint layout, but there's also a new UI builder for the other layout that you already use in your applications. And if you use the UI builder that was there in previous version of Studio, that new UI builder is definitely a step up. And again, for it as well, it will get better over time. All right, let me talk briefly about what we have in mind for the next versions. So if you remember the slide from earlier about the solver and the equation and the constraints, clearly, we are going to focus, and probably in the short term, that's mostly what we'll be working on, improving the performance. We have a ton of optimization that we haven't, obvious ones that we haven't yet done. So we really want to focus on that. For the equation themselves that we generate from the constraint, we have some interesting ideas on how to automatically take them and simplify them and optimize them. But for the constraint, there is a couple of things that we can do, and actually we could have demoed it. But in addition to those basic constraints that we demonstrated, we have the concept of helpers. And one of the helpers that we have in the preview actually is a guideline object. So you can create a guideline, think a Photoshop guideline, something like that, something that your designer probably work with. And you can just set a guideline, make it relative to one side or the other, or percentage of the dimension of the container, and simply constrain your widget to that guideline. The interesting thing, though, is that this guideline is not a new layout. This is just an object that we use to generate the right equations. And we have a ton of ideas of other type of virtual objects like that will help you create more advanced layouts. Another thing that did not make the cut for I/O, but that we know is important, is that all we've talked so far and that we demoed lets you create constraints, position constraints, from one to one. Of course, it can be from one widget to many widgets for the two axes, but it's going to be from one widget to something else. And often, you want to actually consider position in terms of grouping. You want to say, yeah, sure, but I want this group of stuff to be vertically positioned. And we have a concept of virtual containers. And similarly to the guidelines, those things don't have to end up in the view hierarchy. So once we create them, they will actually appear in the XML as normal tags, so you'll see them. But when we inflate the XML, we can then drop them on the floor and simply use them to generate the right equations. So you'll still have the power of using groups without the implication in terms of the view hierarchy. You can think of this whole system as a way of decoupling the layout from the view hierarchy. And the shallower the view hierarchy, the better in terms of performances. But there are also other things. One particular thing that I'm really keen on exploring is if you have a very shallow view hierarchy, that should make your life a ton easier dealing with animations. I think if you try to do animation with very deep nested hierarchies, it can be very annoying because something that is really deep down in the hierarchy, you want it to maybe move somewhere else, and it's very difficult to do right now. But if you actually do not have an actual view hierarchy and everything is kind of flat, it's much nicer.
Yeah.
And of course, for the inference and tooling, we have some interesting ideas on how to let you import assets into Android Studio. And the concept is simply, we want to give you a step up. Don't start from scratch. If your designer gives you something, maybe there is something in what he gives you or she gives you that we can use. And finally, and John might have something to say about that.
Yeah. So the inference and tools are a combination that we see a lot of future of making your life very easy. So one of the things we want to do is back the probability by machine learning. So look at what layouts are out there, what are all the Google layouts that they've created, and see how they are working, and try and learn from them. Tools to help you more easily beautify and organize and arrange your widgets on the screen, more dynamics associated with when I put things on the screen, it'll automatically infer containers and virtual containers and guidelines and things like that as well. So there's a lot of room to grow in that area as well. Okay.
All right, thank you for your attendance. Check out the code lab. There's a great code lab that lets you walk you through the first steps in using constraint layout. Download the preview. Beyond the constraint layout and the new UI builder, there's a ton of things, as you saw in the previous sessions about Studio. File bugs, you can use the Tool Studio tag. And we can take some Q&A now, and there are some mics that you can name up to if you want.
OK.
Thank you.
I guess nobody has a question. Go ahead.
Hello? Oh,
Yep.
Hi. I was curious, how expensive is the on-measure and on-layout for this layout?
That's a good question. So at the moment, the performances are not where we think they will be.
So richly deserve. And yes, this really does work even if that friend had to install the app first. Traditionally, deep links tend to get lost during app installs, but Invites uses Firebase dynamic links, which are able to survive the App Store installation process. As an added bonus, many developers have found that not only are these kind of invites more successful at driving installs, but that users who join through this kind of personalized onboarding flow are more likely to come back to your app in the future. And Firebase Invites isn't just for referral codes. You can use it to share any content you want from your app. Have a recipe app? Firebase Invites can make sure that killer lemon meringue pie recipe gets the visibility that it deserves. And because Invites is a Firebase product, it works with Firebase Analytics to let you know when a user has opened or installed an app through an invite. So be sure to check out the documentation and give Firebase Invites a try. We can't wait to see what you build.
Last episode, we used a decision tree as our classifier. Today, we'll add code to visualize it so we can see how it works under the hood. There are many types of classifiers you may have heard of before, things like neural nets or support vector machines. So why did we use a decision tree to start? Well, they have a very unique property. They're easy to read and understand. In fact, they're one of the few models that are interpretable, where you can understand exactly why the classifier makes a decision. That's amazingly useful in practice. To get started, I'll introduce you to a real dataset we'll work with today. It's called Iris. Iris is a classic machine learning problem. In it, you want to identify what type of flower you have based on different measurements, like the length and width of the petal. The dataset includes 3 different types of flowers. They're all species of iris: Setosa, versicolor, and virginica. Scrolling down, you can see we're given 50 examples of each type, so 150 examples total. Notice there are 4 features that are used to describe each example. These are the length and width of the sepal and petal. And just like in our apples and oranges problem, the first 4 columns give the features, and the last column gives the labels, which is the type of flower in each row. Our goal is to use this dataset to train a classifier. Then we can use that classifier to predict what species of flower we have if we're given a new flower that we've never seen before. Knowing how to work with an existing dataset is a good skill, so let's import Iris into scikit-learn and see what it looks like in code. Conveniently, the friendly folks at Scikit provided a bunch of sample datasets, including Iris, as well as utilities to make them easy to import. We can import Iris into our code like this. The dataset includes both the table from Wikipedia as well as some metadata. The metadata tells you the names of the features and the names of different types of flowers. The features and examples themselves are contained in the data variable. For example, if I print out the first entry, you can see the measurements for this flower. These index to the feature names, so the first value refers to the sepal length and the second to sepal width, and so on. The target variable contains the labels. Likewise, these index to the target names. Let's print out the first one. A label of 0 means it's a setosa. If you look at the table from Wikipedia, you'll notice that we just printed out the first row. Now, both the data and target variables have 150 entries. If you want, you can iterate over them to print out the entire dataset like this. Now that we know how to work with the dataset, we're ready to train a classifier. But before we do that, first we need to split up the data. I'm going to remove several of the examples and put them aside for later. We'll call the examples I'm putting aside our testing data. We'll keep these separate from our training data. And later on, we'll use our testing examples to test how accurate the classifier is on data it's never seen before. Testing is actually a really important part of doing machine learning well in practice, and we'll cover it in more detail in a future episode. Just for this exercise, I'll remove one example of each type of flower. And as it happens, the data set is ordered so the first setosa is at index 0, and the first versicolor is at 50, and so on. The syntax looks a little bit complicated, but all I'm doing is removing 3 entries from the data and target variables. Then I'll create 2 new sets of variables, one for training and one for testing. Training will have the majority of our data, and testing will have just the examples I removed. Now, just as before, we can create a decision tree classifier and train it on our training data. Before we visualize it, let's use the tree to classify our testing data. We know we have one flower of each type, and we can print out the labels we expect. Now let's see what the tree predicts. We'll give it the features for our testing data, and we'll get back labels. You can see the predicted labels match our testing data. That means it got them all right. Now keep in mind this was a very simple test, and we'll go into more detail down the road. Now let's visualize the tree so we can see how the classifier works. To do that, I'm going to copy-paste some code in from Scikit's tutorials. And because this code is for visualization and not machine learning concepts, I won't cover the details here. Note that I'm combining the code from these 2 examples to create an easy-to-read PDF. I can run our script and open up the PDF, and we can see the tree. To use it to classify data, you start by reading from the top. Each node asks a yes or no question about one of the features. For example, this node asks if the petal width is less than 0.8 centimeters. If it's true for the example you're classifying, go left. Otherwise, go right. Now let's use this tree to classify an example from our testing data. Here are the features and label for our first testing flower. Remember, you can find the feature names by looking at the metadata. We know this flower is a setosa, so let's see what the tree predicts. I'll resize the windows to make this easier to see. And the first question the tree asks is whether the petal width is less than 0.8 centimeters. That's the 4th feature. The answer is true, so we proceed left. At this point, we're already at a leaf node. There are no other questions to ask, so the tree gives us a prediction, setosa, and it's right. Notice the label is 0, which indexes to that type of flower. Now let's try our second testing example. This one is a versicolor. Let's see what the tree predicts. Again, we read from the top, and this time the petal width is greater than 0.8 centimeters. The answer to the tree's question is false, so we go right. The next question the tree asks is whether the petal width is less than 1.75. It's trying to narrow it down. That's true, so we go left. Now it asks if the petal length is less than 4.95. That's true, so we go left again. And finally, the tree asks if the petal width is less than 1.65. That's true, so left it is. And now we have our prediction. It's a versicolor, and that's right again. You can try the last one on your own as an exercise, and remember the way we're using the tree is the same way it works in code. So that's how you quickly visualize and read a decision tree. There's a lot more to learn here, especially how they're built automatically from examples. We'll get to that in a future episode, but for now let's close with an essential point. Every question the tree asks must be about one of your features. That means the better your features are, the better a tree you can build. And in the next episode, we'll start looking at what makes a good feature. Thanks very much for watching, and I'll see you next time.
So constraints. They're a great way for you as a developer to deal with the ever-expanding number of screen sizes, device rotations, and new form factors like slide over in the iOS world. But one unfortunate casualty in this brave new world of alignment has been the way we animate views. See, it used to be we could go around setting a UI view's position or frame with a fun little UI view animate with duration method and watch our view scoot around the screen. Oh, that was fun. But that's harder to do in a world full of constraints. Constraints don't necessarily play nicely with a view whose frame you're setting explicitly, as you can see here. Well, that leads us to this episode's quick tip sent in by Jacob Cho, a fan of Route 85 and a software engineer at Ensemble, a mobile app developer located in beautiful Vancouver, British Columbia. Jacob notes that many iOS developers forget that in addition to the old way of animating a view's position, you can also animate constraints in iOS. Let's look at how you might do that. Here's my storyboard, and as you can see here, I've got everything set up nicely using constraints. Now to move my UI image view on and off screen, I'm going to want to change this constraint here, the one that sets my image's leading edge to the leading edge of my super view. Right now it's set to -180, so it's off screen. So first I'm going to control drag from this constraint into my view controller to make it an IB outlet of type NSLayout constraint. This allows me to access it in my code. Now I can adjust it with a standard UI view animate with duration call. In this case, I'll change the constant of the constraint from -180 to 0 so that it appears on screen, and now we can give it a try. Well, that's weird. The constant definitely changed, but what happened to my animation? Well, it turns out to get this constant to animate nicely, I need to call layout if needed on my view controller's view within this animation block. We'll give it one more try, and that's much better. I now have a constraint that I can change within an animation block, and everything animates smoothly to its final position, except in cases where I want to adjust something besides my constraint's constant. Let's take a look at another example. Here I want to adjust this center square to expand or shrink to be either twice or half the width of its neighbors. Now I could do that in theory by adjusting the multiplier on the center view's width constraint. But it turns out that changing that multiplier in code doesn't work. See, constraint multipliers are a get-only property, and Xcode will give me an error. So how do I change it? Well, the answer is I don't. Instead, I create two completely different constraints and enable or disable either one as necessary. As long as I'm still calling layout if needed in my animation block, this kind of change will still animate. Now, there are two ways I can accomplish this constraint swapping. One way is to create both constraints in Interface Builder, like so. Now, Xcode will complain that these are incompatible, and it's right. So first step, we'll uninstall one of them by checking this box here. Next, we'll control drag both of these constraints into our code to make them IB outlets. And then I can enable or disable these as necessary in my animation block, like this. Once again, you'll notice I make sure we're calling layout if needed in our animation block, and we end up with a nice smooth looking animation. Look at that. The other way to accomplish this would be to create a completely new constraint in code. This is useful when I don't know in advance what I'm going to want this multiplier to be, and I need to create it dynamically. So let's see that in action. This time in my animation block, I'll first remove the old constraint. Next up, I can create a new multiplier. Let's make it slightly random just for fun. Ooh, hey, that is fun. OK, next I'll create a brand new constraint with this new multiplier and assign it to my center view width property. And then I can add it back in again to my view. Finally, I call layout if needed on the super view in the animation block, and I once again have some nicely animating views that use this new constraint that I've created. And because this is all done using constraints, you'll notice this works as intended on an iPhone in landscape mode, or even, say, a slide over view on an iPad. And once you understand that this trick simply involves removing an old constraint and adding a new one, you might discover a whole new world of animation is available to you simply by turning on and off various constraints. For example, on this screen, I can change all my views to be either left aligned or right aligned. simply by adding and removing two different groups of constraints, and then calling our now familiar layout if needed method. Pretty neat, huh? Oh, by the way, one fun little quirk about all this, if you add your new constraints before you remove the old ones, iOS will complain about all the incompatible constraints it has to deal with in those few milliseconds. So always make sure you remove the old ones first before adding the new ones. So thanks to Jacob for the quick tip. Jacob, you're going to get a very stylish Google t-shirt in the mail. But hang on, we're not done yet. You see, now that you know all about constraint animation, I have a couple more quick tips from one of Google's engineers about more efficient ways to implement it. So follow me on to the next video, because we're not done learning just yet. Click here, click here. And otherwise, I'll see you on Route 85. Bye.
People love to use different mobile devices in different ways that suit their situation and lifestyle. Michael uses a phone to play games on the go, while Tony enjoys using a large tablet as he relaxes on the sofa. And Jen carries a small tablet in her purse for reading on the bus. But they all want to use your app on the devices they prefer, so you'll want to make sure they each have a great experience, regardless of screen size, OS version, and the features of the app they use the most. It can be taxing to test each one of these situations so that all your users can be happy. We know you'd rather not have to buy and store stacks of devices and test your app in all these circumstances. That's why we built Firebase Test Lab for Android to make it easy and affordable for you to test your app with a variety of devices and be sure it works great for all your users. Our device lab, hosted in the cloud, offers a variety of physical devices ready to test your app. The selection of devices is always growing, so your tests will stay current with the latest hardware and operating systems. The easiest way to use Firebase Test Lab is to run a robo-test. This is an intelligent, automated test that crawls your app to discover and exercise its features. You won't need to write any additional code to make use of a robo-test. For more advanced testing, you can also script the interactions with your app to simulate specific use cases and verify that everything works as expected. Test results include a detailed report for each device used, including screenshots, device logs, and any crashes that may have occurred during the test. This allows you to verify that your app is working correctly on the variety of devices and configurations you selected. It's easy to make Firebase Test Lab a part of your daily development routine, and we have multiple ways to help you test regularly and spot errors early. First, you can use the Firebase console to upload and test your app. There is also a command line interface for testing with continuous integration servers, so you can automatically test every build. During Android development, you can deploy your app directly to Firebase Test Lab using Android Studio 2.0. And finally, in the Play Store Developer Console, there is a special automated launch test that will run for Android apps published to an alpha or beta channel. To get started using Firebase Test Lab and learn how to regularly test your app on different devices and configurations, you can start with the documentation available right here. Happy testing!
The Firebase Notifications console lets you re-engage your users quickly and easily. With it, you can manage and send notifications to your users easily with no additional coding required. Messages can be addressed to single devices, Firebase Cloud Messaging topics, or devices that you select using powerful analytics tools. So, for example, you can send a message to all of your users who have made an in-app purchase, giving them a special offer, allowing you to re-engage with them. The Firebase Notifications console integrates with analytics so you can measure the effectiveness of your messages and explore insights based on your users' activities, so you can grow your application by easily engaging your users through the Firebase Notifications console.
One of the driving principles of the mobile marketplace is that users want new apps, new updates, new content. In fact, over 60% of the users who go on to digital marketplaces do so because they want to try something new. While this is fantastic for user acquisition, this presents a problem for user retention, because if you are not keeping the user's attention, they will quickly be looking for something that will. In this episode, we will learn how to create a good retention strategy. Ready? Let's get started. The key to effective user retention can be broken down into 3 things. 1. Understand users' behavior in your app. 2. Identify roadblocks to retention. 3. Use tactics and tools to re-engage users. Now, of course, all of this starts with understanding your users. If you don't understand what they want, how they act, or their opinions, you can't really craft a strategy on how to keep them happy. The good news is that Google Analytics has a set of tools to give you insight here. First, check out your cohort analysis report. Why? Because cohort analysis is a powerful report that allows you to measure and compare users based on their specific customer journey. For example, what pages they visit, what they do, how they behave in each stage, etc. So you could measure the impact of your marketing campaigns on specific days, see how effective they are in generating loyal users, and compare which campaign performed best. Another good report is active users. Find out how your users interact with your app over time, so you could better understand why they may be staying in or leaving it. It displays your 1-day active users up to 30 days active users next to each other. This helps you answer some important questions regarding your users' retention. For example, if your 30 days active numbers is much higher than the 1-day active number, most users are not coming to your app more than once during a 30 days period. This can indicate that you need to add fresh content on a more regular basis, and maybe you need to re-engage users through marketing campaigns and notifications. The third report is about recency. This report shows how much time passed between app sessions. You might discover users who only open your app once a week. Once you identify users that engage with your app infrequently, you need to figure out how to re-engage that audience. You could send push notification to those users after 3 days to remind them about the app. You could even tailor the message to include incentives. A gaming app, for example, might want to send a push notification with an offer of a free in-app tool to users who haven't opened the app in a while. Now that you have an understanding of your users, you could start think about what their experience is like and get visibility into what roadblocks they are encountering in your app. Here are 3 basic ways that will help you get this information. Screen tracking will help you learn where users spend their time. For example, if each level of a game uses a different screen, you could track what percentage of people pass through each level. If there's a level that has a massive users drop-off, that may indicate that there is a technical issue associated with that level, or it is just too hard. Monitor your behavioral flow report. It takes your screen tracking, event tracking, and combines it in a visual user flow. Lastly, use the crash and exceptions report to identify possible roadblocks. You could break data out by app version, operating system, and device brand, so you could evaluate your app's technical performance in different environments. Want to take it one step further? Find out how much crashes are costing you. You could do this by creating 2 segments, one for sessions with crashes and the other without. Then compare the conversion rates and the average order value to see if these metrics are lower in the sessions with crash. Now that you've got all the basics down, the final step is building an effective re-engagement pattern for your users. This varies between apps, but the tools we covered today will help you think in the right direction. Do me a favor. Stop spending money on apps installs if you don't have a retention strategy. It's like the dude that sells tomato at a loss and telling his friends that he's going to compensate on it by volume. Game monetization today is more challenging and sophisticated than it used to be. A good monetization strategy depends on your retention strategy. You need to understand your users' behavior, identify roadblocks, and use tactics and tools to re-engage with your users. On the next episode, we will learn how to use in-app purchase househead as part of our strategy to increase revenue. Until next time, eat your vegetables and listen to your partners.
So now Firebase, it's a part of Google, but I hear that you were part of Firebase for a long time.
I've been Firebase for almost 2 years now, and I was a big user back in the early days. And when I first discovered it, I was building a lot of apps, and so having something that just made making apps so easy, I was kind of like, my God, they've done it. Like,
wow.
They've built the holy grail of development. And then one day they posted up a developer advocate job, and so sent my resume in on a Sunday. They called me on Monday, took a coding test on Tuesday, flew out on Wednesday, brought my whole family to, my wife and my 16-month-old son.
Wow.
Got the job that day.
So the only thing faster than the database is the hiring committee.
Yeah, no, it was a pretty fast process, just letting everyone know. I was like, oh, by the way, I'm moving to San Francisco.
See ya.
Yeah, pretty much.
Wow, and so now you're a developer advocate at Google, and Firebase is a part of Google. How is that?
That's been great. Like, it's been about 15 months ago that we were acquired, and it's been a really awesome experience because Google's just sort of thrown a lot of resources into us. We've expanded the team so much, and we've been able to focus on the core product and making Firebase better. We are in the middle of releasing a Unity plugin that's out there for beta for people to test out. Yeah. No, there's some pretty cool samples.
So lots of cool stuff there, David. But I mean, how does a developer get started with that?
So the best place to get started is just right on the Firebase website. So firebase.com, and then you can sign up, but also firebase.com/docs. Our docs are one of the things that we really pride ourselves on. So by just reading our quick start guide, you can already get a gist of how to get started. And then and each platform integrates totally with whatever dependency manager it has. So with Android, it's great with Gradle. With iOS, you can use CocoaPods, and web.
Web's web, right? Now, one of the things I remember about Firebase is that you guys used to do these epic hackathons where you gave out really cool swag. Right?
Yeah.
So is that something you're still doing?
Well, we used to make a joke that Firebase was actually a swag company, and we just were kind of put on a front that we did.
So it's a swag company that makes software.
Yeah, that was pretty much what we used to say.
Plan.
So yeah, we used to make, or we still do actually. We make tons of like pieces of swag. We did Firebase hot sauce was pretty awesome. Yep. But yeah, we did hot sauce. We did my favorite is headbands. So you have these sweatbands. And so I was at a hackathon once, and I saw this guy who was like, hey, can I have a couple? And by couple, he meant 16. And then he started putting them on and kind of mummified himself and then just sat down and started hacking. And I was like, dude's gonna win.
Did he?
I don't think so.
In all seriousness, though, I'm a developer. Middleware is really hard. If I want to have some kind of a database, if I want to have some kind of synchronization of data, it's a case where I can just go out and use Firebase today, right?
Yeah, no, that's what we're doing. We always say our mission is to help people build extraordinary applications. And so there's so many pieces of building something, and the back end is just so easy to get wrong, or so easy. You can just spend so much time. I remember one time I was building an Angular app, and I was so excited. It was I'm gonna write directives, and I'm gonna build this cool web app. And then I spent an entire month just building out the back end for it. And then I realized I haven't written a line of JavaScript yet. And so with Firebase, you don't have that problem. You can just immediately start doing what the user is interested in, because the user's only going to see the client-side stuff. Right. I always say, you're never going to get an email from an app reviewer or someone saying hey man, your app is so good. I can tell you use so many databases. It's really awesome. They're just going to tell you.
I'm going to review your app with that now.
Yeah, if you ever get that review, let me know. I would love to see it. But yeah, most people are going to say the gestures were great, or it was really responsive. I loved this feature. That's what people really care about.
Yeah, I've worked for middleware companies, and whenever we built apps, it was a case of we designed all the middleware brilliantly first, and then the app was the thing that came at the end. Right. And I've worked in purely mobile companies, and we were building mobile apps, and then the middleware was the thing that came at the end, and both of them. So, but to be able to make that middleware easy with the authentication, and of course the static hosting, which is it sounds trivial, and it often overlooked, but it's actually really important.
Well, the static hosting is really awesome because the setup is so easy with it. There is a CLI, so you just install it on npm, and once you have it installed, you type in a command Firebase init, and that kind of does it sets you up a little file that says, oh, this is the Firebase database I'm going to point to, or this is the URL I'm going to set up and everything. And then from there you say Firebase deploy, and then you have a website out on the web just like that. And what's kind of crazy about it too is that it comes with a free SSL certificate, so it's already provisioned out there for you. You don't have to do any of that wiring up. And then every single file is, is a static file, so we actually cache them in a CDN that has pops all around the globe. So wherever your users are viewing your site from, it's delivered to them from whatever that local pop is.
So for a developer to get started, Firebase.com, tutorials on there. I know you've written a series of tutorials on some various sites, right?
Yeah, well, I mean, our documentation is one of the things that we just pride ourselves on so much. It was one of the first biggest projects I was on when we joined, and it's we have a quick start, so you can get started on any platform in 5 minutes, and then after that we have your 0 to 60 guide, where you can go from knowing pretty much nothing to being an absolute pro. And we actually take pride in the fact that they're written for humans and not for technical geniuses. Yeah, non-humans. Exactly.
Well, cool. Well, thank you, David. Learned a lot. I'm going to go check out Firebase.com and see what I can write with Firebase in it.
Thanks for having me, Lomo.
If there's any Googlers you'd like to talk to, contact us on our G+.
But what I'd like to tell you today is that Firebase is actually an integrated, unified mobile set of development platform with tools to help you grow, develop, and earn money from your mobile app. There are 15 components in total. They are meant to work well together. If you adopt many of them, you'll find that the components have a certain way of working well together. 13 of these are part of the core Firebase platform. 2 are what we call integrations. So they're standalone products that are, have been modified and changed to work well with the Firebase platform. Now, this is some feedback I received. I put it in quotes. It's not actual feedback. This is sort of like aggregate feedback. I've been talking to developers all day yesterday and the day before. Everyone's been saying how much they love it, especially some of our early access partners. Some of our partners have been wholeheartedly adopting the Firebase platform for their apps. And I'll give you some more specific feedback about that later. But that's why my voice is a little bit hoarse today. I've been talking to so many people who have wonderful things to say, and they've been experimenting with it, doing code labs, putting components in their apps. And I would like to tell you about a couple app ideas I have and how Firebase can be used to build those out. So my first idea, I've experimented with this little idea called ride sharing. I don't know if this would ever take off, but my app idea is a ride sharing app called You Got Ride, and that name doesn't refer to anything in particular, but let's see, how could we build this with Firebase? Well, the first thing you probably want to do is have iOS and Android app. This is a mobile-first app. There's an app for drivers. So if you're a driver, you probably want to find out where are passengers, identify them, locate them, go get them, and take them where they're going. And if you're a passenger, you want to hail a ride. You want to find a driver to get you where you're going. So that's a basic ride-sharing app. Crazy idea, right? So the first thing you probably want to do is get users logged into your app. It would be kind of crazy to have a ride-sharing app where anonymous drivers are giving rides to anonymous people. That seems like a recipe for disaster. You probably want to get people logged in and identified so they can have some assurance that this is totally a legit thing. So you can do that with Firebase authentication. People can get logged in with minimal friction, and it's a federated login system. So we'll accept Google+ logins, Facebook, Twitter, and GitHub, of course, regular email and password, and if you bring your own authentication, you can integrate that as well. Now, the good thing about this is that once we have the user's identity, we can access their profile picture, so that can be used to help drivers locate passengers and passengers locate drivers. But if the profile picture isn't appropriate or missing, what you can do is you can use Firebase storage to provide a place for people to take pictures of themselves and store that in places. So once you have a profile picture stored, then you can use that to help drivers and passengers find each other. Now, Firebase storage is built on top of Google Cloud Storage, and as such, it scales to petabytes of storage. Now, petabytes is kind of a weird word. It's big, right? Well, that roughly translates to billions of photos, so you'll never run out of space when you need it. Now, you probably want drivers to be able to locate passengers wherever they are. So if a passenger happens to move, that driver needs to respond to that. So what you can do is you can use Firebase real-time database to write the user's latitude and longitude, their coordinates into the real-time database, and then the driver can actually receive that in real time. So you can think of like data going into the cloud, into the database, and being distributed in real time to those who are listening to it. So not only can drivers pay attention to passengers' location, the passengers can also see where a driver is. And this is great. This makes for a great experience. It gives you some assurance that things are going according to plan. Now, if you're using authentication along with database and storage, what you can do is set up rules so that the data you store in your database and in your file storage can be protected by authentication rules. And you write those rules yourself. You can determine who can see what other content, so you can be sure that your passengers or drivers' data is secure and stored safely. Now, you probably don't want to be glued to your app all the time. So imagine you're a passenger and you've hailed a ride, and the ride is like 10 minutes away. You don't want to stare at your app for 10 minutes waiting for the driver to arrive. So what you can do is allow the user to put the app away, and then send a message to them when the driver gets near. And you can use Firebase Cloud Messaging for that. So with Firebase Cloud Messaging, you can get users back into your app at the time something is important to them. So for a passenger, when the driver arrives, they'll need to know that. You can send them a notification. Likewise, if you're a driver, you might want to know where passengers are. If there's a passenger nearby who wants a ride, you can get a notification for that as well. Now, it's worth noting these are event-driven notifications, so Firebase Cloud Messaging is great for times when there's something in the system that changed, and you need to know about that in the app. Now, there's a different kind of notification called Firebase notifications, and what this gives you is a way to type in messages and send them to your users in the console. So in the console, you can say, I don't know, remind users if they haven't used the app in a while. Or you can say, advertise a promotion. So if you have 20% off rides, you can send a notification to everyone and get them back into the app. Now, if you're trying to perform an experiment, you might want to figure out, is early authentication better or is late authentication better? We do want our users authenticated, but you want to know the right time in the app to get users authenticated. So a lot of people might turn away if there's early authentication. They might not want to bother with that. So you might want to experiment and say, well, I'll test out early authentication and I'll test out late authentication after the user has sort of poked around in the app a little bit. And if you want to know which works better, you can use Firebase Remote Config to perform that experiment. So you're essentially doing an A/B test. And this is a great way to find out how your app works better for your users. Now, you probably want to get the word out about your app. So the best way to do that is to hook into relevant searches. So on Google, people might be searching for, say, a taxi or airport transportation. In this case, you can use Google AdWords along with Firebase to hook into those search results and have your app appear. It's essentially a relevant ad in search results to get people into your app at the time that they're looking for it. Another way to get users into your app is with dynamic links. So you can think of a dynamic link as a bridge between your web content and your mobile content. It's pretty easy to get web traffic. We've been doing that for a long time. It's easy to hook into searches that way. Everyone knows how to use a web browser. But you might want to push people into your mobile app for that unique experience. So dynamic links can do that. It's great for marketing promotions. With a dynamic link, you can say, have a special link that people will follow, then that links directly into the app for a first-time experience that keeps them engaged. And also, if they don't have the app installed, what dynamic links will do is get you installed into the app, and then after that, it will take them, again, directly to the content. Now, in the past, deep links always had the problem of not being able to survive this installation process. But with dynamic links, now you can. You can get users installed and directly to the content that you want. And now there's Firebase Invites, which is built on top of that. This lets happy users invite other happy users. This is word-of-mouth marketing. This is like the best way to get users, because glowing reviews from your happy users are more likely to create retention for the users that they refer. Now, invites are built on top of dynamic links. You get all the power of dynamic links with the personalization that an invitation gives. And we found that this increases retention drastically. Now, the last component I'd like to talk about for this app, for the ride-sharing app, is analytics. Now, analytics is the core component. This is the thing that ties together the rest of the Firebase platform. So with analytics, the obvious benefit is that you can know how your app is being used. And it's worth noting, this is an all-new analytics component. This is not a remake or a rehash of something else. This is built specifically for Firebase for mobile applications. You can know how people are using your app, and you can also measure the efficacy of your AdWords and your invitations, know how users are interacting with your app from external sources. And it works really well with notifications as well. So now with analytics, you can define an audience of users who you want to target. So say you want to target everyone who took a ride in Boston, say, in the last week or two. Now you can get them to get back into your app and type a notification and say, hey, we hope you enjoyed your ride. Would you consider taking another one? So that's 10 components. I promised 15. I showed 15 up here. We only talked about 10. Now that's a lot of components. This is a great way to start building out a ride-sharing app. But what about the other 5 components? What do we have? So I have a second app idea, and it's totally unique. It's a recipe-sharing app, and I call it iChef. I'm actually really bad at making up mobile app names, but run with me with this. So imagine you have an app that's Android, iOS, and mobile web and desktop web. You're scattering your app as far as you can. You're trying to reach as many people as possible. You generally want your app to be used anonymously, so if people are just doing regular web searches, they might log in, or they're not logged in yet, but what they'll do is find a recipe, search for other recipes, enjoy the app anonymously. But if you want someone to help, integrate their own recipes into your app, you might want to get them logged in. So that's how this app works. So the first thing, obviously, you'll need a place to store all of your recipe data, right? So you can use Firebase real-time database for that. Now, it's worth noting that recipes aren't really real-time. There's nothing terribly dynamic. Once you've created a recipe and put its data in there, it's not going to change. There's nothing really real-time about it. Now, Firebase real-time database can handle that, but what you can do with real-time database is you could say, create a real-time chat associated with each and every recipe so that everyone who logs in can talk about it with their friends and with the person who created the recipe. You can make your website and your mobile app much more dynamic and much more interactable. Is that a word, interactable? Interactive. I think interactive is a better word. Now, of course, you'll want people who are submitting recipes to take pictures of their recipe, maybe at various stages. So you want people to upload photos. So you can do that with Firebase storage. Like I said, Firebase storage scales massively, and you'll never worry about space again. Now, for the web side of things, if you have a mobile app, you generally don't worry about deployment. The app is deployed on the user device. But for web apps, you need a way to get your static content out there. So you have HTML, CSS, and JavaScript. All of that can be served through Firebase hosting. Firebase hosting gives you a way to deploy your static content out into the world in a CDN over SSL, so everything is SSL protected. Certificates are deployed automatically, and you don't have to worry about it. And there's a simple command line interface to deploy as often as you want. Now, it's also worth noting that if there are some graphical assets, say, that you don't want to package into your Android or iOS app, you could also deploy those to the Firebase hosting and then load those as needed. So that can shrink down your original APK size if you're an Android developer, or the iOS app can also be shrunk down. Now, this is important in parts of the world where there's not very much data. The bandwidth is very low. So having a small initial app size is very important. Deploy the rest of your content onto hosting and load it on demand. Now, of course, you do want to get people logged in, and authentication can do that. Now, what advantage does authentication provide? Well, you're essentially encouraging people to join in and be social. Say, log in. Have an identity. Have a space within your app. Let them interact with each other. Now you can do things like user-to-user communications. You can store specific data per user. So if users want to favorite recipes, you can store that within their space. If users want to follow other recipe creators, they can do that. You can store information about them and help them navigate your app better. Now, I was trying to figure out how might I use Firebase Cloud Messaging. So it's an event-driven messaging system, but how might you use it in an app like this? Well, there's kind of an unsung feature in cloud messaging. When you send a cloud message, it doesn't actually have to contain text of a message you want someone to read. What you could do is use cloud messaging to ping the app to say, hey, there's new content. You should load this. You should cache it so that when the user opens it up, they have fresh content. So for example, if you have a user logged in and they have favorited some other users, they want to know when they've updated new recipes, you can ping the app. The user's app can say, oh, I have new content. I'm going to download it, cache it, so that when they open it, the recipes are all there and they don't have to wait for it. And this makes for a very pleasant and much more natural experience than opening up and waiting for the content that they were hoping to find. Now again, you can use remote config for more things than just A/B testing. So let's say you have, you're doing a massive redesign of your website. So everything's changing, the look, the feel, the colors, the whole experience, and you want to launch this all at the same time for all your users at, say, during like a television event or some marketing push. And it's important that it's all available right at the same time. Well, in the past, you might have had to say, publish a new app to the App Store and wait for approval. Same thing with the Play Store. The Play Store doesn't give you a guarantee about when that app hits the market. So it's been kind of hard to make sure everyone gets the experience that you want at the same time. But with remote config, what you can do is essentially create a switch in the dashboard to say, I want to switch from the old experience to the new experience immediately. So you can be sure that everyone who's using your app gets the experience you want at the time that you want it. And as a side benefit, if something goes wrong with that new experience, say it's causing the app to crash, what you can do is turn it off, right? You can revert features that are having problems with the flip of a switch. Now, for apps like iChef that has content on the web and on mobile apps, and they're parallel, right? You're generally looking at the same thing in both iOS, Android, and the web. You can use app indexing. And the advantage to using app indexing is that Google will naturally scan all of your web content and index it and make it easily searchable. But you can use app indexing to get content in your mobile apps indexed as well. So all you have to do is write a few simple rules to say how your web content maps into your mobile content, and app indexing will now let users do searches and link directly into your mobile app, deeply into the recipes that they're looking for. So if they're on Android, they go to the Android app, iOS to iOS, and web to web. So it makes for a much more seamless and easy to use experience. Also, there's a benefit of knowing that usage within your app actually promotes its rankings within Google. So if you have active mobile users, you can be sure that that activity will help the ranking within your overall search results. Now, with dynamic links, one thing you can do is link between the mobile version and your web version. So again, like I said, it's really easy to draw traffic to your website. But what if you want to push people into the mobile app? What you can do is say, if someone's looking at a recipe in the mobile view and you want them to go into your iOS app, simply provide a link on the web page to say, view this on mobile. And when they do that, they can get installed and get right to the content, and you can drive them to a more pleasant experience for their device. My slides are not advancing. Oh, there we go. So again, with invites, you want happy users to refer happy users. But there's another benefit. So with an invite, since they're built on top of dynamic links, what you can do is embed some context in your invites to say, give people a referral bonus, to say, invite a friend, and that friend then gets, say, $5 off their grocery bill. So if you have a deal with a grocery store, you could say, for everyone who invites one of their friends, we'll give them a coupon, and that makes for a great first-time experience and greatly increases your retention. Oh, there we go. So again, with AdWords, just like before, you probably want to hook into search results for things like recipe book and dinner ideas. The Google AdWords integration will definitely help drive traffic to your mobile app. And of course, you want to monetize this thing. You don't want users to use this free forever. I mean, you want them to use it for free, but you need to get paid at the end of the day, right? So AdMob by Google is another Firebase integration. It's the same AdMob that you already know that's been monetizing great apps for years. And now it works great with Firebase. And there's one new feature in AdMob that you should know about. It's called Native Express. And what it lets you do is include ads in your app that match the look and feel of your app. So this is great for putting ads in scrolling lists. So if you have an ad in a scrolling list that looks like the other items in the scrolling list, I think users are more likely to notice it, click on it, and then that should drive more revenue to your app. So this is pretty exciting. Developers have been asking this for a long time. It's also great for games, right? Games have their own very distinct styling, and if you can put ads in your game that match that styling, it creates for a less jarring experience. And of course, analytics, again, the thing that ties it all together. You can measure the efficacy of your invitations, your dynamic links, your AdWords, and eventually, we hope that analytics will have even better and tighter integration. So I highly recommend you look at analytics. You can, over at the Firebase tent, we have demos of analytics, and you can talk to people who are very knowledgeable about this. Now, I've gone over 13 components. I promised 15. That means there's 2 left. My counting is very good. I took math in school. So what's missing here? Well, the 13 components I've talked about are great for adding features and functionality to your app, but there's 2 more things left. And what we can do with Firebase is also test our app. So with Firebase, we have Firebase Test Lab for Android. With Firebase Test Lab for Android, you can test your app on actual devices hosted in the cloud. So with Firebase, we own the devices. Google owns them, manages them, and you can test on them. Now this is great because if you've ever done Android development, you know that you could end up with stacks of mobile devices on your desk. And I had this problem too, where I had a cabinet full of devices, and the team I was working with, they would constantly go in there, grab devices, they would get lost, you could never find the thing that you wanted, you had tangled cables on your desk if you were testing on different devices. This is a terrible situation. You should abandon that and just do testing in the cloud. So we have phones, small tablets, large tablets across a variety of OEMs. They're always ready and waiting for you to do your tests. And so if you're an Android developer, you probably know you can write instrumentation tests as a way to sort of like script the interactions with your app. And you can run those on your desktop. But again, that's not scalable. If you have instrumentation tests, you can deploy those to Firebase Test Lab. And we'll run those instrumentation tests against the set of devices you selected. And then we run them concurrently. You don't run them in order, we run them concurrently. So you get very fast, very comprehensive results immediately. Now, if you're not into writing unit tests, and who is, writing tests isn't fun, you can also have an automated test like crawl your app for you. And we call this a robo test. Now this little robot here, there's no actual robot poking and prodding your app. This is sort of like an artist's imagination of what a robo test is like. But with a robo test, what happens is we have software that looks at the UI widgets in your app and fills in text fields, pushes buttons, selects drop-downs, goes through menu items. It tries to discover everything in your app. And if there's a crash, you'll know about it. It also takes screenshots along the way so that you can know that everything is rendering properly on the set of devices you selected. Now this is an actual device rack. We had a photographer come in and make some very nice photos. This sort of demonstrates how, much like a server farm, we can have device farms now. So I really want to visit the device lab someday. I haven't been there yet. We have one on Google campus and one in Atlanta. I think this is fascinating. We have a sort of a light version of that over in the Firebase tent. So if you want to see what a rack kind of looks like, we have a demo for you to see. And lastly, there's also a crash reporting component. So you can do all the testing you want on devices in the cloud, but inevitably users will find some problem. So you can use Firebase crash reporting to observe and triage those crashes. So they'll be grouped by type. There's a clustering algorithm where you can see similar crashes, and then we'll order them by severity so you know which ones to tackle first. And this should help your overall app quality. Now, the way I see Test Lab and crash reporting working together is that during development, you'll make use of Test Lab in the cloud to make sure that all of your tests are working as planned. Then for Android, when you publish to an alpha or beta channel, there's another test that's run. We call this a pre-release report. And this is a very simple robo test. And what this will do is give you kind of a quick check to see, is my app actually launching and working OK on a variety of devices. And then, of course, your alpha and beta users could then, if they experience crashes, that will report back into the dashboard, and you can use that to create new tests to make sure that you fix those properly. And then when you promote your app from alpha or beta to production, you then have actual live production-grade crash reporting. So this is a great way to ensure app quality throughout your development lifecycle. So that's all 15 components. Again, you can take as many of these or as few of these as you want. I'm a big fan of using as many as possible, especially for new apps. Now, I understand that established apps may already have solutions for some of these in place, and that's fine. You can keep using them. But if you want to replace anything, that's fine. Or if you want to create a whole new app on top of Firebase, that's great as well. I've been very excited to talk to developers who are going to build whole new things on top of Firebase. Now, one of our early access partners, Malang Studio, had some very specific things to say about it. So here's what they did. They built 3 apps. Chew Day, which is an anniversary app, so it helps couples plan an anniversary day. There's Me Time, which is a diary app. And there's School of Rock, which is a school lunch app. Now, some of these, I believe, are not in languages that are English, so beware that if you download one of these, it may not make sense, but you can see Firebase in action. Now, what they did is they showed us this chart of how they used Firebase. And you can see across the board, they are making heavy use of Firebase, and they loved it. So the more solid icons or components they definitely integrated. The more faded out ones are ones that they're planning on in the future. They just didn't get to it yet. But they were excited to tell us about how well they were able to use Firebase, that they gave us some quotes. The CTO of Malang Studio said, "I feel that recent mobile development is similar to putting Lego bricks together. Too often, some of the bricks don't fit well, and a few even become problematic. But from what we experienced, Firebase feels like the genuine Lego brick set that guarantees compatibility and stability." Now, I love this Lego brick analogy. This is exactly how we intended Firebase to work. We give you these components that you can build up your app, create an infrastructure that you don't have to create. You can focus on your user's experience. And their CEO went on to say, "Our main goal has always been about creating products that people actually use rather than product craftsmanship. So we used to concentrate all our efforts on our core competencies and borrow competencies in areas where we lacked a cutting edge. Google has gifted us with Firebase, which has been a complete package for what we used to borrow." Now, what he's saying here is, as an app developer, you might have to pull in all these different components and sort of assemble something from a bunch of other components. But with Firebase, you get one thing that gives you all of the core, all of your infrastructure that you need. Once you have that infrastructure in place, you don't have to worry about server farms or scaling up or creating revenue or drawing users into the app. All of that is there. You can focus on the app and your users and the experience they want to have. So that's all I have. If you want to learn more about Firebase components, there's another talk here at 3 p.m. Todd Kerpelman will talk about how some of the individual clusters of components work really well together. I like this talk. I like the idea that these components are like Lego bricks. So he'll provide that Lego brick experience. If you have any questions about Firebase, visit any one of these URLs. If you want to get deeper into it, there's a code lab called Friendly Chat. And with Friendly Chat, you'll actually walk through the integration of like 7 or 8 of these components and see how they actually work. And then there's Friendly Picks, which is an actual live app, which will demonstrate a lot of Firebase features. So I'm really excited about Firebase, and I can't wait to see what you build. Thank you very much. Now we have...
Hello, I'm Timothy Jordan, and you're watching the Day 3 livestream of Google I/O 2016. Stay tuned for more sessions on all 4 livestream channels for the rest of the day. We'll also be on the ground and behind the scenes finding the coolest and most innovative things to share with you right here on the livestream between sessions. And if you want us to track someone down with your questions, use the hashtag AskDevShow.
One word that's the bane of both the novice and expert programmer alike: threads. I'm Joanna Smith, and threading can be one of the greatest perf improvements you make, but it will also likely drive you crazy. Tom Sawyer illustrated threading perfectly a long time ago when he needed to paint that fence, because when you've got a large chunk of work to do and it's the same work over and over again, you call in some friends to get it done quickly. So for computations that are taking a long time, consider calling in reinforcements with threads. By allowing multiple threads of execution to operate on your dataset in parallel, you reduce the overall time required to complete the task. With Android, threading becomes especially important because the entire app runs on the main thread, which is also called the UI thread because it updates the UI. And when the UI stops responding, users stop using your app. So, When you want to perform some complex action in response to a button being pushed, for example, you'll want to move that off the main thread until it is finished so that the user can continue to interact with your app. Because there are few things worse than the dreaded application not responding dialog. However, integrating threads into your system is not for the faint of heart. You're going to have to rethink your entire approach to computational complexity and to your memory model in order to properly integrate threads. So, to avoid the rabbit hole, take advantage of the Android framework, which has been built to help you out. Careful thought and planning about your app's structure and flow will enable you to determine whether a thread should affect the UI or be entirely hidden. APIs like async task and thread both help you manage the work and keep your app from hanging, but async task will also allow you to affect the UI, like when you want to display a progress dialog. So take a walk through your own app and see if there are places where it stops responding or gets exceptionally slow in response to a user action, and then move all of that extra work off the main thread. But, thoughtfully. Don't just change things willy-nilly. Because while threading may be intimidating, it shouldn't scare you. What is scary, though, is bad performance, which is why you should check out the rest of our Android performance patterns content and consider joining our G+ community for tips, tricks, and help. But most importantly, keep calm, profile your code, and always remember, perf matters.
Where are we actually?
Okay, glad you asked, because I did think a little bit further than you, since you've started driving and you've no idea where you're going. I thought since we went to the Boozer in England, we could this time continue the trend, but go to a vineyard.
Ooh,
yes.
That's...
Keep it classy. See now, look at this, right? I kind of feel like, yeah, all right, like we did the pub before back in England, but I do think this is a slightly better view.
How qualified do you feel?
Not at all.
Yeah,
I know you're going through this. I know it's red or it's clearish kind of colour.
It's nice and it's not nice. It's one of those very binary with my wine tasting.
And I have an upper limit of about £5 or $8, and if it's more than that, it's probably not worth it.
Anyway,
right. So since we're here,
yes.
we tend to talk about the web, and today I think is no different. I want to talk about libraries and frameworks.
Ah, yes, because you're not big on the frameworks, are you?
No, and neither are you.
And on the other hand, I am not big on the frameworks.
Yeah, so I don't think there's going to be much of an argument, but I do want to talk about it because it bothers me that I perceive that the default state of developers is, I've got a blank page here, how am I going to fill it out? I need a framework. Which one do I use?
That is a problem I have with frameworks, that they have a way of starting projects. Like there's a kind of expectation to use them from the offset. And I think if you're thinking, what combination of frameworks should I use to render this blank page, then I think something has sort of gone wrong. Yeah. For me, it's entirely from a performance point of view. Well, no, it's not actually. But okay, step one, performance. If your page has to load a ton of JavaScript in order to make a request for the actual data it's going to display, you've lost performance.
Yes.
And you can sort of say, oh, but next time it's going to be cached. It might not be. You might have changed the code, busted the cache.
And it's an assumption that somebody's going to come back again. Right?
Well, it's your goal, I would say.
It's your goal, but you don't know that somebody's going to. It's like paying a big, fat, hefty tax on the assumption you're going to get a repeat view. And
That's
you
true.
might not.
That is
you
true.
might not.
Yep. And stuff falls out the cache all the time.
Yeah, exactly. So
not the service worker cache, though.
Oh, you and service worker. Here we go again.
Service worker!
Da, da, da. One trick pony, Jake Archibald.
Come on, but it's got a cache, you can rely on it.
All right. Okay, performance that notwithstanding, I think for me, it's about code ownership somehow. It's about a level of trust that I don't necessarily feel. And what I want to do is I want to be able to feel like my application code is the thing that's running, that I'm not running through something else that I don't necessarily understand.
Running through something else is fine, because that's what a library is, right? Like you've got you've got hold both ends, and you're running through bits of library that you don't understand.
Yeah.
But that's fine, because if one of them starts misbehaving, rip it out, either code it yourself or find a replacement library.
But when you're going through something else,
you're in something else, I think, with a framework. And the framework will vend you little bits of, it'll give you scraps, and then you do something.
Can I have some more? I'd like to work with this application.
Can you please send this data over
here? Get out.
But then the frameworks, you're sat in a tiny bubble of the overall application with a framework, and I feel like to get the most out of a framework, you need to understand how the framework is built. Like, and these frameworks are huge, so it's
They
really
are.
difficult to do
I actually feel maybe this is wrong, but it feels to me like it's a kind of, the decision is an ergonomics one. Like a developer's saying, my ergonomics trumps the user's requirements. I want to feel like, my job is easy, and what the user gets is what the user gets. And my whole approach is very much the other way. I'd rather go the extra mile and all my users benefit than my life is a bit easier and I'll take some of the bad performance or the tax of using that framework. So I don't think that frameworks are inherently evil and to be avoided, but I think you want to be able to transition to one and say, yeah, now it feels like we're getting to the point where we're going to reinvent that. And I think you can only do that when you've got to a certain point with the build.
So for you, it's start light, start with libraries as when you need them, and then make the jump to frameworks only if you have to.
Agreed.
Hi there, I'm Timothy Jordan, and I'm glad that you're still here on the Google I/O 2016 live stream. Stay here between sessions because we're going to have great conversations like this one with Jamal Eason, a product manager on Android Studio. Jamal, Android Studio 2.2 was announced and launched today. Can you give us the highlights? What are the changes from Android Studio 2.0 that are going to make the most difference in a developer's experience?
Well, there's three key things. First, we talked about new testing tools, and so the new test recorder is a really amazing feature, got a lot of excitement from the developers.
Yeah.
Number two is about the new layout editor. So it actually introduces a new layout. So instead of worrying about all the different nested layouts, you have one flat layout that's actually more performant and more dynamic. And number three, enhanced C++ support. We've already had great editing support already. Now we support hybrid debugging and support for NDK build and CMake builds.
That's really great. I think one of the things that we've been hearing from developers for a long time is more C++ support. It gives them a stronger ability to build cross-platform and make sure that that code that they're building can apply more to their Android apps as well.
Absolutely.
Yeah. In fact, especially game developers have been asking that as well. I can't wait to see what they'll do with it.
Absolutely, yeah.
So what are the next steps for Android Studio?
Well, today is the preview release.
Okay.
And so we're looking for people to download today and give us feedback. And so as we typically do, we have a canary release today, and we'll soon launch a stable release this summer. And in that time period, we're looking for feedback from developers about what they should use and what they like about the product.
Great. Is there anything else that developers should do besides downloading Android Studio 2.2 and giving us feedback?
I think that's it.
That's it. Jamal, thanks so much for joining us today.
Not a problem.
Where are we actually?
Okay, glad you asked, because I did think a little bit further than you, since you've started driving and you've no idea where you're going. I thought since we went to the Boozer in England, we could this time continue the trend, but go to a vineyard.
Ooh,
Yes.
that's...
Keep it classy. See now, look at this, right? I kind of feel like, yeah, all right, like we did the pub before back in England, but I do think this has a slightly better view.
How qualified do you feel?
Not at all.
Yeah,
I know you're going through this. I know it's red or it's clearish kind of colour.
It's nice and it's not nice. It's one of those very binary with my wine tasting.
And I have an upper limit of about £5 or $8, and if it's more than that, it's probably not worth it. Anyway, right. So since we're here,
yes.
we tend to talk about the web, and today I think is no different. I want to talk about libraries and frameworks.
Ah, yes, because you're not big on the frameworks, are you?
No, and neither are you.
And on the other hand, I am not big on the frameworks.
Yeah, so I don't think there's going to be much of an argument, but I do want to talk about it because it bothers me that I perceive that the default state of developers is, I've got a blank page here, how am I going to fill it out? I need a framework. Which one do I use?
That is a problem I have with frameworks, that they have a way of starting projects. Like there's a kind of expectation to use them from the offset. And I think if you're thinking, what what combination of frameworks should I use to render this blank page, then I think something has sort of gone wrong. Yeah. For me, it's entirely from a performance point of view. Well, no, it's not actually. But OK, step one, performance. If your page has to load a ton of JavaScript in order to make a request for the actual data it's going to display, you've lost performance. Yes. And you can sort of say, oh, but next time it's going to be cached. It might not be. You might have changed the code, busted the cache.
And it's an assumption that somebody's going to come back again. Right?
Well, it's your goal, I would say.
It's your goal, but you don't know that somebody's going to. It's like paying a big, fat, hefty tax on the assumption you're going to get a repeat view. And
That's
you
true.
might not.
That is
you
true.
might not.
Yep. And stuff falls out the cache all the time.
Yeah, exactly. So
not the service worker cache, though.
Oh, you and service worker. Here we go again.
Service worker!
Da, da, da. One trick pony, Jake Archibald.
Come on, but it's got a cache, you can rely on it.
All right. OK, performance that notwithstanding, I think for me, it's about code ownership somehow. It's about a level of trust that I don't necessarily feel. And what I want to do is I want to be able to feel like my application code is the thing that's running, that I'm not running through something else that I don't necessarily understand.
Running through something else is fine, because that's what a library is, right? Like you've got you've got hold both ends, and you're running through bits of library that you don't understand.
Yeah.
But that's fine, because if one of them starts misbehaving, rip it out, either code it yourself or find a replacement library.
But when you're going through something else,
well, you're in something else, I think, with the framework. And the framework will vend you little bits of, it'll give you scraps, and then you do something.
Can I have some more? I'd like to work with this application.
Can you please send this data over
here? Get out.
But then the frameworks, you're sat in a tiny bubble of the overall application with a framework. And I feel like to get the most out of a framework, you need to understand how the framework is built. And these frameworks are huge, so it's
they
really
are.
difficult to do
I actually feel maybe this is wrong, but it feels to me like it's a kind of, the decision is an ergonomics one. Like a developer's saying, my ergonomics trumps the user's requirements. I want to feel like, my job is easy, and what the user gets is what the user gets. And my whole approach is very much the other way. I'd rather go the extra mile, and all my users benefit, than my life is a bit easier, and I'll take some of the bad performance or the tax of using that framework. So I don't think that frameworks are inherently evil and to be avoided, but I think you want to be able to transition to one and say, yeah, now it feels like we're getting to the point where we're going to reinvent that. And I think you can only do that when you've got to a certain point with the build.
So for you, it's start light, start with libraries as when you need them, and then make the jump to frameworks only if you have to.
Agreed.
So service workers are powerful for offline caching, but they're also really good for giving you instant loading performance benefits when it comes to repeat visits.
Yep.
Right? And you can achieve that using an application shell architecture.
Yeah.
Now,
so that's kind of the idea of kind of separating content from the actual visual UI. So in my head, it's kind of like native apps. You always have the banner, you've got the navigation drawer at the side, you might have some other bits. That could be common through like 90% of your app.
Yeah.
You always want it there.
So when we talk about the shell, we're talking about the HTML, the CSS, and the JavaScript that's making up the bulk of your UI.
Yeah,
Stuff that, if you cache that, you can still just like load up content in the very middle.
Yeah.
And save yourself having to constantly reload that stuff, right?
Yeah, and it's super nice when it comes to like, let's say they're visiting a page they've never been to before. If you know the layout's always going to be the same, you can still load that while you go and get the content in the background.
And it just makes sure that your user has like really good perceived performance.
Yeah.
So the first time your app loads, you're going to have to render the shell itself. You'll cache that in your service worker, and you might show like a toast just to let them know, hey, this application now works offline.
Yep.
And that means that when they come back another time, like let's say they're in airplane mode, that shell will load up really, really quickly, and then it might go to the network to fetch the rest of the content. You can then cache that content so that that entire view is then available whenever they try accessing it without a network connection.
Yeah, exactly. Spot on.
We've got some performance testing we've done with the application shell model. This is using web page tests. So on first visit, we've got a relatively fast time to first meaningful paint.
And this is super important because I think that there can be scenarios where someone might take advantage of Service Worker to be like, don't worry about your first load, but I'm just going to serve up like megabytes of stuff that I'm going to cache. Afterwards, you'll be super fast. But that first load, if that takes so long to the point where the Service Worker doesn't even get registered, that's pointless. And plus, for other browsers that don't support Service Worker, you're then kind of just damaging yourself.
Yeah, that's going to make your users go and cry in a corner.
Exactly.
You don't want that.
So you still want to be serving up just that static render of your site, just so then it just loads up as fast as humanly possible, and then progressively enhance with Service Worker to then use the app shell model.
And if you are using the app shell model, as you can see here, we've got really good, we've actually slashed our load times for first meaningful paint on repeat visits. Speaking of like actually taking a look at what impact server-side rendering has on this, you don't have to use Service Worker to actually be able to get good gains. If you're building with the app shell model in mind, with server-side rendering in mind, you will get like a really good first paint, even in like Safari and like mobile Safari on iOS.
Yeah, all the other browsers that just don't have Service Worker.
Yeah. Now, if you're wondering, okay, well, should I be using the application shell model on all of my applications? There are going to be types of apps, like super simple apps. This might be overkill.
Yeah.
But if you're building something that's a little bit more complex, a little bit more dynamic, this type of model makes a ton of sense. At Google, we're using it for things like Inbox, and it's working really well there.
Yeah, I think it's one of those things you end up falling into the sit there and figure out whether it makes sense for your site or not. But I think it's a good overall model that works for a lot of different scenarios.
There's a whole ton behind this model that we way too much to explain in just one video, but we wrote up a pretty amazing article on this, if we do say so ourselves.
Well, you wrote it up and I just read it. So
you just added your name to the end of it.
Yeah, that's how I roll.
Pretty much. Impact. That's worth checking out.
That's the format of this show.
It's a mediocre article at best, but it's got pretty graphics.
Yes, it does.
People should go check that out.
Yep.
Learn more about App Shell.
And then there's also the Getting Started guide for your first progressive web app, where it actually talks about the application shell model, how you can take advantage of it, as well as how it applies to the demo app that you can build in this lovely code lab.
Yep. And in that article, we also link out to tools that can help you get started with the application model really quickly that we're working on. So check that out.
Yeah, build a weather app.
Firebase makes authentication easy for end users and developers. Most applications need to know the identity of a user so they can provide a customized experience and keep their data secure. Firebase supports lots of different ways for your users to authenticate. If your users want to authenticate with their email address, you can build that for them. Firebase Auth has built-in functionality for third-party providers such as Facebook, Twitter, GitHub, and Google. It can also integrate with your existing account system if you have one. You're given the choice about how to present login to the user. You can build your own interface, or you can take advantage of our open source UI, which is fully customizable and incorporates years of Google's experience in building simple sign-in UX. No matter which one you use, once a user authenticates, 3 things happen. Information about the user is returned to the device via callbacks. This allows you to personalize your app's user experience for that specific user. The user information contains a unique ID which is guaranteed to be distinct across all providers, never changing for a specific authenticated user. This unique ID is used to identify your user and what parts of your backend system they're authorized to access. Firebase will also manage your user's session so that users will remain logged in after the browser or application restarts. And of course, it works on Android, iOS, and the web. That's Firebase Auth, allowing you to focus on your users and not the sign-in infrastructure to support them.
Hi, I'm Timothy Jordan, and this is The Developer Show on location at Google I/O 2016. And I'm here with Noah. We're going to talk about Project Tango. I'm still overwhelmed by how cool Project Tango is.
Absolutely, blurring the lines between the real world and the virtual world.
Now, there is a Project Tango game that people are playing with here in the sandbox called World. Can you tell us a little bit about it?
So this is a game that's being done by a new company called Phenomena, but with some very old and experienced game developers, including a designer called Keita Takahashi. He worked on a game called Katamari Damacy. And
it's an awesome game.
Oh,
Played
just great stuff, you know, but very playful approach. And he's brought that to World. It's a game where you can actually set up little things in a virtual world that are situated in the real world. So as you move around with the Tango device, you can actually see them from different angles and set them up on the real walls and floors of your room.
Now, you were telling me a little bit earlier about the first steps you take into the game. What is that like?
Sure. Well, at the beginning, one of the things that you do, for example, is you're given a little seedling, and you can plant that in the ground, and then perhaps on a nearby wall, you can take a cloud, but the cloud is actually on a spring, so you put it on the wall, and it goes boing, 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 and you can click on the cloud, and it starts raining, and suddenly the seed will sprout and turn into a flower. So it's stuff everybody understands intuitively, but then you can play with the stuff, put the flower on top of another flower, have them start rotating, make them bigger or smaller. The whole thing just sort of opens it up as a playground for you to try.
Something I've heard you talk about before, which I really love with Project Tango, is the ability to make any space a play space, which seems to be evident in this game.
So one of the great things is that you can use the Tango device to actually have it be a sort of a magic window into a virtual world that you create or that's been created by the developer, so that as you move it around, it's as if you're seeing right into this other space that isn't even there.
That's really cool.
It's great stuff.
One more general question for you. What is your favorite thing about being a game designer and developer?
Wow, I think the best thing about being a game designer is that you get to make things that you enjoy, that are fun, that please the rest of the world. You know, it's pretty much like other entertainers, just a lot more nerdy than being a rock star, for example.
Awesome. Thank you so much, Noah.
All right. Thank you, Timothy.
Hey there, Polycasters. Rob here. Welcome back to the show. As we've been working on Polymer, one of the probably biggest requests that comes in from developers is, when are we going to get a CDN for Polymer and for web components? Because it's kind of a pain in the butt every time you want to sort of like hack on an idea, and you've got to use Bower and install a bunch of packages and wait for everything to download just so you can, you know, play with stuff. So recently, the Polymer team has put out a brand new project, which is called PolyGit. It is a development CDN, which I'll talk about what that word means in just a second. But basically, it is a CDN that includes Polymer, all the Polymer elements, and the web components polyfill. So if you want to hack around using something like JSBin and Polymer, you can totally do that. So if you go to the website polygit.org, you see that it bills itself as the Polymer Magic Server. And what it's actually doing under the hood is it's just using GitHub's rawgit CDN and extracting things from there and pulling them into, you know, JSBin or wherever you want to use the CDN. So what I want to do here is just sort of like show you some examples of how you can use the CDN, how you can configure it to actually pull in your own packages as well, and basically just get hacking really quick. So over on jsbin.com, I've already set up this little sample bin. And the main thing to notice here is I'm using this base tag right here. And if you're not familiar with a base tag, in HTML, a base tag or a base element, it just allows you to set a URL. And then any sort of subsequent URLs that you use, like for script tags or imports, they will all be relative to that base. So what we're saying here is we want the base URL to be polygit.org/components. This components directory is where Polymer and all the Polymer elements and all that good stuff lives. And from here on out, if we have any relative URLs, it'll just pull stuff from that directory. So I'm pulling in web components.js. It's coming from that directory. I can import polymer.html. That'll also come from that directory. And so since we've got all this working off of our CDN, now we can actually sit here if we want. We can just create our own Polymer element right on JSBin. So I'm going to do that right out of DOM module here. I'll give it an ID of like xfoo. And I'll give it a template that just says like, hello from xfoo. And I'll also give it a little script tag. And inside of here, we will call the Polymer constructor. And we're going to say it is an xfoo element. And then the last thing we want to do is we want to just make sure that we use our xfoo tag somewhere in the page. And now you can see it showing up over there in our output. So this is really great if you're, hanging out on the Polymer Slack channel, you run into a bug or some issue and you're not quite sure how to explain it to folks. You can just go throw together a JSBin using PolyGit and then share that JSBin with people so they can help you get unstuck. Now, I also mentioned that all the Polymer elements that we built are included in this CDN as well. So what you can also do if you find maybe a bug or an issue with something like paper tabs is you can go over here and you can just write an HTML import for paper tabs. So instead of just Polymer, I'll also pull in paper tabs. And then you can just start using that element in your page here. So I'll say I want a set of paper tabs. And then inside of here, I will write out maybe like 2 or 3 paper tabs. So we'll say this first tab is called foo. Second one is going to be called bar. And the last one will be baz. Foo, bar, baz. And there we go. Now over here in our output, I've got these 3 paper tabs working just as I was expecting. And if I had some issue, I could then take this, I could save this JS bin, I could go file a GitHub issue and point the engineer at this particular JS bin. And that way it's going to help them triage that issue a lot faster and help them debug the actual problem that you're running into and hopefully get things fixed. Now, one of the coolest things about polygit is that it is configurable. So not only does it pull in Polymer and the elements that that team has created, but you can add your own GitHub repos to it as well. So if you go back to the polygit.org website, you scroll down here to the bottom, you can see that there is this sort of interesting configuration syntax. And it might look a little weird when you first see it. It took me a few times kind of working through it to understand what it's doing. But basically, what you want to do is when you are defining that base URL, you can configure it by saying, oh, I would also like to include this component. And this component might live like inside of some particular org. And maybe you want a particular version, like version 1.2.3. Or maybe you want a branch, right? Maybe you want like the master branch. That's some good handwriting right there. Or maybe you want just the latest tag. So if you include an asterisk, instead of pulling a particular version or a branch, it'll just give you whatever the latest tag happens to be. So to show you an example of that, I've again got a little JS bin here. And I'm just going to paste in a better URL here. So what I've done is I've configured polygit to pull in 2 additional dependencies. The first is the markdown.js library, which is in the chjj org on GitHub. And I've told it to grab the latest tag. And I've also told it to pull in the mark-down element, which is something that I wrote myself. That lives in the Rob Dodson org on GitHub. And again, I've just told it to pull in the latest tag there. So now both of those are available in that CDN components directory. So I can just go ahead and write an HTML import to pull in the markdown element. And then over in my body, I can just start using it. So I can have a markdown tag. And we'll just drop in like a hello world for the header there. And we can see we're getting this sort of like huge H1 rendering over there in the output. So if you're working on an element or a project or something like that, and you want to show that to folks on JSBin, you can absolutely do that using polygit as well. The one caveat there is that it has to have been published for at least 1 hour for it to be picked up by the rawgit caching CDN. But once it's been published for about an hour, it should be available to you on polygit. Now, the last thing I want to mention here is at the very beginning of the show, we said that this is a sort of development time CDN. And what I mean by that is it's not a CDN that you want to use for production. And the reason is because we're not doing any sort of like vulcanization or anything like that to optimize the elements that we're sending down. Instead, you're getting an individual dependency for everything that you import, which is actually pretty expensive in terms of HTTP requests. So it's great for development time. It's great for hacking on ideas. But when you get to the point where you want to launch something into production, you still want to use a package manager like Bower. You still want to use a process like Vulkanize to make sure you're sending down the absolute smallest payload possible. But if you just want to mess around with some ideas, it's perfect for that. So that about covers it for today. If you have any questions, please leave them for me down in the comments. Or you can always hit me up on a social network of your choosing at #AskPolymer. As always, thank you so much for watching, and I'll see you next time.
Welcome back. We've covered a lot of ground already, so today I want to review and reinforce concepts. To do that, we'll explore 2 things. First, we'll code up a basic pipeline for supervised learning. I'll show you how multiple classifiers can solve the same problem.
Right. Hello and welcome everybody to our Recycle View Ins and Outs talk. I'm Yiğit Boyar from Android UI Toolkit team.
And I'm Adam Powell, also from the Android UI Toolkit team. So we can go ahead and get started with kind of a brief history. Recycler View is meant to be a widget that succeeds List View, which a lot of you are probably familiar with at this point. List View has been around since Android 1.0, and it's meant to handle repeated structure in consistent content. And more specifically, it was made to handle this sort of repeated structure in some very simple settings. So as you can see here, we've got our old settings screen from Gingerbread. And this was already kind of after a lot of extensions to what List View was meant to do. And sometimes the content isn't so consistent. So you've got different view types floating around, so on and so forth. And we just kind of kept adding features. But the core problem that List View meant to solve is how do you make it fast when there's a ton of items, hundreds, thousands, possibly more. Creating views themselves can be really expensive, especially on old devices back in Android's early days. And memory is limited, so you can't just necessarily create tens of thousands of views and deal with that all at one time. And the answer is we cheat. So with List View, we do a trick with some smoke and mirrors. And really, anyone who works on UI development has a lot in common with stage magicians. Stage magicians use misdirection and other sorts of tricks on stage to make you think that you're seeing something that you're really not. And if it looks right, it is right. So, I mean, what they're seeing is the UI in terms of what the user believes. So the trick that we use is that we only create and lay out the views that the user can see right now. And as the user scrolls, we continue to lay out more items. The image you should have in your heads right now is that bit from Wallace and Gromit where you're quickly laying the track in front of the moving train. So that's basically how List View works. And in order to enable this, List View uses adapter components. Now, this is a component that's provided by the application itself. And it's used to create and populate the item views on demand. You've got this getView method in the adapter that is used to query the adapter for a particular view to show a data item that corresponds to a particular position in the list. And the extra trick that we do there is we also pass in a special convert view that's guaranteed to be of the same item type that the adapter believes that new position to be, so that you can reuse the same view and you don't have to pay the cost of inflation again. And over time, we continued adding more and more features to List View because they were things that people needed in their apps. And this question kind of came up a lot. So List View grew feature after feature after feature. And you can go back and watch this talk from I/O 2010 if you want to see a few of them.
Watch that talk. It's really nice. You should watch it. I enjoyed it.
Yeah, if you want to see some of our classic UIs and some of that talk as well, yeah.
It's nice.
But really, as we kept adding features to List View, we kind of hit this complexity overdraft point. We had so many features that kind of sort of interacted with each other, but not really. All of them a little bit one-off. And it was just all of these long-tail features that led to a lot of very strange interactions. And what that meant in practice is that everybody wrote their apps such that things worked how they wanted it to, but a lot of times those things were really just kind of the result of undefined behavior in List View's implementation itself. And once enough apps start doing that, then that's de facto API that we have to support. Any small change that we make to List View's behavior that might improve it for some of these core use cases ends up breaking some app's really hero use case that they want to use someplace else. We also had a lot of duplicated functionality in List View. Like List View selections or view focus, which ones do we use? I mean, the view hierarchy already knows how to handle things like keyboard focus as you navigate around, but List View had its own completely separate idea of this in terms of the current selection, a selector drawable that's drawn either behind or over the views, depending on what configurations that you set up. And this led to a lot of overlap. And not only that, but it meant that when you start using more complex views in your List View items, you kind of have to switch over to this set items can focus option that disables List View's internal selection handling and lets you use the view hierarchy's focus handling instead. Similarly, we had the same issue around item click listeners versus view click listeners and other sorts of general touch handling. So list view provided this very nice convenience where you could set an item click listener on the list view itself and get clicks for anything that happens in that list. Now this makes a whole lot of sense for lists that are really uniform, where you have a list of items and you just want to pick something from it, kind of like the pop-up menus that we have from the overflow menu up in the upper corner of your apps today. But alternatively, you can also just go ahead and attach click listeners to these views themselves. And which one was going to handle the events was sometimes not always clear or intuitive. So people would ask us a lot of times, which one do I use? And the answer always ended up being, it depends. It was like, OK, well, how complex are your list items, so on and so forth. And anytime that you have to answer a lot of those types of clarifying questions about, like, OK, well, what are you trying to do? Then that really kind of complicates the developer story. But really the big thing that kind of kicked off the whole recycler view effort was that list view animations are really, really difficult. And the core problem is that adapters don't tell us enough to do them smart. So when you change an adapter, you say notify dataset change, and the assumption is anything could have changed. We're not entirely sure what, and we're just going to go ahead and rebind all the items that are currently visible and go from there. And over time, we had a few prototypes. Some of them were done by members of the team. Some of them were done by members of the community, all to try to show items animating in and out as the data set changes, and do so in a way that's kind of intuitive. But all of these had some really major limitations. Most of these had to do with, again, the internal implementation details of list view that apps had really come to rely on. So we couldn't fix these things to make these animations possible. So eventually, you just end up making this face at list view.
Yeah, look at the regret in his face. Like, I'm doing this thereby, but I'm not really sure if I should do this. Like, I'm going to regret this. I have to do. Like,
yeah, Chet wears this face a lot.
Part that comes with the framework.
Right. And again, another one of these problems that we had with list view was just this duplicated functionality.
The duplicated slide.
What is?
Perfect. You had the slide.
Yeah, I guess we did, didn't we? OK. So as we moved on, people started using much, much more complex layouts in their list view items. We went from something like that very simple settings screen in Gingerbread to suddenly people are showing items from a full social stream, items with many different components to them, with many different points of interaction. So these simple grids and lists that we provided with list view and grid view in the framework really weren't enough to handle these use cases appropriately. People started wanting to create these sorts of staggered grids, responsive layouts, so on and so forth. And really, if you wanted to change these types of layouts, you were rewriting a whole lot of core code that list view used to do this adapter-based recycling. So if we had a do-over, what would we change? Well, one of the things that we wanted to do was to elevate the best practices of working with list view to first-class API. We had this view holder pattern that Roman and I went over in the World of List View talk, linked earlier in the talk here. And the nice thing about the view holder pattern as it existed for list view is it gave one point where you could sort of collect a bunch of attributes about a recycled view that you were going to work with and have that single point of access. You could kind of cache a lot of these find view by ID calls that you would make to an inflated view subhierarchy. And especially on older devices, that made a big difference because you were doing fewer traversals. And as you were creating more and more complex item layouts, it mattered even more. So we thought, OK, well, let's go ahead and just make that part of the core API. Like, let's go ahead and instead of having this just be a best practice that everybody has to read some blog posts to figure out about, let's go ahead and make sure that this is something that you see as soon as you read the documentation for working with Recycler View. We wanted to separate view creation and binding. Now, this was something that happened in the cursor adapters that many of you have probably used if you worked with SQLite databases or content providers as your backing data source for your list view adapters. We separated out an onCreate versus onBind step in those. But if you were just writing a raw list view adapter yourself, then this was essentially a question of the very first couple of lines of code in your getView method where if convertView equals null, create a new thing, and then sort of fall through and do the binding there. And this was one of those things that was fairly easy to forget to do. And if you forget to do it, then that means that you entirely lose out on this recycling mechanic that ListView gave you to really kind of boost your performance. Sometimes it wasn't really clear why this was happening from the outset. And next, we really kind of wanted to throw out a bunch of this selection handling that really only made sense for these very simplified lists and just rely on the framework's normal focus and input handling. Because this was, this again just kind of comes down to simplicity of working with the rest of the framework and kind of reinforcing the consistency of working with the rest of the view hierarchy. And then selfishly, we also wanted a little bit more easier maintenance on our end, because I don't know if any of you have taken a look at the internals of ListView in AOSP. I'm pretty sure that it could be used to scare small children. So we wanted to keep the core universal. So all of those things that were a total pain to rewrite yourself if you tried to write your own recycling container, we wanted to have a way to give that to developers more or less for free in a canned form so that they didn't have to sort of rediscover all the things that we had to do the hard way. And we wanted to make sure that you could still implement all of these other long tail features that ListView just kind of provided as API on ListView itself as other plugins that we could sort of share and mix and match to get the experience that you wanted. We needed smarter adapters too. Again, the problem with ListView adapters is that you could say, notify dataset changed. OK, what changed? And that was about all you knew. And this makes animations really difficult. We'll get to that a little bit further on down the line. So recycler view adapters tell us what changed, not just that something changed. Now, if you're working with a data source that doesn't provide that sort of fine-grained messaging, then you can still use the old ListView style, hey, something changed, go figure it out. We'll make some best effort attempts at dealing with it, but really, if you have any knowledge of what the specific changes in your data set are, you can get a lot better results. So this also means that we can do more efficient recycling, not just animations. If we know that only a particular item in the adapter changed, then we don't have to rebind everything that's on the screen. We only have to rebind that one view. And this can save a lot of time in the measurement and layout phases of applying those updates.
All right. So that was born recycler view. So we made mistakes. We learned from ListView. Now, like, OK, how do we write recycler view not to repeat the same mistakes? And the major thing in recycler view is we try to make it a component-based architecture. This is the architecture of recycler view. And we will go through the details of it. I think it's very important. I believe most of you already use it. It's good to know who does what and which one you should use or which one you should customize depending on use case. So we have the recycler view. That's the main view group. There's three major components. There's the layout manager, an item animator, and an adapter. So adapter is provided by you. Layout managers, most of you provide, you can write yourself. And item animator is the same. There's a good default one, but you can write yourself. So layout manager positions the views. Item animator animates them. And the adapter provides the views. And the recycler is the boss. So it's the central location that communicates with all these components to make them work together. So we briefly look at the layout manager. It can be a linear list. It can be a grid, or it can be a staggered grid. It can be anything. Recycler view doesn't know or doesn't care about how the items are laid out. It's the layout manager's responsibility. Or scrolling. Recycler view handles the interactions with the finger, but tells the layout manager to scroll because only the layout manager knows where the views are. So it scrolls the content. Or if you do focus traversal, recycler view handles the basic focus traversal because actually the view framework handles it. But if you are focusing and you need one more item, then it's the layout manager that brings the new item to the focus area because that did not exist before. Or the accessibility. Yeah, recycler view provides basic information about those items, but layout manager is the one that knows, OK, this is a section title. Or you could attach your custom delegate that says, hey, like, do not focus on this. or additional information that only you can provide. And we have a Recycle View accessible to Delegate API for this.
All right. So similar to list view, Recycler View still relies on adapters. Now, a Recycler View adapter's responsibilities are, again, to create the view, but also to create the view holder. And the view holder is what we really use as the tracking element for recycling. So when you're binding an item, you don't just bind it to the view, you bind it to the whole view holder. And this is something that you can use as a place to stash other information as well. And of course, it's the adapter's responsibility to notify the Recycler View about changes that happen to the data set, or if the data is out of sync. So in contrast to list view, where you could use this item click listener type of model for things, the adapter is now responsible for configuring the item interaction handling. So these are all of your click listeners, touch listeners, so on and so forth. Adapters also deal with your multiple view types, sort of being able to keep track of the different view holders that you may be tracking.
And like one tip about the view types, in the list view world, you need to give us how many view types you have, versus in Recycle View, they're unlimited. So I suggest just use r.layout, whatever, as the view type, and then you're done.
Right. So your view type IDs no longer need to be contiguous the way that they did with list view. So if you, as long as you have any sort of unique identifier that you can use to identify a view type, then go ahead and use it, and Recycler View isn't going to care. So that means that you can use this handy trick of using the layout resource ID itself, and since AAPT already guarantees that that ID is going to be unique, it makes a pretty good stand-in for that identifier. Oh, whoops, went a little too fast. So the adapter also deals with things like recycler recovery. So we have this on fail to recycle view concept. So why could something fail to recycle a view? Well, again, we're trying to keep in mind that people are doing more and more complex things with their UIs. And in those cases, you might start making a lot of changes to your views that are very difficult to reverse. So in those cases where we know that a view has been left in kind of an inconsistent state, then we can communicate that back and forth to the adapter so that the adapter is able to sort of recover from a case where a view has been messed with kind of beyond the normal bounds of expectation. And again, we have the granular data change events as added to sort of handle efficiency and
performance.
Totally blank. Performance. That's
Animations.
efficiency. Animations. Yes, that one. All right.
All right. So let's deep dive into the view holder, because everybody needs to write a view holder to use Recycle View, and you spend most of your time there. It's important to know the life cycle of a view holder. So we'll go through it. What happens when we create it? What are the stages? So while the layout manager is calculating the layout, it tells the Recycle View, OK, give me the view for position 5. So it wants to get the view for that position. Recycle View checks the cache. Because we cache the views now, if we already have it in the cache, we will return it to the layout manager. If not, so if we have it, we did return it. If we didn't have it, the cache said no, Recycle will ask the adapter, OK, what is the type of this view? Adapter returns it. Then we go check the pool. This might be a shared pool. This might be the only pool used by this Recycle View. Do we have a view holder for this view type? If it says no, we tell the adapter to create one. So this is when we actually create a view holder. Or maybe the pool returned an item that already exists. Then we tell the adapter, OK, bind this position to this view holder. It returns it, and we give it back to the layout manager. Eventually, layout manager will add it back to the Recycle View as a real child. And then we will tell the adapter, hey, this view has been added to the layout. This is a very good hint for your adapter to know that, OK, user is about to see this view. It's other case where layout manager will say, OK, I'm done with this view, remove and recycle it. Recycle will tell the adapter, OK, I removed this view, let you know so that if you have expensive things inside that view, you can uncache them, you can remove them from memory. And then we will check, OK, is this view valid for this position? If it is valid for this position, we will cache it. The idea is that if the layout manager asks back for that position again, we can give it without talking to the adapter. This is again for performance reasons. And then the cache will evict the oldest one. And I will tell the adapter, hey, we got rid of this view. Now you know that it will not be reused for that position, so you can do even further memory cleanup.
Right. This is kind of an important step that was a lesson learned from ListView, where ListView eventually added this recycled view listener that you could use to track when a view was really no longer in use. And again, because people create much, much more complex UIs in these sorts of recycling containers these days, this allows you to take a step and say, OK, well, instead of leaving these giant, expensive bitmaps attached to these views that are just being held in a cache off screen, let's go ahead and clean those things up, but still retain the core view structure that we had before so that we can rebind it later.
So if the view is not valid, let's say it might be maybe the item has been removed because the adapter told us, or item was changed, and the contents of the view does not represent that position anymore. If it is not valid anymore, we just send it to the pool, and we tell the adapter about it. There's another use case where layout manager recalculates the layout after some adapter changes, and then doesn't use some of the views. So it had all the views from 1 to 5, let's say, and then next one, it only used 8 of them, and the other 2 are missing. So what recycle view does is, OK, we understand that the layout manager doesn't want these views anymore. But item animator may want them, right? You may want to fade them out instead of disappearing them instantly. So what recycle will do is, for each disappearing children, it's going to make them children again, and I'll hide them from the layout manager. We will go into details of this later, but basically, the list of children from the layout manager's perspective are not the same as the children of the view group. When the item animator says, OK, we'll tell item animator, animate these children, and when the item animator says, OK, I'm done with these views, you can do whatever we want, then recycle view will remove them. We will tell the adapter they are going away, and then we will recycle it. So how do we lose a view holder? This is very important, because if you are losing view holder, you will hit performance problems. So the same thing happened. The recycle layout manager said, OK, I want to get rid of this view. Recycle view check, is this view valid? I was like, no, OK, I want to put this into the pool. And the pool checks, does this view has transient state? This is what Adam mentioned earlier. A view having transient state means it's animating. The contents are, we have a button, it's doing some animation. That means if a view is animating, we cannot reuse it for other view holder, because imagine that it was fading out, and then we bind it to something else, and it comes to the UI as faded out. It's like, that's not what you want. You want fresh views.
There are a few other cases that can cause views to have a transient state as well. This is a concept that's part of the framework, not just the recycler view itself. So for example, if you have an edit text widget with a piece of text that the user's entered, and they've gone ahead and created a selection across several words, but maybe not others, then that's kind of this complex interaction that the user has created that we really didn't want to make it the developer's responsibility to sort of track and restore that if that particular item is rebound across other contexts.
So what will happen is that now we cannot reuse this view, and we are removing from the recycle, like the last reference we have to that view is going away. So we give adapter one last chance. Hey, I could not recycle this view. Can I recycle? Because most of the time it's because of animations or selection. You can actually recover from that state. The only problem is that we cannot do it automatically because we don't know what's going on. So adapter can say, either when we call fail to recycle, you can end those animations or clear the selected state. Or you can even say, do nothing, like, I know I fixed these when onbind this call, like, recycle it, I will use it. But if the adapter does not implement this method, by default, it returns false. So we will have to destroy the view holder. So it goes to the dead pool. You don't want this. The moral of the story is, if you're animating items, don't go ahead and create animations on onbind. We have the item animator API to do these things properly. So use the item animator if you want to animate. And the item animator receives the correct lifecycle events so that we can take care of recycling those views when they are done animating.
Right. Essentially, you can forget about everything that just happened on that slide before you, as long as you implement the item animator interface.
Yeah, it's actually
if you're
true.
doing it yourself, you're on your own, and you're going to have to handle all of these problems yourself.
Yeah, and one of the major thing when you start using Recycler, you really need to forget everything you learned in list view. Most of them are valid, but some bits that are not valid will actually hurt you here. So it's another use case where we will lose views. Is Recycler is like, okay, I'm done with this view. We try to put it into the pool, but pool is limited per size per item type. So if you have way too many of those view types in the pool already, we're like, you know what? We have no space for it. Throw it out. So why would this happen? Why would we create views that we already had a lot many of them that are unused in the pool? Well, this usually happens if, right? So if you have too many view holder types, and why would it happen? Is mostly because of animations. Like you told us, I have seen this in Stack Overflow, it made me really sad. We're like, to make it animate, instead of calling notify dataset change, call notify items change from 0 to all of them. So if you say something like this, Recycler is like, oh, okay, for every single visible child is by the default behavior, I have to create another view holder to represent the child so I can crossfade them, because the default behavior is crossfade. That means you duplicate the number of view holders. Of course, when those animations are finished, we try to put all of them back to the pool, and pool's like, no, I don't need this many items, just throw them out. So don't do that. When an item has changed, tell us what actually changed is really, really important. And run the correct animation. Or if you have some other cases where you notice the views are being lost, you can change the type, the size per type in the pool.
So this comes up when you have cases where, again, social streams are a really big use case for this as well. You might have some posts that are very long that fill an entire screen all by themselves, or you might have several posts that are very, very short. And if you have items that are of drastically different sizes like that, then the number of items that can be attached at one time is going to vary pretty greatly. So those are cases where you really want to sort of measure what your app's own behavior is under some of these use cases and tune the size of the view, recycled view pool accordingly. All right. So item animators. Items come and items go over time. And again, we want to use a smarter way of figuring out exactly what it was that changed. So let's say that we add a new item in between H and I in this diagram here. So now we have P in the middle, so no longer sorted. Ignore that. What happens if something disappears? Well, now we have another image of a list. Now, the interesting thing here, and then of course we have the case where an item simply changes, and its contents change in place. So the interesting thing in these cases is that there's always kind of some side effects when you add and remove views. So we added view P here. I and J got moved down, and K is completely gone. When we remove, something really similar happens. So we remove item H, I, J, K, move, but L is new on screen. We had to get a new view in order to show it in that case. So without extra information, change first. And of course, this is one of the easy cases. We can just go ahead and crossfade between these. So if we're handling things this way, if an item's removed, we can fade it out. If an item's added, we fade it in. And if an item's just sort of moving around on screen, we can translate it. And our default item animation handlers can handle this no problem. Changing, we just do a simple crossfade in place. And as long as we don't have cases where that item has changed size, we're in a super easy case. But otherwise, it just means other items around it are moving, and we get into exactly the same cases as before. But can we do better than this? There's kind of a key problem in these cases, which is that if all we know is that something changed in the adapter and here's the new state, like with list view, then how do we really tell the difference between an item that was removed from the adapter after this versus an item that just was knocked off screen and is no longer there? When we're putting together these sorts of animations, this is suddenly really important. Similarly, how do we know if something came on screen because other things moved around it, or if it's actually a new item in the adapter itself? Again, without there being a representation of those views attached to the parent from the outset, we don't necessarily know. So we can do better because now we know this. We know that conceptually, again, coming back to this smoke and mirrors analogy from before, even though we only have a certain number of items attached to the view group at a time, conceptually, we have a lot of items that come before and after what's being shown on screen. So we can get a little bit predictive about this if we're willing to ask the adapter some additional questions, and specifically in conjunction with the layout manager. So as we add this item here, and we have to delete K, in this case, we know that K is still present if the adapter hasn't told us that it's now gone. So we know that it's just sliding off screen instead. Similarly, with removal, we can use the same trick. We can ask the layout manager, hey, show some stuff around what I'm doing so that I have the added context to be able to take the diff of the before and after states and animate it correctly.
OK, I'll speed up a little bit.
Yeah.
So the way this works about the item animator, the predictive animations, is that the recycler view can show a view of the adapter in the past. So how we can do this is like, if you have added new items to the adapter, we don't tell about them to the layout manager because recycler always sits in between. What we do is we show a different view. For example, before we implemented that, there was a layout manager and item animator, and there's a view, and they will always fight. No, this view is mine. No, 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 this view is mine. Like, I want to animate it, but wait, I want to remove and recycle it. So always get into these conflicting cases. The way we solved this was the child helper. So when layout manager says, hey, like, I want to get a child at a position, or remove it, or do whatever I want, recycle view doesn't call the view group. Like, we don't change the children instantly. We instead tell the child helper, which is the component that's responsible to create this fake list about the contents. And then the child helper decides, OK, layout manager told me to remove it, but item animator told me to animate it, so I will keep it until the item animator is done. But we don't want layout managers to get more complex trying to understand about animations. So for the layout manager, they look like they disappeared, but they're actually real children in the view group. So child helper is responsible to provide a virtual list to the layout manager. So for example, let's assume this view has been swiped, is being removed. So while you run the remove animations at the 200 milliseconds, if the layout manager tries to get the child at the third position, it's going to return Barcelona. And if the recycler views, if you try to get the recycler view's third child, is New York. So the abstraction between these components helps us do this kind of tricks without making these components complex. And when the animation is complete, they will start returning the same value. Adapter helper is the same thing, but doing the same abstraction towards the adapter. So when you have the adapter and send all these notify change events, like there's a bunch of things happening in the list, and recycle is, oh, suck, what's going on? I have no idea what's happening there. It's very hard for layout manager to track these things because it's already busy tracking the UI. So adapter helper is to the rescue. So when you say notify item inserted in an adapter, we record it and we request a layout. We know something happened, we need to redraw. That's it. The only thing we do is we keep the information about it. And then as you add more notify events, we just keep them in a list. Let's say during this moment, before we recalculate the layout, but we know the adapter contents have changed, user clicked on a button. And you wanted to get the item, you call get adapter position for the item at 59, which was clicked. But we know there's a new item added at index 55, so we know that in the adapter, that's actually at position 60, so we return you 60. So even if the view is not recalculated, if you need the adapter position to go access your adapter items, we can provide you the right position. So this simply happens by checking what you told us before. And let's say you send more updates, and then we will go through them. The request layout will be honored by the system. We will start preparing the new layout. And this time, the adapter is going to provide the layout manager the fake positions. So how does it work? What we do is, when I talk about like faking the adapter contents, is we reorder your updates first. So the idea is that everything we have to tell to the layout manager first, we tell about them. We let it do the predictive layout. And then everything else, we tell about them later. So if you look at, you remove 2 items from 61, we know that was 60 when we reordered. When we look at this, OK, I actually have the item for 60. So even though it is removed, when the layout manager is recalculating the previous state, which is part of predictive animations, if it asks for item 60, I could provide it. So I don't need to tell the layout manager that that item has been deleted from the adapter. But item 61, I don't have it. So what I do is I divide that remove operation into 2. I tell the layout manager, hey, like before even you calculate the layout, the item 61 is gone, just to let you know. It does the pre-layout, goes to the post-layout phase, then we tell about these things. Like this fine-grained adapter updates enables us to fake the adapter contents towards the layout manager so that all it has to do is we ask it to lay out twice, and then we predict all the rest of the animations. So layout manager almost doesn't need to know anything about them. OK.
All right. We'll try and move through some of the other features here a little bit more quickly. So item decorations. List view has the ability, like many other one-off features in list view, to draw dividers between items. And so we needed to make sure that this sort of functionality was still preserved. So item decorations allow you to do custom drawing on the recycler view's canvas itself. So this is in the context of the recycler view, the parent of all your child items, not necessarily just individual items within it. We can also go ahead and add offsets to view bounds. Again, using the simple test case of the divider, you need to make sure that you have that couple pixels of space that the divider consumes itself, rather than drawing necessarily over or under the item views. And you can also have multiple item decorations. They stack. So these item decorations can affect views, again, in sort of a stack-like manner. Item decorations, so we can draw items over our list items here. What else? Come on. All right. So another kind of important thing here is the get item offsets. This is really what lets us add space around particular items. So this can be nice if you're doing some sort of card background around several items at once, so like a grouping of some sort. But you can also do it just on single items, too. So we can expand the space around a particular item, because maybe that's an area that we're going to draw in. So we get onDraw, which will draw underneath the item views before we actually draw the item views themselves, which is then followed by the items themselves. And then we get onDraw over, which allows us a chance to draw on top of the item views in case that becomes relevant in your particular situation. So in this case, we're just otherwise decorating these things. So you need to be kind of careful about item decorations, though, because this drawing phase here might be in the middle of several other operations that Recycler View is doing. And as you just detailed, there are a lot of things that Recycler View does to sort of try and present a consistent view of the world to adapters versus the layout managers. We're doing animations and so on and so forth. So the adapter's view of the world may not be what you're seeing on screen right then. So you want to make sure that you don't use the item decorations to access the adapter. Keep the necessary information about things that you need to draw in the view holder itself. The item decoration can access the view holder at will, because the view holder is data about what's being displayed on screen right now. And again, the general rules around drawing apply. This is a pretty hot code path. Ideally, this is being called 60 frames per second if everything's going right. So try not to allocate memory, do anything too expensive, so on and so forth. You can always go ahead and use the Recycler View getChildViewHolder method to get the view holder for a particular child view that's attached to the Recycler View at the time. So the recycled view pool is another component that's kind of important to know about, if only because it allows you to pull some pretty neat tricks depending on the type of UI that you're creating. So the recycled view pool would normally just be an internal implementation detail where we're holding extra view holders of the different types like we mentioned earlier. But the cool thing about the recycled view pool is that you can share it between multiple recycler views or even just other custom view groups that you've written that need to do some similar operations that need uniform views of this type. Again, always make sure that you keep these scoped to a single activity. These things are holding views. Views hold on to a context. Contexts were inflated with your activity. And you can get yourself into trouble if you end up leaking those activity contexts by accident. So make sure that these are scoped to a single activity at most. But you see UIs like this in terms of the Android leanback library for Android TV. You have multiple rows that are actually recycler views held within recycler views. But the innermost child items are all of a uniform type. So what we do there is we can share the recycled view pool across all of these individual rows. And this allows us to be much, much more efficient in terms of how we allocate those and manage those pools.
OK. So as we start adding more functions to recycle, we try to implement them as components. So things drag and drop. If you look at list view, there's like a bunch of libraries. You need to look at the examples, and only some of them work for your use case. So we wanted to learn from our mistakes. When we designed item touch helper, we wanted it to be independent of the layout. So I want to use item touch helper. It can do drag and drop. It can do swipe to dismiss. And all you do is you provide this callback class. In the callback class, you provide some like get movement flags. This is the idea. I have a view holder. How can I move this view holder? Because I up and down or left and right. And you could say to us, what should I do when the item is moved? So let's say the user moved it to somewhere else, and then now you need to change the adapter. Similar swipe. The user is swiping it to the right. When it is done, we will let you know. So all you have to do is tell us how a view holder can be moved. Actually do what you need to change in your adapter when it is moved or swiped. So you can actually run drag and drop and swipe at the same time in the same layout manager. It just works. So this is the get movement flags. We provide the make movement flags. So in this example, I say each item can be dragged up and down, and you can swipe it towards the end. So it also supports RTL. Actually, if you say and, your callbacks will receive the same things, like an RTL parameters. If you use left and right, your callbacks will receive left and right. So you can also customize how it is drawn. In the Support 7 demos, we have this sample. Like you can make it fade away as you swipe. You just override another method in the callback. And you can also start the drag and drop or swipe yourself. Maybe you have a custom button there. Try to go a little bit faster. OK, we'll go through some tips and tricks.
Yeah, really quick here. So again, as we talked about before, we want to be more efficient with recycler view adapters than we were with list view adapters. So if you don't update a particular item, you don't get on bind for that item anymore. We're able to just reuse that view in place. So even move operations, we don't have to go back to the adapter to ask for that data again because, hey, it hasn't changed. Why should we do the extra work? So we don't get an invalidate on that view. We make sure that cache works. We have happy kittens. And then what that means, though, as a side effect, is that since items can be added or removed around it and items can move, when you bind your views, don't make assumptions that the position that you were initially bound for is always going to be the position corresponding to that data item. Again, this is a perfect example of what can end up going wrong. You want to make sure that you access the position live from the view holder itself. The view holder knows what's going on there. In this case, yeah, there we go. The view holder knows what the adapter position is right now. So we make sure and keep that updated for you so you don't have to track it yourself. But make sure that you don't accidentally close over the value of the adapter position by accident.
By the way, Android Studio has a lit rule now, so it will not let you do that. So use item change with payload. So when an item changes, like the time change, a user liked it, use it with the payload. It will make your onBind a lot more efficient. You can run better animations. So in the onBind method, you can just check if you have been passed payloads. So if there's no payloads, fully bind is a new view holder. If there is payloads, we guarantee that the view holder is being reused for that position. So you don't have to set everything. You only set what has changed, and you know that information from the payload. It's very efficient. It's great for animations. Another mistake we see commonly, like you have a header view. When we ask for the header view, you return the same one. Don't do it. If we called onCreate, that means create a new view holder. Don't try to return us the same view you have, because you will have bugs. We wouldn't call that method if we didn't need it. So the idea, never do something like this. If we ask for you to create a new one. Adapter versus layout positions is something we previously mentioned. But so a view, let's say you moved an item. At this point, you can see the adapter positions and layout positions of some items are different until the next layout is calculated, because layouts are calculated asynchronously. So once the view system tells us, OK, you can refresh yourself, we refresh it. Now all of the items have the same layout position and adapter position. So adapter's position is very good if you need to access your data. Layout position is very good if you want to know what is above and below at the point when user clicks something.
Right.
And
I think
thank
that's
you.
it.
Yes.
So thank you very much.
Reduce the bandwidth for our total application. So to do that, we're going to use import href over here in our code editor. So this is my XApp element that I have started off with. And what I'm going to do is I'm going to have an XApp element inside of XApp. I will chuck in a little iron pages here. And inside of iron pages, we'll have sections for the different bits of our app that we are interested in. So I've got a browse section and an activity section. And we've also got the page.js router loaded into XApp as well. So if we go down to the JavaScript definition, we can see that I've got kind of a basic route stubbed out. And what I want to do is, when the route changes to either the browse section or the activity section, I'm going to call Polymer's import href method, load in my element definition. Once that's loaded in, I will then tell Iron Pages to switch over to that section. Now the first thing I want to do, though, since we're starting off just at like slash, right now what we're doing is we're actually just loading a shell that looks kind of like this, right? We don't have, we're not hitting either the browse or the activity section, so the user's kind of got, nothing to look at. So we'll start off by redirecting them, page.redirect, over to the browse section. So this way we just have kind of like a nice starting point. I'm going to write another handler for browse, so page/browse. And you'll notice here that I'm using ES6 fat arrow functions. That just makes it a little bit easier to deal with the scoping of the this value inside of these handlers. So I'll say page.browse. And what I first want to do is see if the element has already been loaded. Has this page been loaded before? Because if it has, there's no reason to import it again. So we'll call Polymer's isInstance method. And this is something that I don't even think it's well documented. It might seriously not even exist anywhere in our docs, but I spoke with our tech writer. This is a thing. You can use it to sort of check to see if an element is an upgraded Polymer element. So because both our browse element and our activity element have IDs, we can reference them using automatic node finding. And we could say this.$browse. So if this is already a Polymer element, let's just go ahead and return. No reason to do anything. No importing or anything like that is needed. But we will set the selected value to browse. And then what that's going to do is that's going to tell our Iron Pages up here to switch to that section. So you can see we're binding its selected attribute to that property. OK? Now, if the element has not been loaded, if it hasn't been upgraded yet, now we're going to import its definition. So we'll call polymer.base.importhref. And we're going to pass it a path to the HTML import for the browse section that we want to load. So elements/xbrowse/xbrowse.html. And then we'll give it a success handler to run. So we're going to say, all right, cool, the element loaded in. Let's now set this selected state to browse. That'll tell Iron Pages to update. And now we can return, exit our route here. We should be good to go. If we go back and we look at our application now and we refresh the page, it should redirect to the browse section, and it should start loading in all of those cards. Awesome, right? Now we need to do the same thing for the activity section. So I can just grab this entire route right here and do some dangerous copy and paste work here. We're just going to go through, and any place where it says browse, we'll just flip it out for activity. Activity. Thank you, spell check. So when we go to /activity, we're going to check to see if the activity element is upgraded. If it is, return. If it's not, import it. Let's go give that a look. So refresh the page, and we see our browse section looking good. We go to the activity section, and boom, we got our status feed showing up right there. Now, there's still a lot of unanswered questions to this. I kind of showed you the quick and dirty version of using import href, but what we didn't talk about was, do we need to vulcanize these things into different bundles? And if so, how do we exclude common dependencies? Or can we just use HTTP2 to maybe like server push all the things or multiplex stream all of our dependencies? So there's still a lot of things that remain to be worked out. And what we're going to do is we're going to talk about those in an upcoming episode of Polymer. But today, for what we've done here, if you have any questions, please leave them for me down in the comments. Otherwise, you can always ping me on a social network of your choosing at #AskPolymer. As always, thank you so much for watching, and I'll see you next time. Otherwise, you can ping me on a social network at... We'll keep all the fun stuff up here, top 2/3 of the screen.
We all know from experience that people love to share things about themselves, such as photos, videos, and GIFs that express their feelings. So what do you do to let them store and share these files through your app? That's where Firebase Storage can help. Our storage API lets you upload your users' files to our cloud so they can be shared with anyone else. And if you have specific rules for sharing files with certain users, you can protect this content for users logged in with Firebase authentication. Security, of course, is our first concern. All transfers are performed over a secure connection. Also, all transfers with our API are robust and will automatically resume in case the connection is broken. This is essential for transferring large files over slow or unreliable mobile connections. And finally, our storage, backed by Google Cloud Storage, scales to petabytes. That's billions of photos to meet your app's needs, so you will never be out of space when you need it. So give your users space to share their lives with Firebase Storage, available right now for iOS, Android, and web applications. And to learn more about Firebase Storage, check out the documentation available right here.
Let's be honest, you're an awesome engineer with an awesome app and you are using threading to the max. Sadly though, managing all those individual threads and assigning work between them is causing you to lose your hair. My name is Colt McCandless, and please, don't join the bald club. Instead, use the thread pools class, which is an ideal primitive for breaking up lots of work into little buckets. See, historically, it was commonplace that applications would use a dedicated thread model. That is, one thread that only deals with database writes, while a separate thread only handles streaming of music, and a third one only handles networking. These setups are okay because the amount of work per thread isn't that large, and it's okay to handle this work in sequential order. But there reaches a point where this model starts to fall over. Say, for example, that you've got 40 bitmaps to decode, and each decode takes like 4 milliseconds or something. Putting all of this work on a single dedicated thread is a bad idea, since it'll take 80 milliseconds total to get all that work done in a sequential fashion. On the other hand, if you created 10 threads and let each one decode 4 bitmaps, then you'd end up only taking 16 milliseconds total. But then, of course, you run into the problem of how to properly pass the work around between those threads, schedule that work, and then managing of those threads. Before you start stressing out about writing all that code, don't worry. This is exactly what thread pool executor primitive is for. Basically, this class will just let you spin up a number of threads and toss blocks of work to execute on it. Thread pool executor handles all of the heavy lifting of spinning up the threads, load balancing work across those threads, and even killing those threads when they have been idle for a while. Basically, it handles all the heavy lifting of super parallel processing on your behalf. All you have to do is split up the work. But there's a small caveat here. how many threads should your thread pool have? I mean, technically speaking, you have the ability to create as many threads as you want, but that's not ideal. See, CPUs can only execute a certain number of threads in parallel. Once you get above that number, then the CPU has to start deciding which threads get the next free block of processor time based on how important they are. Which means that if you keep eventually adding threads, you'll hit a break-even point where your computation isn't getting any faster, even though the number of threads that you have has increased significantly. And it's also important to note that each of these threads aren't free. Each thread costs you about 64K of memory in minimum, and that adds up quickly, especially in situations where the call stacks can start growing pretty large. As such, your app needs to find a sweet spot between the number of cores and the point of diminishing return with the number of threads. Thankfully, once again, the thread pool executor class has got you covered. When creating your thread pool, you can specify the number of initial threads and the number of maximum threads. As the workload in the thread pool changes, it'll scale the number of alive threads to match. Oh, and a quick note, the value returned from get available processors may not reflect the number of physical cores in the device. See, some devices have CPUs that will deactivate one or more cores depending on the system load to save battery. So if your device has 2 CPUs, but one of them is asleep, this value could return 1. And of course, thread pools won't solve all of your threading problems. As mentioned earlier, unless you're dealing with lots and lots of work packets all the time, this thing's kind of overkill. It's best to use things like handler threads or async task loaders for specific types of work blocks and only throw the massive computing problems at the thread pool. And for you power users out there, remember that render script might be a better alternative to large-scale parallel work on Android devices, but that's a whole separate set of videos that we haven't gotten into yet. And don't forget that systrace is an amazingly powerful tool that lets you visualize how work is flowing through the threads in your application. It's a great way to validate that things are working as intended and also see all the other crazy threads that are being worked on by other parts of your app. And that's the trick with performance, isn't it? I mean, you can make assumptions, but things don't always work the way you think, which is why you need to check out the rest of the Android Performance Patterns videos, and don't forget to join our Google Plus community to ask a lot of hard threading questions as well. So keep calm, profile your code, and always remember, perf matters.
So service workers are powerful for offline caching, but they're also really good for giving you instant loading performance benefits when it comes to repeat visits.
Yep.
Right? And you can achieve that using an application shell architecture.
Yeah.
Now,
so that's kind of the idea of kind of separating content from the actual visual UI. So in my head, it's kind of like native apps. You always have the banner, you've got the navigation drawer at the side, you might have some other bits. That could be common through like 90% of your app.
Yeah.
You always want it there.
So when we talk about the shell, we're talking about the HTML, the CSS, and the JavaScript that's making up the bulk of your UI.
Yeah,
Stuff that, you know, if you cache that, you can still just like load up content in the very middle.
Yeah.
And save yourself having to constantly reload that stuff, right?
Yeah, and it's super nice when it comes to like, let's say they're visiting a page they've never been to before. If you know the layout's always going to be the same, you can still load that while you go and get the content in the background.
And it just makes sure that your user has like really good perceived performance.
Yeah.
So the first time your app loads, you're going to have to render the shell itself. You'll cache that in your service worker, and you might show like a toast just to let them know, hey, this application now works offline.
Yep.
And that means that when they come back another time, like let's say they're in airplane mode, that shell will load up really, really quickly, and then it might go to the network to fetch the rest of the content. You can then cache that content so that that entire view is then available whenever they try accessing it without a network connection.
Yeah, exactly. Spot on.
We've got some performance testing we've done with the application shell model. This is using web page tests. So on first visit, we've got a relatively fast time to first meaningful paint.
And this is super important because I think that there can be scenarios where someone might take advantage of service worker to be like, don't worry about your first load, but I'm just going to serve up like megabytes of stuff that I'm going to cache. Afterwards, you'll be super fast. But that first load, if that takes so long to the point where the service worker doesn't even get registered, that's pointless. And plus, for other browsers that don't support service worker, you're then kind of just damaging yourself.
Yeah, that's going to make your users go and cry in a corner.
Exactly.
You don't want that.
So you still want to be serving up just that static render of your site, just so then it just loads up as fast as humanly possible, and then progressively enhance with Service Worker to then use the app shell model.
And if you are using the app shell model, as you can see here, we've got really good, we've actually slashed our load times for first meaningful paint on repeat visits. Speaking of like actually taking a look at what impact server-side rendering has on this, you don't have to use Service Worker to actually be able to get good gains. If you're building with the app shell model in mind, with server-side rendering in mind, you will get like a really good first paint, even in like Safari and like mobile Safari on iOS.
Yeah, all the other browsers that just don't have Service Worker.
Yeah. Now, if you're wondering, okay, well, should I be using the application shell model on all of my applications? There are going to be types of apps, like super simple apps. This might be overkill.
Yeah.
But if you're building something that's a little bit more complex, a little bit more dynamic, this type of model makes a ton of sense. At Google, we're using it for things like Inbox, and it's working really well there.
Yeah, I think it's one of those things you end up falling into the sit there and figure out whether it makes sense for your site or not. But I think it's a good overall model that works for a lot of different scenarios.
There's a whole ton behind this model that we way too much to explain in just one video, but we wrote up a pretty amazing article on this, if we do say so ourselves.
Well, you wrote it up and I just read it. So
you just added your name to the end of it.
Yeah, that's how I
roll.
roll.
Pretty much. Impact. That's worth checking out.
That's the format of this
It's
show,
a mediocre article at best, but it's got pretty graphics.
Yes, it does.
People should go check that out.
Yep.
Learn more about App Shell.
And then there's also the Getting Started guide for your first progressive web app, where it actually talks about the application shell model, how you can take advantage of it, as well as how it applies to the demo app that you can build in this lovely code lab.
Yep. And in that article, we also link out to tools that can help you get started with the application model like really quickly that we're working on. So check that out.
Yeah, build a weather app.
Hey gang, did you know you can send notifications to iOS devices using Google Cloud Messaging? Well, you can. Why would you ever want to do that? Maybe that's a better question. Let's find out the answer on this episode of Route 85. So, notifications. They're a great way for you to engage with your users. They let your customers know you have important new information for them, and when used responsibly, they can be a great way to keep users coming back to your app. But they're not super fun to implement. There's a lot of steps required to set up notifications in the first place. You need logic on both the client and the server, and if you're developing a cross-platform mobile app, and most of you are these days, you have to do this for Android and for iOS. And I'm not just talking about two sets of client logic either. It turns out sending notifications to iOS and Android devices requires different logic on the server too. See, if you've done any notifications work in the past, you're probably used to talking to APNS, that's the Apple Push Notification Service, to deliver notifications to iOS devices, and to GCM, that's Google Cloud Messaging, to deliver notifications to Android devices. And while sending notifications through these two services is similar, they each have slightly different features, use different protocols, accept different message payloads, and return different responses, all of which means that you got to keep track of what kind of device each of your users has and use two completely different code paths to send a notification. Or do you? Well, no. No, you don't. You see, one pretty great feature about Google Cloud Messaging that a lot of people don't know about is that GCM can relay to APNS any notifications you want to send to an iOS device. Now, granted, you'll need to do some setup work like upload your APNS certificate to GCM and make sure your client sends its device token to the GCM service. But once you've done that, you can use GCM to send all of your notifications, no matter what platform your target device is, and GCM will deliver your notifications to the correct device using the appropriate service. What all this means is that you don't need to care about what device your user has anymore. You just have to write and maintain one code path, and as we all know, less code means less room for mistakes. But it's not just about using less code. By using GCM to handle your messaging for you, you can take advantage of some of the other nice features that GCM offers to developers, like topics. Topics allow your app to subscribe to notifications about any particular topic that you or your users want to. For example, let's say you've got a weather app and I, as a loyal weather fan, want to be notified whenever there's extreme weather happening in my zip code. Well, in the old way of doing this, you'd probably need to set up a database where you keep track of each one of your users and their devices and their zip codes and do this whole select users where blah 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 query, then loop through the results and send notifications to each device that you get back from this database query. But with topics, none of that's necessary. Instead, your app simply tells GCM that you're interested in subscribing to, say, the weather 94043 topic. Then, next time there's rain in California, for us that counts as extreme weather.
Oh my gosh, there's something coming down from the sky. I don't know if it's water, if it's acid. I can't go out. I don't know how to drive anymore.
Yeah, that seems about right. So yeah, with topics, your server simply tells GCM to send notifications to all devices subscribed to the weather 94043 topic. And I will get notified along with all other devices subscribed to that topic. So there's no database required. Go ahead and throw it out. Oh, as long as you weren't using it for anything else, I guess. I probably should have mentioned that earlier. GCM has other useful features too, like upstream messaging, which allows your app to communicate to your server through GCM. This can be helpful in cases where you might want some lightweight communication from your clients to your server, but don't feel like dealing with the hassle of setting up and maintaining a full-blown server open to the entire world. Or read receipts, where in some, but not all situations, you can be notified that a user has received your message, something you can't normally do through APNS alone. Oh, and in case you're wondering, all this is free, as in please send us $0, and it's using much of the same infrastructure that Google uses for its own apps, so it'll probably scale for yours. So there's a lot to learn when it comes to notifications, and I encourage you to get started here with our Google Cloud Messaging documentation for iOS. We also have a couple of sample applications for you to look at. There's Friendly Ping, our cross-platform chat app powered entirely through Google Cloud Messaging, as well as the GCM Playground, which lets you easily experiment with sending calls through the GCM service. And keep watching Route 85. Maybe you'll see another Google Cloud Messaging video pop up in the future. If only we had some way of letting you know when that happened. Well, I'm stumped. So what if I told you there was a way you could compress nearly any stream of data by a factor of 10x or more? Wouldn't that be something you'd be interested in? Yeah, I thought so. Let's find out more on this episode of Route 85. So I want you to take a look at this array of numbers here. Imagine that we wanted to send this array of integers from a server to your user's device. Looks like just a bunch of random numbers, right? Well, that word random is actually the key to compressing these in an incredibly efficient manner. As you probably know, a random number generator isn't truly random. Supply a random number generator with the same seed, and you'll get the same results out every time. And we can take advantage of that fact to recreate that list of integers using a random number generator. You see, all I need to do to regenerate that array on a device is to supply 3 parameters: the seed for an agreed upon random number generator, an upper bound to apply to these results, and the length of the list. I simply supply those numbers to a method that looks a little like this, and I can recreate that original number stream. Just like that, I've built my array of 30 integers using just 2 integers and an int 32. That's a 92% compression rate. Now granted, finding that initial seed did take some work, but you know what? That work can happen in the cloud, so it doesn't really matter. What's important is that on the device, I'm able to decompress that number stream in order and time. And then of course, once you start looking around, you can see that there's a ton of data you can compress this way. I mean, need to compress a text string? Well, what's a string but a stream of encoded integers? Once I have my stream of integers, I simply figure out what seed I need to generate them, and voila, I've compressed my string down into just 3 numbers. It's a pretty amazing savings, right? Anybody with a username of stidjexmisdizixgoodquibpubpa will be singing your praises in their reviews. And my gosh, if you think about it, an image is really just a stream of numbers broken out into several channels. Take a look at this image here, and you can see how, using our random number generator, I've been able to replace it with just 3 sets of integers for the red, green, and blue channels, respectively. Now, once again, finding the right seed can take some time, and I haven't found the perfect seed just yet. So if you look at the results carefully, you can see that this is not quite a lossless compression scheme. But I think you'll agree that for this kind of savings, these trade-offs just might be worth it. Anyway, I hope you consider using this technique the next time you have data that needs to be compressed. Remember, the more efficient you are with your users' data, the more they'll love you. Thanks again for watching. Be sure to check out other episodes of Route 85. And remember that, as my coworkers on the Android team like to say, perf matters. All right, thanks guys. I think we're done.
Who let him into the studio again?
I couldn't say no to Elijah Wood.
But that's...
Elijah Wood.
People love to use different mobile devices in different ways that suit their situation and lifestyle. Michael uses a phone to play games on the go, while Tony enjoys using a large tablet as he relaxes on the sofa. And Jen carries a small tablet in her purse for reading on the bus. But they all want to use your app on the devices they prefer, so you'll want to make sure they each have a great experience, regardless of screen size, OS version, and the features of the app they use the most. It can be taxing to test each one of these situations so that all your users can be happy. We know you'd rather not have to buy and store stacks of devices and test your app in all these circumstances. That's why we built Firebase Test Lab for Android to make it easy and affordable for you to test your app with a variety of devices and be sure it works great for all your users. Our device lab, hosted in the cloud, offers a variety of physical devices ready to test your app. The selection of devices is always growing, so your tests will stay current with the latest hardware and operating systems. The easiest way to use Firebase Test Lab is to run a robo-test. This is an intelligent, automated test that crawls your app to discover and exercise its features. You won't need to write any additional code to make use of a robo-test. For more advanced testing, you can also script the interactions with your app to simulate specific use cases and verify that everything works as expected. Test results include a detailed report for each device used, including screenshots, device logs, and any crashes that may have occurred during the test. This allows you to verify that your app is working correctly on the variety of devices and configurations you selected. It's easy to make Firebase Test Lab a part of your daily development routine, and we have multiple ways to help you test regularly and spot errors early. First, you can use the Firebase console to upload and test your app. There is also a command line interface for testing with continuous integration servers, so you can automatically test every build. During Android development, you can deploy your app directly to Firebase Test Lab using Android Studio 2.0. And finally, in the Play Store Developer Console, there is a special automated launch test that will run for Android apps published to an alpha or beta channel. To get started using Firebase Test Lab and learn how to regularly test your app on different devices and configurations, you can start with the documentation available right here. Happy testing!
Welcome to the Googleplex. This is an incredible place with lots of great stuff being worked on every single day. Before I worked here, I always wondered what it would be like to come to the Googleplex, meet up with a Googler, and have coffee with them and just chat about what they do, how they do it, and why they do it. And today we're going to do exactly that. Welcome to Coffee with a Googler. I'm Lawrence Moroney and I'm here in New York City to meet with Roman Nurik. And Roman Nurik is one of our material design gurus here at Google. So material design, tell me, what's it all about?
Oh, Lawrence, what is material design? Yeah, it's kind of hard to explain. There's actually a video with a bunch of the original designers that created material design, and they get asked the same question and they don't know how to answer it. It is a complex kind of thing. There's a lot of things going on. I guess at the most basic level, it's a design language. It's a design system. It covers visual, interaction, and motion design. I feel like most design systems, design languages are treated as just visual languages, like here are the colors you should use and so on. But material is much more than that. It really kind of covers the model, the underlying physical model of a UI.
Okay.
So it basically tries to establish this physical environment within which your apps should live, on a phone, on a tablet, on a computer, basically any sort of screen. And then it basically establishes this physical environment in a set of basic rules and principles. And I like to think of it along these kind of 4 basic axes or 4 basic principles. And that's tangible surfaces, or kind of the material metaphor. We could talk about what material is at some point. Also, bold graphic design, this idea that we should take some of the best design ideas from the print world and see how that can help us make really great apps on digital devices.
Right.
And the third is meaningful motion, basically how all these things, how the surfaces and the ink on that surface, the graphic design stuff, how that all kind of moves in a consistent way to help communicate what's going on. And the fourth thing, which is to me one of the most important things, is adaptive design, which is how can we take all these first 3 things and make sure that they work consistently and coherently across different devices, phones, tablets, and everything else.
Now, you have a video, right, of some really good examples of material design being used. So shall we roll that?
Let's roll it.
So some pretty excellent examples there, but it's like, you know, how does somebody reach that level? And for someone like me, I'm a developer and my design skills are non-existent. So if I want to become somebody who can build apps with those kind of design, how do I get started? And
well,
how do I learn this stuff?
It's a great question. I think first of all, I just want to, I guess, recognize some of those apps they're doing amazing jobs, and they have large teams. Some of them actually have very small teams. Some of those apps are created by one person. So you can absolutely reach that level of quality from these amazing showcase apps, regardless of your team size.
Okay.
But I'd say for the developers and designers out there that are just getting started, there are a lot of great resources out there. There's a great Udacity course that me, Nick Butcher, also from Google team here, and James Williams from Udacity put together. And that's available at udacity.com/Google.
Right.
And there's also a bunch of amazing resources on design.google.com, which will kind of tell you about how to come to Android if you're doing iOS stuff, for example, or how to kind of get started understanding what material design is. There's obviously the entire material design guidelines are there.
Okay.
So I'd say that the first thing, the Udacity course is probably the best kind of first step in getting started. But there's a whole lot of resources out there, and we link to others from the Udacity course.
And Udacity courses, if you're not familiar with them, they are very Socratic in how they teach, right? It's short videos and then challenging you to do something, and then a short video and then getting you to do something. And it's a good way that someone can incrementally learn rather than be thrown into like a huge design doc or something like that, right? So
yeah, it's definitely, there's a very clear progression. We specifically designed that course so that you can kind of start with some of the basics, the most elementary basic things about a screen, like what is a pixel, what is a density independent pixel, and then you kind of ramp all the way up to how do I make everything work on phones, tablets, and so on.
Right, and I have to assume that a design course is well designed, right?
We have some very nice color choices in our slides or our tablet drawings, so hopefully.
So back to material design again. It's like why material? What is it that?
So material goes back to that first principle. Right. So this idea of tangible surfaces, this idea that everything on a on your screen and your device exists on a surface. We like to think of them as pieces of paper. So basically, you can think of basically a sheet of material, or the word material representing one of those pieces of paper. And the reason we don't just call it paper is because it's a lot more than just paper. In the real world, paper, once you rip it up, you can't really just, put it back together, and paper can't go from being, a circle to a square or to a rectangle. And so we like to think of our digital pieces of material or sheets of material as kind of a smarter paper, a more kind of, still a constrained paper. You can't just do anything. It can't just do all sorts of crazy things, but it is a physical thing that exists inside of this kind of environment, this kind of like faux environment, but it is something that has a lot of thought put into it. And so the word material, to me really means the sheets of paper that everything in this world exists on. But for me, the main thing to think about, the reason that motion is so important in material design is that motion should always have meaning. Try not to just do it like a flip of a button or like a double rotation or something just to kind of draw attention. Every time something moves, it attracts our attention. And so it needs to be really thoughtful and really kind of carefully planned out. And so in material, we use motion, or we kind of use just enough motion to convey the change in some object's state, or try to get a little bit of attention, but just enough motion, not too little, not too much.
I understand Android Studio has some templates to allow developers to at least get started with building material design into their apps.
Absolutely. So one of my philosophies for a long time has been, we can write about material design. We can write about a thing. We can make suggestions about that thing, and we can try to teach people about that thing. But one of the best ways to get the thing into people's hands, in this case material design, is to actually just build it into the tools. Just make sure that as a developer that's just getting started, even just on Android, if I just go to File, New Project, or New App, right, I should be able to get the latest and greatest. And so in Android Studio now, we're actually seeing new templates for material design. So you could do File, New Project, and then your default activity templates are going to come with material design in them.
Okay.
So it's going to use the material theme. It's going to use some of the latest support libraries from material design. So things like the Android Design Support Library, things like App Compat.
Cool.
And so you're just going to get a lot of great stuff for free right off the bat.
Nice. So for someone like me, I'm a coder, not a designer, and so I can use Android Studio, get effectively the scaffolding done for me in these templates, and then learn from something like the Udacity course.
Exactly. I definitely suggest, even before you do the Udacity course, File, New Project, right? Just look around the code, see what you get. I think that's a great way to get started. I always valued, as a kid and growing up learning programming and stuff, I always valued experimentation. So definitely experiment with that. But as soon as you kind of hit some sort of if you hit an obstacle or something, obviously take a look at the guide and the reference and all that. But the Udacity course is a great way to say, what, let me just kind of see what Google thinks is the right way to kind of approach understanding this system.
Awesome. Well, thanks, Roman. This has been a whole lot of fun, and I've learned more about material design in the last 5 minutes than I'd had in a year beforehand. So
this is fun. I could always talk about this stuff. So
they've told me that about you.
This is my favorite thing to talk about.
It's cool.
It's been awesome.
And I'm going to check out that Udacity course, and I recommend that you do so too. And if you're an Android developer, take a look at those templates. If you have any questions for me about this, or if you have any questions for Roman about material design or other aspects of building for material design, just please drop us a line in the comments below. Thank you for watching this episode of Coffee with a Googler. For more great episodes of Coffee with a Googler and for more great videos on developer topics, please tune to the Google Developers channel on YouTube. Thank you.
Last episode, we used a decision tree as our classifier. Today, we'll add code to visualize it so we can see how it works under the hood. There are many types of classifiers you may have heard of before, things like neural nets or support vector machines. So why did we use a decision tree to start? Well, they have a very unique property. They're easy to read and understand. In fact, they're one of the few models that are interpretable, where you can understand exactly why the classifier makes a decision. That's amazingly useful in practice. To get started, I'll introduce you to a real dataset we'll work with today. It's called Iris. Iris is a classic machine learning problem. In it, you want to identify what type of flower you have based on different measurements, like the length and width of the petal. The dataset includes 3 different types of flowers. They're all species of iris: Setosa, versicolor, and virginica. Scrolling down, you can see we're given 50 examples of each type, so 150 examples total. Notice there are 4 features that are used to describe each example. These are the length and width of the sepal and petal. And just like in our apples and oranges problem, the first 4 columns give the features, and the last column gives the labels, which is the type of flower in each row. Our goal is to use this dataset to train a classifier. Then we can use that classifier to predict what species of flower we have if we're given a new flower that we've never seen before. Knowing how to work with an existing dataset is a good skill, so let's import Iris into scikit-learn and see what it looks like in code. Conveniently, the friendly folks at Scikit provided a bunch of sample datasets, including Iris, as well as utilities to make them easy to import. We can import Iris into our code like this. The dataset includes both the table from Wikipedia as well as some metadata. The metadata tells you the names of the features and the names of different types of flowers. The features and examples themselves are contained in the data variable. For example, if I print out the first entry, you can see the measurements for this flower. These index to the feature names, so the first value refers to the sepal length and the second to sepal width, and so on. The target variable contains the labels. Likewise, these index to the target names. Let's print out the first one. A label of 0 means it's a setosa. If you look at the table from Wikipedia, you'll notice that we just printed out the first row. Now, both the data and target variables have 150 entries. If you want, you can iterate over them to print out the entire dataset like this. Now that we know how to work with the dataset, we're ready to train a classifier. But before we do that, first we need to split up the data. I'm going to remove several of the examples and put them aside for later. We'll call the examples I'm putting aside our testing data. We'll keep these separate from our training data. And later on, we'll use our testing examples to test how accurate the classifier is on data it's never seen before. Testing is actually a really important part of doing machine learning well in practice, and we'll cover it in more detail in a future episode. Just for this exercise, I'll remove one example of each type of flower. And as it happens, the data set is ordered so the first setosa is at index 0, and the first versicolor is at 50, and so on. The syntax looks a little bit complicated, but all I'm doing is removing 3 entries from the data and target variables. Then I'll create 2 new sets of variables, one for training and one for testing. Training will have the majority of our data, and testing will have just the examples I removed. Now, just as before, we can create a decision tree classifier and train it on our training data. Before we visualize it, let's use the tree to classify our testing data. We know we have one flower of each type, and we can print out the labels we expect. Now let's see what the tree predicts. We'll give it the features for our testing data, and we'll get back labels. You can see the predicted labels match our testing data. That means it got them all right. Now keep in mind this was a very simple test, and we'll go into more detail down the road. Now let's visualize the tree so we can see how the classifier works. To do that, I'm going to copy-paste some code in from Scikit's tutorials. And because this code is for visualization and not machine learning concepts, I won't cover the details here. Note that I'm combining the code from these 2 examples to create an easy-to-read PDF. I can run our script and open up the PDF, and we can see the tree. To use it to classify data, you start by reading from the top. Each node asks a yes or no question about one of the features. For example, this node asks if the petal width is less than 0.8 centimeters. If it's true for the example you're classifying, go left, otherwise go right. Now let's use this tree to classify an example from our testing data. Here are the features and label for our first testing flower. Remember, you can find the feature names by looking at the metadata. We know this flower is a setosa, so let's see what the tree predicts. I'll resize the windows to make this easier to see. And the first question the tree asks is whether the petal width is less than 0.8 centimeters. That's the 4th feature. The answer is true, so we proceed left. At this point, we're already at a leaf node. There are no other questions to ask, so the tree gives us a prediction, setosa, and it's right. Notice the label is 0, which indexes to that type of flower. Now let's try our second testing example. This one is a versicolor. Let's see what the tree predicts. Again, we read from the top, and this time the petal width is greater than 0.8 centimeters. The answer to the tree's question is false, so we go right. The next question the tree asks is whether the petal width is less than 1.75. It's trying to narrow it down. That's true, so we go left. Now it asks if the petal length is less than 4.95. That's true, so we go left again. And finally, the tree asks if the petal width is less than 1.65. That's true, so left it is. And now we have our prediction. It's a versicolor, and that's right again. You can try the last one on your own as an exercise, and remember the way we're using the tree is the same way it works in code. So that's how you quickly visualize and read a decision tree. There's a lot more to learn here, especially how they're built automatically from examples. We'll get to that in a future episode, but for now let's close with an essential point. Every question the tree asks must be about one of your features. That means the better your features are, the better a tree you can build. And in the next episode, we'll start looking at what makes a good feature. Thanks very much for watching, and I'll see you next time.
Pop quiz, hotshot. You've got 48 milliseconds of work to do, but only 16 milliseconds per frame to get it done. What do you do? My name is Colt McCandless, and while threading on Android can help cure your performance woes, it can also end up creating some huge problems if you don't understand how it's all working under the hood. So let's take a few minutes and make sure we're all on the same page. See, a thread by default does three things. It starts, it does some works, and as soon as that work is done, it terminates. Now, by itself, that's not too useful. Instead, what you want is a thread that sticks around for a while so you can feed it packets of work to operate on. But to do that, you need a little more scaffolding. First, since threads die when they run out of work, you need to have some sort of loop running on the thread to keep it alive. Just make sure to put it in an exit condition so you can terminate that loop later. In addition, you'll need some sort of queue that the loop can pull blocks of work from to execute on. And of course, you'll need some other thread that creates work packets and pushes them into the queue for execution. Now, if you've ever tried to write this setup yourself, you know it gets a little gnarly to get all of that machinery working correctly. Thankfully though, Android has a set of classes to do all that for you. For example, the looper class will keep the thread alive and pop work off a queue to execute on. And rather than always inserting work at the end of that queue, the handler class gives you the control to push work at the head, the tail, or set a time-based delay that'll keep some work from being processed until that time has passed. And don't forget that units of work in Android are explicitly defined as intents or runnables or messages, depending on who's issuing them and who's consuming them. And then the combination of all these things together is called a handler thread, which lets this look like this. Pretty nifty, huh? So let's look at how you can use this in your application. When the user launches your app, Android creates its own Linux process. Alongside with this, the system creates a thread of execution for your application called the main thread, which at its core is just a handler thread. This main thread handles processing of events from all over your app. For example, callbacks associated with lifecycle information, or callbacks from input events, or even events that are coming from other applications. And most important is that these callbacks can trigger other work that runs on the thread too, like making a change to the UI will create work packets that allow the UI to be redrawn. Basically, this means that any block of code your app wants to run has to be pushed into a work queue and then serviced on the main thread. The takeaway here is that with so much work happening on the main thread, it makes a lot of sense to offload longer work to other threads as to not disturb the UI system from its rendering duties. And this is how the entirety of Android's threading model works. Now, lots of packages of work being passed around between threads and worked on as needed. So, with all this in mind, some of Android's threading classes make a little bit more sense. See, each threaded class is intended for a specific type of threading work, so picking the right one for your needs is really important. For example, the async task class is ideal for helping you get work on and off the UI thread in the right way. Handler threads are great when you need a dedicated thread for callbacks to land on, and thread pools work best when you can break your work up into really small packets and then toss them to a bunch of waiting threads. And intent services are really ideal for background tasks or when you need to get intent work off the UI thread. And like everything else, there's not a silver bullet here, but knowing which primitive is best for what situation can save you a lot of headaches. Now, if you ever want more insight into how your app is leveraging threading, make sure you spend some time getting comfortable with systrace. It's a fancy tool that'll school you on how that mumbo jumbo is working underneath the hood. And if you're looking to get schooled more, make sure you check out the rest of Android Performance Patterns videos. And don't forget to join our Google Plus community for more tips and tricks on threading. So keep calm, profile your code, and always remember, perf matters.
Hey there, Polycasters, Rob here. Welcome back to the show. As we've been working on Polymer, one of the probably biggest requests that comes in from developers is when are we going to get a CDN for Polymer and for web components? Because it's kind of a pain in the butt every time you want to sort of like hack on an idea and you've got to use Bower and install a bunch of packages and wait for everything to download just so you can, play with stuff. So recently, the Polymer team has put out a brand new project, which is called Polygit. It is a development CDN, which I'll talk about what that word means in just a second. But basically, it is a CDN that includes Polymer, all the Polymer elements, and the web components polyfill. So if you want to hack around using something like JSBin and Polymer, you can totally do that. So if you go to the website polygit.org, Polyget.org, you see that it bills itself as the Polymer Magic Server. And what it's actually doing under the hood is it's just using GitHub's rawgit CDN and extracting things from there and pulling them into, JSBin or wherever you want to use the CDN. So what I want to do here is just sort of like show you some examples of how you can use the CDN, how you can configure it to actually pull in your own packages as well, and basically just get hacking really quick. So over on jsbin.com, I've already set up this little sample bin. And the main thing to notice here is I'm using this base tag right here. And if you're not familiar with a base tag, in HTML, a base tag or a base element, it just allows you to set a URL. And then any sort of subsequent URLs that you use, like for script tags or imports, they will all be relative to that base. So what we're saying here is we want the base URL to be polyget.org/components. This components directory is where Polymer and all the Polymer elements and all that good stuff lives. And from here on out, if we have any relative URLs, it'll just pull stuff from that directory. So I'm pulling in web components.js. It's coming from that directory. I can import polymer.html. That'll also come from that directory. And so since we've got all this working off of our CDN, now we can actually sit here if we want. We can just create our own Polymer element right on JSBin. So I'm going to do that right out of DOM module here. I'll give it an ID of like xfoo. And I'll give it a template that just says like hello from xfoo. And I'll also give it a little script tag. And inside of here, we will call the Polymer constructor. And we're going to say it is an xfoo element. And then the last thing we want to do is we want to just make sure that we use our xfoo tag somewhere in the page. And now you can see it showing up over there in our output. So this is really great if you're hanging out on the Polymer Slack channel, you run into a bug or some issue, and you're not quite sure how to explain it to folks. You can just go throw together a JSBin using Polyget and then share that JSBin with people so they can help you get unstuck. Now, I also mentioned that all the Polymer elements that we built are included in this CDN as well. So what you can also do if you find maybe a bug or an issue with something like paper tabs is you can go over here and you can just write an HTML import for paper tabs. So instead of just Polymer, I'll also pull in paper tabs. And then you can just start using that element in your page here. So I'll say I want a set of paper tabs. And then inside of here, I will write out maybe like 2 or 3 paper tabs. So we'll say this first tab is called foo. Second one is going to be called bar. And the last one will be baz. Foo, bar, baz. And there we go. Now over here in our output, I've got these 3 paper tabs working just as I was expecting. And if I had some issue, I could then take this. I could save this JSBin. I could go file a GitHub issue and point the engineer at this particular JSBin. And that way, it's going to help them triage that issue a lot faster and help them debug the actual problem that you're running into and hopefully get things fixed. Now, one of the coolest things about Polyget is that it is configurable. So not only does it pull in Polymer and the elements that team has created, but you can add your own GitHub repos to it as well. So if you go back to the polyget.org website, you scroll down here to the bottom, you can see that there is this sort of interesting configuration syntax. And it might look a little weird when you first see it. It took me a few times kind of working through it to understand what it's doing. But basically, what you want to do is when you are defining that base URL, you can configure it by saying, oh, I would also like to include this component. And this component might live like inside of some particular org. And maybe you want a particular version, like version 1.2.3. Or maybe you want a branch, right? Maybe you want like the master branch. That's some good handwriting right there. Or maybe you want just the latest tag. So if you include an asterisk, instead of pulling a particular version or a branch, it'll just give you whatever the latest tag happens to be. So to show you an example of that, I've again got a little JSBin here. And I'm just going to paste in a better URL here. So what I've done is I've configured Polyget to pull in 2 additional dependencies. The first is the markdown.js library, which is in the chjj org on GitHub. And I've told it to grab the latest tag. And I've also told it to pull in the mark-down element, which is something that I wrote myself. That lives in the Rob Dodson org on GitHub. And again, I've just told it to pull in the latest tag there. So now both of those are available in that CDN components directory. So I can just go ahead and write an HTML import to pull in the markdown element. And then over in my body, I can just start using it. So I can have a markdown tag. And we'll just drop in like a hello world for the header there. And we can see we're getting this sort of like huge H1 rendering over there in the output. So if you're working on an element or a project or something like that, and you want to show that to folks on JSBin, you can absolutely do that using Polygit as well. The one caveat there is that it has to have been published for at least 1 hour for it to be picked up by the rawgit caching CDN. But once it's been published for about an hour, it should be available to you on Polygit. Now, the last thing I want to mention here is at the very beginning of the show, we said that this is a sort of development time CDN. And what I mean by that is it's not a CDN that you want to use for production. And the reason is because we're not doing any sort of like vulcanization or anything like that to optimize the elements that we're sending down. Instead, you're getting an individual dependency for everything that you import, which is actually pretty expensive in terms of HTTP requests. So it's great for development time. It's great for hacking on ideas. But when you get to the point where you want to launch something into production, you still want to use a package manager like Bower. You still want to use a process like Vulcanize to make sure you're sending down the absolute smallest payload possible. But if you just want to mess around with some ideas, it's perfect for that. So that about covers it for today. If you have any questions, please leave them for me down in the comments. Or you can always hit me up on a social network of your choosing at #AskPolymer. As always, thank you so much for watching, and I'll see you next time.
There's something really satisfying about getting your app to look great on your device. But just because there's over 11,000 other Android devices out there doesn't mean you need to build 11,000 other layouts to make a great-looking app. Not if you're using responsive UI principles. You may have noticed that I'm not Ian or Joanna. My name is Mike Denny, a design advocate on the Google design team. First things first, thinking about specific phones and tablets is only going to get you into trouble. There's a wide spectrum of devices and not that much difference between the largest phone and the smallest tablet. Instead, think more generally about how much space you have to work with. This can come in 3 different flavors: width, height, and smallest width. Width is super important and should be the basis for breakpoints in designing and building your UI. For example, 600 dp in width is the first point where you could consider having a side-by-side summary and detail level view. Any lower and you won't be giving each level the full attention it deserves. Height is less common when designing responsive UI, but keep in mind that something like a vertically scrolling container is going to be difficult to use if you can only see 1 or 2 elements at a time due to a constrained height. Smallest width, unlike height or width, is designed to be rotation insensitive as it's just the smaller of the 2 values. This gives you a better idea of how much space is available and is an easy way to ensure that your app remains consistent as the device is rotated. You don't want to force your user to relearn your navigation structure every time they rotate their device. This is particularly important in the multi-window world. When your app is resized, your width, height, and smallest width are going to be updated. You might be going from full screen on a tablet down to what amounts to a portrait-oriented phone worth of space. Here's where a good responsive UI can make for a smooth transition. There are a number of common patterns you might consider when building that responsive UI, such as revealing previously hidden content as the screen size grows, transforming your navigation pattern or switching from a list to a grid, dividing your screen into multiple sections side by side, reflowing specific elements, expanding the size or margins of individual elements, or even changing the position of specific elements like a floating action button. Check out the blog post for more details on designing responsive UI and specific patterns you can use to build better apps.
Hey there, Polycasters, Rob here. So before coming into the studio, we tweeted out a question to see what folks wanted to see in the next episode of Polycast, and a lot of folks wrote in and said they wanted to know how to lazy load Polymer elements to improve the performance of their apps. So that's exactly what we're going to cover today. Now to do that, we're going to start off over here at the Polymer docs, and we're going to go down to the API reference. And some folks might not even realize that we have an API reference, but it's kind of hidden down here in the sidebar for the documentation. You can go click on that, and that's going to take you to this sort of kind of classic Polymer doc layout if you've seen this before on other elements. And this is where you can find all of the properties and methods of the Polymer object itself. So a lot of really cool stuff inside of here. This is also where, for instance, like the Polymer templatizer documentation is. So if you wanted to create your own version of DOM if or DOM repeat, you could use templatizer to do that. Just a helpful tidbit there. But what we're interested in here is this Polymer base object. And Polymer base is sort of the base prototype for all Polymer elements, and it's where we hide interesting like methods and properties and stuff like that. The one I'm into is called import href down here. We can hit the embiggen button to make it larger. And so what import href is going to do, it's going to give us the ability to dynamically load an HTML import at runtime. It's got a few arguments that it takes. The first argument is we're going to give it an href, so basically just a path to some component or some HTML import that you want to pull in at runtime. And then it wants callbacks for on success, on error. And lastly, it takes an option which specifies whether or not you want the link tag to have an async attribute on it. So what I'm going to do is I'm going to use import href, and I'm going to build sort of a sample application. This is the app that I have thrown together. It is called Polymeal. It's a social network for foodies, and I guess people that like stir fry, because there's a lot of pictures of stir fry. And you can either go to the sort of the browse section, and you see here that I've got all sorts of yummy photos. Or you could go to the activity feed, and you could see maybe like I'd be posting status updates from all the cool, awesome restaurants that I'm eating at, right? Now, the main thing to take away from this is that these two sections have very, very different content, right? This one is a whole bunch of cards with some paper buttons on it, right? And this activity feed is instead just sort of these like little status blurb things. So there's no reason to load all of this, all these card elements if the user is just starting off in the activity feed, right? It would just make more sense to load that at runtime to kind of like reduce the bandwidth for our total application. So to do that, we're going to use import href over here in our code editor. So this is my XApp element that I have started off with. And what I'm going to do is I'm going to have an XApp element inside of XApp. I will chuck in a little iron pages here. And inside of iron pages, we'll have sections for the different bits of our app that we are interested in. So I've got a browse section and an activity section. And we've also got the page.js router loaded into XApp as well. So if we go down to the JavaScript definition, we can see that I've got kind of a basic route stubbed out. And what I want to do is when the route changes to either the browse section or the activity section, I'm going to call Polymer's import href method, load in my element definition. Once that's loaded in, I will then tell Iron Pages to switch over to that section. Now, the first thing I want to do, though, since we're starting off just at like slash, right now what we're doing is we're actually just loading a shell that looks kind of like this, right? We don't have, we're not hitting either the browse or the activity section, so the user's kind of got, nothing to look at. So we'll start off by redirecting them, page.redirect, over to the browse section. So this way we just have kind of like a nice starting point. I'm going to write another handler for browse, so page/browse. And you'll notice here that I'm using ES6 fat arrow functions. That just makes it a little bit easier to deal with the scoping of the this value inside of these handlers. So I'll say page.browse. And what I first want to do is see if the element has already been loaded. Has this page been loaded before? Because if it has, there's no reason to import it again. So we'll call Polymer's isInstance method. And this is something that I don't even think it's well documented. It might seriously not even exist anywhere in our docs, but I spoke with our tech writer. This is a thing. You can use it to sort of check to see if an element is an upgraded Polymer element. So because both our browse element and our activity element have IDs, we can reference them using automatic node finding. And we could say this.$browse. So if this is already a Polymer element, let's just go ahead and return. No reason to do anything. No importing or anything like that is needed. But we will set the selected value to browse. And then what that's going to do is that's going to tell our Iron Pages up here to switch to that section. So you can see we're binding its selected attribute to that property. OK? Now, if the element has not been loaded, if it hasn't been upgraded yet, now we're going to import its definition. So we'll call polymer.base.importhref. And we're going to pass it a path to the HTML import for the browse section that we want to load. So elements/xbrowse/xbrowse.html. And then we'll give it a success handler to run. So we're going to say, all right, cool, the element loaded in. Let's now set this selected state to browse. That'll tell Iron Pages to update. And now we can return, exit our route here. We should be good to go. If we go back and we look at our application now and we refresh the page, it should redirect to the browse section and it should start loading in all of those cards. Awesome, right? Now we need to do the same thing for the activity section. So I can just grab this entire route right here and do some dangerous copy and paste work here. We're just going to go through, and any place where it says browse, we'll just flip it out for activity. Activity. Thank you, spell check. So when we go to /activity, we're going to check to see if the activity element is upgraded. If it is, return. If it's not, import it. Let's go give that a look. So refresh the page, and we see our browse section looking good. We go to the activity section, and boom, we got our status feed showing up right there. Now, there's still a lot of unanswered questions to this. I kind of showed you the quick and dirty version of using import href, but what we didn't talk about was, do we need to vulcanize these things into different bundles? And if so, how do we exclude common dependencies? Or can we just use HTTP2 to maybe like server push all the things or multiplex stream all of our dependencies? So there's still a lot of things that remain to be worked out. And what we're going to do is we're going to talk about those in an upcoming episode of Polymer. But today, for what we've done here, if you have any questions, please leave them for me down in the comments. Otherwise, you can always ping me on a social network of your choosing at #AskPolymer. As always, thank you so much for watching, and I'll see you next time. Otherwise, you can ping me on a social network at... Take two. I'll keep all the fun stuff up here, top 2/3 of the screen.
We all know from experience that people love to share things about themselves, such as photos, videos, and GIFs that express their feelings. So what do you do to let them store and share these files through your app? That's where Firebase Storage can help. Our storage API lets you upload your users' files to our cloud so they can be shared with anyone else. And if you have specific rules for sharing files with certain users, you can protect this content for users logged in with Firebase authentication. Security, of course, is our first concern. All transfers are performed over a secure connection. Also, all transfers with our API are robust and will automatically resume in case the connection is broken. This is essential for transferring large files over slow or unreliable mobile connections. And finally, our storage, backed by Google Cloud Storage, scales to petabytes. That's billions of photos to meet your app's needs, so you will never be out of space when you need it. So give your users space to share their lives with Firebase Storage, available right now for iOS, Android, and web applications. And to learn more about Firebase Storage, check out the documentation available right here.
Let's be honest, you're an awesome engineer with an awesome app and you are using threading to the max. Sadly though, managing all those individual threads and assigning work between them is causing you to lose your hair. My name is Colt McCandless, and please, don't join the bald club. Instead, use the thread pools class, which is an ideal primitive for breaking up lots of work into little buckets. See, historically, it was commonplace that applications would use a dedicated thread model. That is, one thread that only deals with database rights, while a separate thread only handles streaming of music, and a third one only handles networking. These setups are okay because the amount of work per thread isn't that large, and it's okay to handle this work in sequential order. But there reaches a point where this model starts to fall over. Say, for example, that you've got 40 bitmaps to decode, and each decode takes like 4 milliseconds or something. Putting all of this work on a single dedicated thread is a bad idea, since it'll take 80 milliseconds total to get all that work done in a sequential fashion. On the other hand, if you created 10 threads and let each one decode 4 bitmaps, then you'd end up only taking 16 milliseconds total. But then, of course, you run into the problem of how to properly pass the work around between those threads, schedule that work, and then managing of those threads. Before you start stressing out about writing all that code, don't worry. This is exactly what thread pool executor primitive is for. Basically, this class will just let you spin up a number of threads and toss blocks of work to execute on it. Thread pool executor handles all of the heavy lifting of spinning up the threads, load balancing work across those threads, and even killing those threads when they have been idle for a while. Basically, it handles all the heavy lifting of super parallel processing on your behalf. All you have to do is split up the work. But there's a small caveat here. how many threads should your thread pool have? I mean, technically speaking, you have the ability to create as many threads as you want, but that's not ideal. See, CPUs can only execute a certain number of threads in parallel. Once you get above that number, then the CPU has to start deciding which threads get the next free block of processor time based on how important they are. Which means that if you keep eventually adding threads, you'll hit a break-even point where your computation isn't getting any faster, even though the number of threads that you have has increased significantly. And it's also important to note that each of these threads aren't free. Each thread costs you about 64K of memory in minimum, and that adds up quickly, especially in situations where the call stacks can start growing pretty large. As such, your app needs to find a sweet spot between the number of cores and the point of diminishing return with the number of threads. Thankfully, once again, the thread pool executor class has got you covered. When creating your thread pool, you can specify the number of initial threads and the number of maximum threads. As the workload in the thread pool changes, it'll scale the number of alive threads to match. Oh, and a quick note, the value returned from get available processors may not reflect the number of physical cores in the device. See, some devices have CPUs that will deactivate one or more cores depending on the system load to save battery. So if your device has 2 CPUs, but one of them is asleep, this value could return 1. And of course, thread pools won't solve all of your threading problems. As mentioned earlier, unless you're dealing with lots and lots of work packets all the time, this thing's kind of overkill. It's best to use things like handler threads or async task loaders for specific types of work blocks and only throw the massive computing problems at the thread pool. And for you power users out there, remember that render script might be a better alternative to large-scale parallel work on Android devices, but that's a whole separate set of videos that we haven't gotten into yet. And don't forget that systrace is an amazingly powerful tool that lets you visualize how work is flowing through the threads in your application. It's a great way to validate that things are working as intended and also see all the other crazy threads that are being worked on by other parts of your app. And that's the trick with performance, isn't it? I mean, you can make assumptions, but things don't always work the way you think, which is why you need to check out the rest of the Android performance patterns videos. And don't forget to join our Google+ community to ask a lot of hard threading questions as well. So keep calm, profile your code, and always remember, perf matters.
So service workers are powerful for offline caching, but they're also really good for giving you instant loading performance benefits when it comes to repeat visits.
Yep.
Right? And you can achieve that using an application shell architecture.
Yeah.
Now,
so that's kind of the idea of kind of separating content from the actual visual UI. So in my head, it's kind of like native apps. You always have the banner, you've got the navigation drawer at the side, you might have some other bits. That could be common through like 90% of your app.
Yeah.
You always want it there.
So when we talk about the shell, we're talking about the HTML, the CSS, and the JavaScript that's making up the bulk of your UI.
Yeah,
Stuff that, you know, if you cache that, you can still just like load up content in the very middle.
Yeah.
And save yourself having to constantly reload that stuff, right?
Yeah, and it's super nice when it comes to like, let's say they're visiting a page they've never been to before. If you know the layout's always going to be the same, you can still load that while you go and get the content in the background.
And it just makes sure that your user has like really good perceived performance.
Yeah.
So the first time your app loads, you're going to have to render the shell itself. You'll cache that in your service worker, and you might show like a toast just to let them know, hey, this application now works offline.
Yep.
And that means that when they come back another time, like let's say they're in airplane mode, that shell will load up really, really quickly, and then it might go to the network to fetch the rest of the content. You can then cache that content so that that entire view is then available whenever they try accessing it without a network connection.
Yeah, exactly. Spot on.
We've got some performance testing we've done with the application shell model. This is using web page tests. So on first visit, we've got a relatively fast time to first meaningful paint.
And this is super important because I think that there can be scenarios where someone might take advantage of service worker to be like, don't worry about your first load, but I'm just going to serve up like megabytes of stuff that I'm going to cache.
Hello, I.O. My name is Adi Osmani. You might have heard of progressive web apps. And it might seem like they went from being this great idea to now being talked about everywhere. It sort of escalated kind of quickly. Now, for many of us in this room, maybe you're working on an existing app, or you're thinking about the next app you're going to be building. Maybe you're building it with a JavaScript library or a framework. And maybe you have progressive enhancement in mind because you want to make sure that the experiences you're crafting work for as many users as possible. We're going to keep that in mind today. Now, before we continue, it's probably useful to remind ourselves what a progressive web app is. So progressive web apps use modern web capabilities to deliver app-like experiences. They evolve from pages in browser tabs to top-level items that exist on your user's home screen. And they exhibit reliable performance. Now, this is an app called Smaller Pictures that I've been working on. It's basically a photo app that lets you compress images on the go. And it's got features like the web app install banner, splash screen, offline support. And when I got to Mountain View, I thought it would be useful to test this app out. So I took a picture of the bathroom in my hotel. Something that I discovered after doing this was that bathroom actually has a better GitHub contribution graph than I do. Kind of. Now, you might be wondering, well, are progressive web apps unique to Chrome? They're often talked about in the context of the Chrome browser. And the answer is absolutely not. In fact, if you take a look at Opera on Android, you'll see that they've got a strong progressive web app story as well. They've got things like the web app install banner working, splash screen, offline support thanks to Service Worker. And it's not just them. If you take a look at Firefox on Android as well, they've similarly got a lot of explorations in this area going on. Add to home screen features, offline support, web app install banners being experimented with at the moment. When you're building a progressive web app and you have progressive enhancement as sort of a core tenet of the experiences you're trying to craft, they just work for everybody. Regardless of whether they're on Safari on iOS or they're trying to look at your content from an area that might have seriously limited connectivity. When you're crafting these experiences with architectures like server-side rendering in mind, it just makes sense to be able to ship faster experiences for everybody. You might also be wondering, well, are progressive web apps a Polymer-only thing? At I/O this year, we did show a first-class experience for building progressive web apps using Polymer. But you can use any tech stack to create progressive apps. In fact, over the last few months, we've seen an increasing number of really large apps launch using progressive web app features. The first one is 5 Miles, sort of a Pinterest meets Craigslist. They launched a full progressive web app with an application shell architecture, add to home screen, splash screen. This was built using AngularJS. And they found that their add to home screen experience led to 30% better conversions. Similarly, Flipkart, they saw 3 times more time on site with their progressive web app, 70% better conversion rate from their add to home screen users. That's an app built using React. And just last week, we saw Celio app, which is a local market app for buying and selling goods locally. This is an app built using React, Express, Flux, uses universal JavaScript. They found that their average session length inside the progressive web app equals native. And they also found that the user acquisition costs were 10 times cheaper than native. Because they used web push notifications, they saw improved user retention. And they used server-side rendering and found that that reduced bounce rates with things like sharing posts and buying ads. So today we're going to talk about how to build progressive web apps using React, Angular, and Ember.js. Before we do that, let's talk about waiting. Waiting is something that we all have to do as a part of our daily lives. It's sort of this frustrating thing. You could be at a restaurant waiting for someone to bring you a menu or waiting for someone to bring you your food. And 20 or 30 minutes could easily pass by, and you're still wondering, should I go up? Should I ask someone for a menu? Should I ask someone if the food is ready? You could be waiting maybe an hour or maybe 2 hours. It gets to a point where you start questioning your life choices and you start wondering, should I just eat my wallet instead? On the web, the equivalent of this is your users, considering leaving your site or your app. And that's not something that you want. So the key differentiator between the old web and the new web is native apps have got reliable performance, and that's something that we'd like to be able to strive for with the experiences we're shipping on the web. So how do we deliver native caliber features while still being able to use JavaScript libraries and frameworks? Well, before we talk about that, there are a few key moments that we need to keep in mind when it comes to user experience and performance. The first is it happening? Time to first paint. Now, this is when you're showing your user a splash screen or a loading indicator, basically some feedback that communicates your navigation has started in your page. Next, you have time to first meaningful paint. This is the is it useful moment. This generally focuses on paints of above the fold content, headline text, something that they can actually use and find useful. Then you've got time to first meaningful interaction. So is it usable? If the user goes and starts tapping around your UI, is something useful actually going to happen? Now, at I/O this year, we announced a new tool called Lighthouse. Lighthouse is a Chrome extension and a CLI that checks that you have your progressive web app features in check. It also has initial support for loading performance metrics. Also on this slide is Web Page Test. It's a tool that's been around for quite some time, but it basically helps you performance profile your sites on real-world devices with different types of network connectivity profiles. Now, one metric that both of these tools look at is the speed index, a metric that looks at how visually complete a page is. And for the apps that we're going to be looking at today, the React apps, the Angular apps, the Ember apps, our targets on cable are going to be a speed index of 1,000. So ideally, things loading in under a second. On 3G, our target is 3,000, so under 3 seconds. And on repeat view, using Service Worker, our goal is to make sure that we're loading things as close to 0 as possible. If it's under 1,000, that's great, but as close to 0 as possible. So at I/O, we're talking about killing the offline dinosaur. Ideally, you want to be able to build experiences where you're no longer having to play that game. You're actually giving your users something valuable. I spent 2 hours on this slide and make poor life decisions. I'm sorry. The underpinning of this is Service Worker. It's basically a script that runs in the background, separate from your page, responds to events like network requests, and basically gives you the ability to define really well-crafted offline experiences. Now, Service Worker gives us the opportunity, really, to start rethinking our application architectures. One such architecture is the application shell architecture. And the idea here is that we try shipping down the network as quickly as possible, just to put the content necessary to load up our application UI. So things like the toolbar, the drawer, maybe some cards. And then later on, we dynamically populate that view with our content. Now, this type of model works particularly well for single-page applications, but it's nuanced. You might be working on a content-heavy site, and it might be more important for you to get actual text down to your users first. So just keep that in mind when you're evaluating your options when it comes to these types of architectures. But if the application shell architecture does make sense for your app, the way that you achieve some of these improvements in addition to Service Worker is doing things like relying on critical path CSS. So inlining the critical styles for your application shell in the document head, and then asynchronously loading in the CSS and JavaScript needing for the current view. We can then use things like the async attribute on script and libraries like load CSS from the filament group for being able to synchronously load in the content that we need. And the performance wins of such a model are actually quite stark. What you'll see if this is working there, is on repeat view, it's almost instant. This is like the simplest version of the application shell architecture we could come up with. And you've got instant performance for the repeat visit compared to the first visit where it took much, much longer. So let's talk about React. React is a UI library for creating interactive, stateful, and reusable UI components built by Facebook. Uses a virtual DOM, try doing the least amount of DOM manipulation, try keeping your components up to date, and it works really well on both the client and the server. Now, I'm a big fan of Hacker News. I use it every day, and I thought, maybe it would be useful to be able to try using Hacker News offline. Unfortunately, Hacker News doesn't work offline on the site. You'll get the dinosaur if you try using it. By the way, this is the dinosaur that we have over in the mobile web area. You might notice that it seems to have like 4 legs for some reason and 2 arms. I just wanted to clarify on behalf of the Chrome team, the back 2 legs have been deprecated, but they haven't been removed just yet. Plan on. So back in 2014, Hacker News actually announced that they now have an API, an open API that anyone could go and build a Hacker News client with. And that API was based on Firebase. This is a real-time API. Anytime someone goes and makes a comment, you can actually stream that latest content through to your Hacker News clients. And so I decided to go on GitHub and try to find out if anyone had been hacking on a really interesting Hacker News client. And I found this one by Johnny Buchanan. This is a really nice client. It lets you take a look at all the different views available in Hacker News. You've got new comments, show, ask, jobs, and it'll highlight anytime a new comment is updated or someone has gone and edited their comment. Unfortunately, this didn't work offline either. And so I thought, it would be kind of interesting if we went in and explored what it would be like to take this complex React app and turn it into a progressive web app that worked offline. So the first thing we needed to do was make it responsive. And I know that sounds silly, but it's still quite a common thing for people to forget this one step. So we went in and we optimized things like the amount of viewport real estate being used on mobile. We wanted to make sure that it actually used up as much space as possible on iOS and on Android. We wanted to avoid things like overlapping menu items, so we fixed those as well. All of this is just done using media queries, and it's nothing particularly special. The next thing we added was the web app manifest. So I went into this project, and I noticed that they had a really tiny favicon, and that wasn't going to cut it. So I redid all of the artwork in Sketch, and exported all the icons out and set up a web app manifest so that we could launch this thing from the home screen and get a splash screen. This is what the manifest looks like. It's nothing particularly crazy. But we basically have a background color set for the splash screen, and we have another color set for the theme color, and we've got our icons defined in there as well. Now, this application is actually a lot more complex than it might initially seem. We have this large set of complex real-time data being streamed to the client, and then we have this application UI, this skeleton, that we're using across all of our different views. So we're going to split this problem into 2 parts. The first is caching our application skeleton, and the next part is going to look at content caching. Now, for caching our application skeleton, we're going to use 2 libraries, SW Precache, which is a build tool that will go and help you precache all of the assets that you need for your first application shell render. And then SW Toolbox, which is a library for handling all of your dynamic views and content that might get rendered later on. Now, in this application, like many React apps, we're just using Webpack behind the scenes for our module bundling. But Precache can actually be added on after the fact. So here I've just got some NPM scripts set up for this project. I've got SW Precache set up as just another step that I run after my build is completed. And I'm configuring it using a precache config file in my package.json. So this is what the config file looks like. It's basically importing in toolboxes. It's importing in some rules for runtime caching. And I'm able to configure things like what other files I might like to have cached inside there. Now, in runtime caching, I can specify what other origins I would like to be cached. So in this case, I've set it up to cache anything coming back from Firebase, from the Hacker News Firebase API. And I can also set it up to cache things like Google Fonts or anything coming back from the Google CDN. My last step is going and actually registering my service worker. So I add the boilerplate code to my index file and just make sure that it's registering the service worker that's being generated by SW Precache. And once I go and I load up my page and I look at a repeat view, I can see that all of my static assets are now being served from the service worker cache in DevTools. So I go into airplane mode and I check out this app, and I'm happy. I've already opened this up before. I'm starting to look at content I've seen previously, but there's something wrong here. Although my application shell consistently renders really, really fast offline, as soon as I close that app, I'm still in airplane mode, I launch it from the home screen, I get this, no content. The reason for that is that Firebase's offline support is limited to the session that the user currently has. As soon as you close that off and you try going and relaunching from the home screen, you're not going to be able to get that same session data back. You need to actually cache it a little bit separately. So that leads us on to content caching, and something I've spent the last 4 weeks trying to solve. So Firebase generally, because it's real time, it works using WebSockets. This is us just expecting some WebSocket frames in DevTools. You've got little bits and pieces of comment data and metadata that you might use to construct a comments page. Now, I first thought, maybe it'd be an interesting idea to store anything that comes back here in IndexedDB. Unfortunately, I'd forgotten that IndexedDB is the worst API known to man, and should probably be burned. Luckily, there exist a number of really good abstractions for working with IndexedDB, things like local forage, Dexy, IDB by Jake Archibald. And so here we are inside of our React app once again. I'm just consuming the Firebase API the same way you would today. And I thought, maybe I could be a little bit clever. What if I built some middleware that would basically proxy anything coming back from the Firebase API to IndexedDB, and we just stored that? It seems like a not terrible idea, right? It seems like it would be fine. Unfortunately, what happened there is if you went and saw any story on the top stories page, and you opened it up, about 10 to 15 seconds later, you'd end up with 3,000 or 4,000 records in IndexedDB. You wait another minute, it'll grow to 4,000 or 5,000, because you're dealing with real-time data constantly updating IndexedDB as you go. On mobile, if you open up an app where you've had like a large number of records stored because you've been looking at lots of pages, you want all of them to work offline, what will happen is that in this app, we had to iterate over the entire collection. It ended up grinding Chrome to a halt, and that just wasn't good enough. So I then said, OK, well, maybe I should rethink this problem a little bit. What if we just used web workers? So I was using local forage. I thought, OK, I'm going to batch all of my writes for this application and only try storing them maybe every 30 seconds instead. Unfortunately, IndexedDB is still really bad when it comes to these types of problems. And I found that just still wasn't good enough for this app. And I had this revelation. I was sitting in an airport lounge, and I thought, well, I don't really need this data to be entirely fresh. I don't need it to be updating every second, so I have every single comment. And I realized that Firebase actually has a REST API. And the REST API allows you to basically go and fetch a static version of content from a JSON endpoint. And that's something that's much, much easier for you to cache. So imagine we have our comment page, and we have all of these different comments. I just have like JSON endpoints for every single one of them that I can go and cache. And that's what we do. So I introduced an offline mode into the React Hacker News client. Here I am. I'm still online. I've launched my app. And I'm just going to go and take a look at one of the Google articles here. You'll see that this is a page that has a lot of comments. There's a lot of content here. We're scrolling. Maybe I'm on the tube or on a bus or something. But I still want to be able to view that content offline. So I'm going into airplane mode. I'm just going to relaunch that app. And with content caching in place now, using the REST API, I can actually cache all of that data in the Service Worker Cache API instead of just using IndexedDB. And as you'll see, it just works. I can load up any of the pages I've previously visited, and they'll just work fine offline. I ended up delaying a 300-person flight 10 minutes just so I could get the pull request in for this feature, because that was how happy I was I got this working. Now, one of the lessons there was that I had to rethink what I wanted my offline experience to be. The technical side of getting Service Worker set up and caching set up, that wasn't hard. It was just crafting the right user experience. Next, we're going to talk a little bit about universal rendering. So Paul Lewis put up these really interesting graphs a few weeks ago. He said that in a JavaScript-based render, you're usually reliant on all of the script to be downloaded, parsed, and evaluated before you can render the page. This ends up wasting a lot of time when the HTML arrives to when you give the user something meaningful on the screen. Something slightly better is the situation where we see a lot of frameworks moving in at the moment. You have a server render with hydration, where you send a view to the user. The downside of this is that you're still reliant on the JavaScript to actually be loaded up before someone can interact with your application. And this can result in a little bit of an uncanny valley, where the user sees that, the application, but they tap and nothing actually happens. Somewhere that would be amazing to see a lot of frameworks move to is this idea of progressive rendering in Bootstrap, where you send a functionally viable but minimal view in HTML with your JavaScript and CSS, and the app progressively unlocks more features as the user starts traversing and navigating around it. So I'd love to see more of us move in that direction. For the server-side rendering portion of the React HN app, React Router was just amazing, worked really, really well on the server. We found that we were able to reuse most of our routes with very little effort. We just put together a very quick Express server to get this set up. Some of the little lessons that I learned along the way were just making sure that we properly guarded ourselves around globals. This app was still making use of things like local storage and session storage, so we had to guard ourselves so that wouldn't fall over. We had to minimize reliance on things like the DOM. The previous author was doing things like using the DOM to parse out the host name, so we had to just switch away from doing that. Now here's where we ended up. We started off in a place where on cable we had a speed index of 2063. And by the time we'd added service worker and server-side rendering, and we used all of these content caching techniques together, we got to a place where we had a speed index of almost 1,000, so close to perfect. Now on 3G, where it's even worse, we're still in a pretty good place. We're in a place where we started off with a speed index of almost 4,000, and we end up in a place where with service worker caching and content caching, we've got a speed index of 1,400. Now, these type of experiences, this is something that I've done just over the last couple of weeks on an existing large React code base. So if you're in a position where you have something similar and you want to turn it into a progressive web app, it's very, very possible. The tools are just there. So I encourage you to try that out. Next up, we have AngularJS. So Angular is a framework that's been around a very long time. It tries to tackle building complex applications, originally focused very much around being data first and using declarative HTML and data binding. I'm going to talk about Angular 2, but before we do that, I know that there are still people that build on Angular 1 or have existing legacy Angular 1 apps. And you might be wondering, well, a lot of this progressive web app stuff, great. Does it work with Angular 1? Yes, but with caveats. So I tried building an Angular 1.5 app just to demonstrate this, and I was trying to think of what app I would build. I initially thought of building like an app that would show me the nearest places I could go and skydive. Then I realized that I don't skydive. The closest thing to me skydiving is probably zooming in on a Google map really, really fast. And that's basically the same thing, so I'm fine with that. So this is the app that I built. It's called Cherry. Built this in about an hour or two. This is using Angular 1. As you can see, we've got add to home screen features, splash screen, offline support with service worker. Unfortunately, the downside to this app is that it just doesn't meet our performance budgets. You take a look at, on 3G, you take a look at, where your goals are for fast first paint. It's taking 2,500 milliseconds for first paint in this app. Our speed index metrics are, 8,000, 8,400. That's crazy. We shouldn't be taking so long for our users to actually be able to start using this application. Luckily, with Service Worker in place, we are able to slash these numbers in half. So if you're in a place where you can't, in the near term, move over to rewriting your application to use a modern framework, I would consider using Service Worker. You're still going to get some wins there, but it's not going to be quite as good as something that has support for server-side rendering and is developed with mobile in mind. That takes us to Angular 2. So Angular 2 is component-based, uses directives, and has an improved dependency injection model. And the Angular mobile team have recently been focusing a lot of their time trying to make it easier to build progressive web apps using their tooling. So we're going to talk a little bit about that. Now, to get started with Angular 2 apps, a lot of the time, they'll recommend using the Angular CLI. This does everything from setting up your TypeScript and typings for you, bootstrapping your app, using System.js to load up your app. And so we're just going to use that to very quickly scaffold up a new app. Now, one thing to keep in mind is a new flag called mobile. Now, what mobile will give you is all of this. When you create a new app, it's going to give you a few extra things that help you make a progressive web app. Things like going and scaffolding you out a web application manifest, a build step to generate your application shell for your application's root component, and service worker support for application caching. So things like add to home screen are possible. You'll still get the splash screen. You'll still get your add to home screen icons. All of those are fleshed out for you. And the manifest doesn't look too different to the manifest you've looked at today. It's exactly what you'd expect it to be. Now, most of the time when we're developing apps, we use a site called realfavicon-generator.net to generate our icons for us. It just avoids you having to handcraft these yourself. Next up, we've got the application shell. So by creating a new project with the Angular CLI and the mobile flag, the application already has a build step configured to go and generate you an application shell from your root component. So here, we're going to just use the main component that Angular CLI created for us to create our application shell. We're going to do something with Angular material. So let's say that we will just add a toolbar to this application. So we npm install the dependencies we need for this toolbar. And then we register the toolbar inside of our main Hello Mobile component in this case. So we see that we've got application shell directives that are going to help us with setting up the application shell. We've got our toolbar in place. This isn't particularly useful just yet. So we're going to go and we're going to add in a proper toolbar in there inside of our template. So it says Hello Mobile. So far, this is fine. This isn't particularly exciting. What is exciting is these two little helpers. So these two helpers are shell render and shell no render. And these are kind of badass. So shell render will allow you to define any UI that you want to display on the screen before your main Angular bundle has completed asynchronously loading in. Shell no render is what's going to be displayed after the entire application has fully rendered out, meaning that you can define your application shell declaratively right inside of your component. So in this case, we can do things like just make sure that the toolbar and at least a loading spinner, so that thing that we wanted to achieve for first meaningful paint is in place, and then we can use shell no render for anything else that comes after the fact. Now, the Angular Mobile Toolkit comes with support for generating a service worker that will automatically cache your assets for you. It doesn't yet entirely support things like dynamic caching, but it does support caching for your static assets. And you can go and you can start using these on serve, using the prod flag, on build, again, using the prod flag. I've been hacking on a little Dribble API client called Berry using this stuff, and I found it particularly good for that. Offline support wasn't very difficult to get in place. And using the CLI, it's actually going to scaffold you out one of these files in the background. So this is an Angular service worker manifest. It contains basically all of the files that are going to be cached, as well as a hash that allows service worker to know whether or not they're stale or not. So what do the numbers look like? We're going to take a look at an Angular weather app that the team have been working on. And this uses the application shell model, it uses Angular CLI, it uses a lot of the tooling that they've recently been working on. And with Lighthouse, these are the metrics that we currently get. So first paint is about 1,083 milliseconds. That could be better. Speed index is 2,271, and the speed index on repeat visit is 599. Now these aren't terrible numbers. These are actually pretty good numbers, but we can do better. So recently, the Angular mobile team have also been looking at offline compilation. Now, in Angular 1, template compilation can happen many times during your application's lifecycle. And Angular 2 tries to move some of this work into a build step, making it a lot more efficient. So offline compilation happens during a build step, as I said, and it no longer happens during the browser. So we convert things like templates into code on the server so we don't have to ship the compiler at all. And what this leads to in terms of application performance is some stark differences. Fast first paint is happening at 479 milliseconds. Speed index is almost exactly where we want it to be. It's very, very close to 1,000. And repeat visit is close to nothing. You're getting what's basically an instant application on repeat visit. This is kind of awesome. Now, we also wanted to take a look at what server-side rendering would look like for these applications, because we can still squeeze out a little bit more performance here. So getting your users a first view really, really fast is kind of critical these days. And Angular Universal basically helps you achieve this with pre-rendering on the server. So the way this works is whenever a user goes and they click on a link to your web app, Angular Universal is going to server-side render the initial response, get it to you. So the user has at least some UI in front of them they can take a look at. A couple of seconds later, it'll then asynchronously load in the rest of the bundle. It'll bootstrap, the client will take over. This is sometimes called hydration. And it just means that you lead yourself to having a pretty good perceived load time performance overall. Some of the interesting things that I came across in this experience over the last couple of weeks was that this notion of user events being stuck in uncanny valley is pretty much consistent across like React, Angular, and Ember. Even with server-side rendering, your first view, you're going to still end up in places where your user can still end up clicking, touching pieces of UI where they're trying to have things happen, and they'll just be stuck until your entire content bundle has ended up there. So in the Angular community, gap events is the term that they use here. So things that the user is going to try accomplishing while they're still waiting for bootstrapping to occur. But thankfully, the Angular team have been working on an interesting solution called pre-boot that basically allows you to respond to and play back events. So I'm not saying this is the perfect solution to this problem. It's kind of very interesting, though. If the user does try interacting with your app, as soon as it has finished bootstrapping, it will replay all of those events for you so that they still, they're not having to redo work. It's kind of interesting. So to get this set up, again, we use Express. We just import in Angular Universal, which doesn't take a lot of work. And this is what the numbers look like. We start off with a speed index of 2,640 on 3G. Once we've added in offline compilation, service worker, universal rendering, we're down to almost nothing. you're in a place where universal rendering has made a huge difference. And this is very much true of the React app we were working on earlier as well. Server-side rendering makes a huge difference, really huge difference. And as you can see, with Service Worker in place again, repeat visit is close to nothing. Users are going to feel it being instant. Now, the Angular mobile team are working on making all of the developer conveniences around this stuff a lot more low friction. Some of this work is still very much early on. They're working on improving their service worker support, adding pass-through caching support, a data savings mode, making sure that they're looking at HTTP2 and how that interacts with service worker, and just improving the docs. So if you're working on an Angular 2 app at the moment, go check out Mobile Toolkit. And finally, we have Ember.js. Now, Ember is a framework for building ambitious web applications. It utilizes components. Routing in Ember is a core tenet there. And the Ember router, similar to the React router, works just fine on both the client and the server. Now, interestingly, frameworks have a bad rap when it comes to performance, right? Henrik Jortig recently said that in his opinion, the data for Angular and I think he was talking about Angular 1 and Ember flat out disqualified them for mobile use. And this is mainly down to bundle size. Like Ember as a framework still has a relatively large bundle size. Now the Ember team acknowledged this a couple of months ago, and they've been looking at how they could improve the situation with mobile in mind. So they've taken a look at both first boot and repeat boot for this problem. Now, on first boot, they're looking at fast boot, so their solution for server-side rendering. And I really love fast boot. We'll talk about it in a minute. And on repeat boot, they're looking at service worker. They're also looking at some other interesting ideas, things like string loading, which basically means shipping JavaScript modules as strings so that you only pay the evaluation cost for the modules that you're using, and Project Svelte for stripping back features that you're not using in Ember. I was trying to think about what progressive app I'd build for this, and I came across the idea of building a puzzle app that would just say go outside when you're complete. It's maybe not the best idea. But I ended up on Super Cool Blog, which is basically a blog app. This is the final thing that we end up building for Ember. Basically, this is an offline-first Ember application that works instantly, meets our performance targets, uses server-side rendering, works without JavaScript enabled, by the way. So let's take a look at how something like this can be constructed. Now, applications in Ember are crafted using the Ember CLI. And you go and you just install it, let you scaffold out your application architecture, a very basic file structure, go and serve it. You get a very, very basic app out of the end of that. Now, routes and making sure that your routes are right and you have a good routing setup will make things like server-side rendering so much easier. So we make sure that in this application we've got our routes figured out. We've basically got very simple routes. We've got one for different categories we've got going on. We want to display articles for. And all of the content for this application actually just exists in JSON files. I could be using a backend, an API of some sort. I could just be caching stuff coming back from Firebase. But in this case, I just have all of my data locally. And it just makes caching a little bit easier. So this is what our very, very basic application looks like at the very start. So we've used Ember CLI, we've scaffolded out our views, added some CSS. We're just using templates to load in the content. It's nothing particularly complex just yet. Now the first thing we're going to do is add in the web app manifest. Similar to the other sites, it's not particularly difficult. It's like something that takes 5 minutes a lot of the time. So we add this in, and this just makes sure that when the user comes to trying to add the site to their home screen or launch it, they're able to get home screen icons, splash screen icons in place. Next up, we have service worker support. Now, about a year ago, the Ember team said that they'd been watching some of Jake Archibald's service worker videos, and they were really excited about them. One of the things they wanted to do, and this is true, I think, of a lot of frameworks, is they want to take web platform features and try to make them usable for their users with as little friction as possible and automate that process as much as they can. So Ember wanted to make this something that's free. They're not quite yet there with their baked-in support for service worker, but luckily the community put together an add-on for Ember CLI called Broccoli Service Worker. Now, one of the cool things about Broccoli Service Worker is it happens to build on top of Service Worker Toolbox. So that thing that we've been using for our React app earlier on. Now, the configuration for this looks a little bit like this. Basically, we're inside our Ember environment. I'm just saying that I'd like to make sure that debug messages are enabled and the service worker is enabled. But I can actually get control over a lot more of my offline experience, being able to set things like network first URLs, paths to include and exclude, And when it comes to Service Worker Toolbox, you actually get quite a lot of control over different network strategies. You're able to say, well, I'd like you to go out to the network first and then fall back to the cache, or use the cache first and then fall back to the network, or try to race both strategies and make sure that whichever wins actually delivers you the content. You've got a lot of flexibility there. So once we have offline support in place, I'm able to launch my application in airplane mode and just view any of the content I've previously seen. I can go and read articles, I can go and look at menu items, and all of it just works offline pretty seamlessly. Now, next up we've got server-side rendering with Fastboot. Now, I've got to be completely honest. When it comes to server-side rendering and adding it after the fact to a framework-level application, Ember has got this just down to an art when it comes to Fastboot. I found this like the easiest thing to set up, and it took very, very little configuration. So Fastboot is basically a middleware for rendering Ember apps on the server. The idea is that in a traditional client-side app, your browser is first of all going to have to request a bunch of different static assets from the asset server. And while those are loading, your users are just going to end up having to look at a white screen. So the way that they solve this with Fastboot is by running an instance of Ember in Node on the server. When a request comes in, we already have the app warmed up in cache and memory. And they just tell the URL you're trying to reach that you want it rendered on the server and send it back down. So you install Ember CLI Fastboot, an add-on to Ember CLI. And the one thing I had to keep in mind here was just making sure that anything I'm using that's going to be fetching data from other origins or an API takes in mind that you're going to be running this code both on the client and the server. So you end up needing to use an isomorphic or universal fetch implementation. And thankfully, Ember have got one of those. So I just switched in the fetch implementation that I was using so that anytime I fetched client-side data, it would work fine on both the client and the server. And I end up with this. I'm basically able to get server-side rendering working fine. This is actually working pretty fast on Safari on iOS as well. It might not have service worker support yet, but server-side rendering just works fine. Now, one of the benefits to this is, of course, that the content from my application is all just there. I'm not waiting for any JavaScript in order for the user to actually be able to read the articles. If they're in a place where they have limited network connectivity, everything will just work. Another benefit is that this works without JavaScript enabled as well. Now, you might be wondering, well, OK, great. I can read content, but what about my user UI? I spent a little bit of time recrafting the drawer menu for this application entirely in CSS. And that just means that my user is able to use some UI with the content in place, even if my JavaScript bundle is still loading with the rest of the framework. And then we've got a little bit of final performance optimization to squeeze as much as we can out at the very end. So this is what our index looks like for this application. It's using some template helpers. And one of the things I want to add is that critical path CSS that we talked about earlier for the application shell. So we install an add-on called Ember CLI inline content. We configure that inside of our Ember CLI build. Basically, for this application, it's not got a lot of styles, so I don't really need to do anything special to get my critical path CSS. I'm just going to inline the entire style sheet inside of my document head. And finally, we've got that one problem of large frameworks still being large frameworks. And unfortunately, this is something that the frameworks still have to solve on their own. Now, Ember, before you gzip it, is almost 700 kilobytes in size. And I don't want that necessarily to block rendering. Now, ideally, I would just be asynchronously loading in both my vendor scripts as well as the main application code for my app. But in this case, I'm probably going to end up having to use something like defer because Ember doesn't actually concatenate scripts for you by default. And we've also got things like gzipping that we could probably be doing inside of the application. So gzipping is something we can also take care of when it comes to deferring. So the async attribute allows script to be downloaded in the background without blocking the page, right? Defer claims to do the same thing, except it's supposed to guarantee script execution order. The spec says that it should be downloading all of your scripts together and executing them before DOM content loaded. Unfortunately, in some older browsers, that's not exactly the case. In IE, less than 10, it might execute your second script halfway through the execution of your first script. Yay, browsers. But We're still going to just use defer in this case to avoid blocking. But at the very end of all of this, so we've got server-side rendering in place. We've got service worker in place as well. We've taken a speed index of almost 3,000. We've trimmed it down with server-side rendering using fast boot, trimmed it down with the optimizations we've made even further. And we end up in this place where on repeat visit, it's close to instant. It's close to nothing. Now, I'm really, really excited about the Ember team exploring how to bake in more of these ideas directly into the CLI. I'm also excited about the Angular team doing this, and really excited about the React community embracing Service Worker as a core tenet in the applications we're building there as well. So, the 3 takeaways for today are do less and be lazy. If you're going to be trying to ship bytes down to your users, try to ship the thinnest, smallest bundle possible. This will benefit absolutely everyone. And be lazy just means lazily load in everything else that you need after the fact. Design for constrained environments. You know, a lot of the time when we're building things these days, we're testing things out on high-end phones or high-end computers. A lot of our users aren't going to have that. They're not going to have a perfect internet connection all the time. They're going to be in places where they'll have limited connectivity, maybe using devices that are like CPU bound or aren't as powerful as the things that we're testing on. So if you're developing with constrained environments in mind, you're going to be able to ship experiences that benefit everyone, and they'll hopefully lead to performance improvements there. And go progressive, because now is a good time. Looking at all of the frameworks and libraries that we've been looking at today, all of them are exploring things like server-side rendering. All of them have got the ability to use Service Worker as a first-class citizen and have it work well and lead to performance improvements. Have it lead to reliable performance, that thing that we're trying to hit with progressive web apps. Everything else, everything from setting up your web app manifests and so on, that stuff is still quite trivial to do. And that's not to say that instant applications with things that I've shown you today are the end. It's really just the beginning. There's still a little bit of work that we have to do on both the JavaScript engine side and the framework side when it comes to performance after the fact. So I've been focusing on load performance a lot today. There's still a lot that we can do after the fact so that when your users are interacting with the app, it still stays instant after that. So please go check out our new progressive web app page on Web Fundamentals. I hope that this has been useful. Thank you.
Consider the simple URL. A few years ago, these were pretty straightforward. You clicked on one, and 9 times out of 10, you went to a web page. Then things changed. People started using their mobile devices for, well, everything. And these devices in turn started supporting the idea of deep links. Click on one of these deep links, and it could take you not just anywhere on the web, but anywhere in an app as well. So you could use a deep link to point directly to a specific restaurant inside a reservation app, or give your new customers a personalized welcome based on the link that brought them to your app in the first place. At least, that's how they worked in theory. In practice, deep linking had issues. The same link wouldn't necessarily work on an iOS or Android device, and they behaved very differently, or didn't work at all, for users who didn't have your app installed. And for people who did install your app through a deep link, all of that great link info was typically lost during the installation process, leaving your personalized warm welcome out in the cold. So while deep links were great in theory, their uses were a little more limited in practice. Enter Firebase Dynamic Links. Firebase Dynamic Links are deep links that work the way you want them to. So you can create one single link that behaves one way on iOS, another on Android, and even a third on a desktop browser, and it will take you to a place that's appropriate to that platform. You can also set up dynamic links to change their behavior depending on whether or not your user has your app installed. For users who don't have your app installed, maybe you send them to your website, maybe you take them to the Play Store, or maybe you show them an interstitial describing the benefits of your app before you take them to the App Store for a smoother transition. More importantly, these links can survive the App Store installation process. So if your user installs your app when clicking on a dynamic link, all of that information is still available to you when your user opens up your app for the first time. So what does this mean? It means you can use dynamic links the way you've always wanted to use deep links. You can use them in marketing campaigns, from email to social media to banner ads to, heck, even QR codes. And in addition to install attribution tracking, the kind that lets you know which campaigns are getting you the highest quality users, you can also give your users a customized first-time experience based on the campaign that brought them there. So if a user installs your music app because you showed them an ad for classical music, you can make sure your app takes them right to Chopin's latest hits when they first open it up. Dynamic links are great for sharing too. Your users can use them to share recipes, links to their favorite level in your game, or even coupon codes. In fact, dynamic links are the technology that powers Firebase invites. And because dynamic links are a Firebase product, you can see their stats directly through the Firebase console. Find out how many people clicked on a link, or use Firebase Analytics to find out which of your users first opened your app through a particular link. To find out more about dynamic links, check out the documentation here and give them a try. And deep link away.
Bitcoin represents a way to transfer money anonymously and at almost no cost. And since it's an arbitrary currency with no nationality attached to it, you're free to exchange it with anyone in the world. What is money? Resources are limited, and they hold explicit value to people. Most resources are physical, and such needed to be traded in a physical form: diamonds, gold coins, chickens, or bikes. At some point, it becomes too difficult to physically transact those objects, and it's easier to agree, collectively, on the value of cash instead of gold. As we know today, this has many advantages. Credit cards and the modern banking basically gave us another abstraction layer on top of cash. There is a centralized system which defines who owns what resources. All of these trades are made virtually. This is the backbone of why Bitcoin is a valid idea. What is Bitcoin? Bitcoin is decentralized, anonymous, digital-only currency that recently received public attention. Bitcoin was originally developed in 2008. Like in any good mystery, someone using the alias Satoshi Nakamoto published a paper describing how Bitcoin could work. There's a very interesting story about this guy too. He must be very smart, but he never came forward to claim ownership or any part of the revenue. Just 1 year later, in 2009, Bitcoin started being traded. Where do they come from? Think about gold. You could buy it or mine it, and it's the same concept with Bitcoin. You do this by using your computer to hunt for 64-digit numbers. By having your computer repeatedly solve complex mathematical puzzles, you're competing with other miners to generate the number that the Bitcoin network is looking for. If your computer generates it first, you receive Bitcoins. The Bitcoin system is programmed to generate a fixed number of Bitcoins per unit of computing time. It is also self-sustaining, coded to prevent inflation, and encrypted to prevent anyone from disrupting its code. In the year 2140, the total number of Bitcoins in circulation will be capped at 21 million. So how much is a Bitcoin worth today? You'll need to Google it. Just type Bitcoin in US dollar, for example. You could also check it out at priv.com. Why are they anonymous? Bitcoin are pseudo-anonymous because they are built upon this centralized system. The Bitcoins themselves are anonymous. The wallets are not. Here is why. The base algorithm creates anonymity, but as the recent court cases show, if your Bitcoin wallet is identified and attached to a person, then someone can go through and track every transaction you've made. Bitcoins exist entirely on their own because there's no central infrastructure to shut down. You are identified by nothing more than your Bitcoin wallet address, a string of randomized letters and numbers. There are absolutely no identifying characteristic beyond that. For the paranoid dude, you can simply create a new wallet for each transaction. Here are some interesting startups that push the technology forward. We are still in the initial phase of Bitcoins, and there are many challenges and opportunities ahead: exchanges, wallets, merchant services, security, and more. But this is something for another episode. Until next time, eat your vegetables and listen to your partners.
One word that's the bane of both the novice and expert programmer alike: threads. I'm Joanna Smith, and threading can be one of the greatest perf improvements you make, but it will also likely drive you crazy. Tom Sawyer illustrated threading perfectly a long time ago when he needed to paint that fence, because when you've got a large chunk of work to do and it's the same work over and over again, you call in some friends to get it done quickly. So for computations that are taking a long time, consider calling in reinforcements with threads. By allowing multiple threads of execution to operate on your dataset in parallel, you reduce the overall time required to complete the task. With Android, threading becomes especially important because the entire app runs on the main thread, which is also called the UI thread because it updates the UI. And when the UI stops responding, users stop using your app. So, when you want to perform some complex action in response to a button being pushed, for example, you'll want to move that off the main thread until it is finished so that the user can continue to interact with your app. Because there are few things worse than the dreaded application not responding dialog. However, integrating threads into your system is not for the faint of heart. You're going to have to rethink your entire approach to computational complexity and to your memory model in order to properly integrate threads. So, to avoid the rabbit hole, take advantage of the Android framework, which has been built to help you out. Careful thought and planning about your app's structure and flow will enable you to determine whether a thread should affect the UI or be entirely hidden. APIs like async task and thread both help you manage the work and keep your app from hanging, but async task will also allow you to affect the UI, like when you want to display a progress dialog. So take a walk through your own app and see if there are places where it stops responding or gets exceptionally slow in response to a user action, and then move all of that extra work off the main thread. But, thoughtfully. Don't just change things willy-nilly. Because while threading may be intimidating, it shouldn't scare you. What is scary, though, is bad performance, which is why you should check out the rest of our Android performance patterns content and consider joining our G+ community for tips, tricks, and help. But most importantly, keep calm, profile your code, and always remember, perf matters.
Hello and welcome to Supercharged. Now this is a kind of TLDW. Last week I did a live stream with Surma where we made some swipeable cards. Now you probably recognize swipeable cards from things like Google Now, where you just kind of take a card and you dismiss it. And you can actually see what I've got on screen. This is what we ended up making. There you go, you see? Dismiss it and all that kind of good stuff. Now the idea is, if you've not got an hour to watch that live stream back, although if you can, I would recommend it, and you can find the link to that below. If you can't, that's exactly what this is for. I want to step through the things that we learned, the things that we did, and just so you can get an insight into what actually went into it. So, before we actually get started, what I want to do is I want to step over to Theory Corner. Oh yeah, theory. Love theory. And what we can do in Theory Corner is discuss what we need to do. Join me. Welcome to Theory Corner. You can tell it's Theory Corner because there's some theory in a corner. Now, this is what we have. We've got the cards. You can tell it's a card because it says card. The cards have will change transform on it. The idea I have here is that we want each card to be transformed around the screen. And so we want to give each card its own layer. The compositor then can move those around with the help of the GPU. So long as we stick to transform, opacity, and we set will change, we should be good. So we move the card as you touch and swipe. But as you get across to this side, we have this marker of like 0.35. Now I picked that at random. You could pick a different number. 0.35. If you go past that point, we basically say, well, this card is being dismissed. So we slide it off to the side. The other thing that we're going to do is we're going to change the opacity. So the further you go across, the lower the opacity in both directions. So that works there. Okay. So we're going to put each card on its own layer, shift it side to side, and fade it out. Let's go back to reality. What we're going to do here is we're going to step into the code so you can actually see bit by bit what we actually did. Here's the cards, and what we do first of all is we basically create an array from the cards that we've got in the document. So we'd have to have some kind of code that adds or removes those cards later on, but don't worry about that. We'll just get on with what we've got here. The next thing to notice is that I've got these named functions on start, on move, on end, and update. Now the first three are our input events, and I choose to do it this way. What I do is I take a copy of it by calling .bind on this, and that takes it from the prototype into the actual instance. But it does another thing for me as well. It means that it's bound to the instance so that in those functions, when I say this dot whatever, it's actually applying to the instance and not to the target's event. No, wait, the event's target. Oh, one of those two. So it also does something else for me. It means that I can do add event listener and remove event listener, and I can call it by name. I can say like this dot on start, for example. You can see that down here in the add event listeners. So I do add event listener for touch start, touch move, touch end, mouse down, mouse move, and mouse up. All of them. Yay! And I can just basically say on start, on move, on end, and so on. And if I wanted to do the remove event listeners, I could do that, and that would just work out fine for me. So we've got our event listeners, and we have a bunch of variables here that are just sort of housekeeping, things that we need to keep a track on. The other thing I do is I start a request animation frame where I busily sort of kind of do an update. Now, if you're doing this in production, I would suggest you don't do it quite like this. I would start the request animation frame when the user starts interacting, and then when the animation's finished, I would stop doing the request animation frame loop. But for the case of this, just to keep things simple, I just start it right at the start, and I do a kind of busy loop through. So what do we actually do in the on start, on move, and on end event listeners? Wow, saying event listeners over and over and over and over and over again. That's not confusing for me. No. What do we do in those? Well, first, in the on start, the main thing is this. We basically take a marker for the start position of the interaction. Where does the user put their finger down on the screen? And then we get that with page X. The other thing we do is we take a copy of that for the current position, because as we move our finger, we're going to update the current position so we know where we started and where we currently are, and the difference is how far we want to transform the card. The other things that we do in this is we set the dragging card to say true, but as we discussed in Theory Corner, we set will change to transform. Now we can check that that actually works by going back to the code, bringing up DevTools, and in the rendering settings, we're going to show layer borders. Anything that's got its own layer is going to go orange around its border. You ready? So when I click, you can see that immediately the card gets its own layer, which is really cool. That means that we can transform and move it around cheaply, like we discussed over there in the Theory Corner. Here's what we've got in the on move. It's fairly straightforward. All we do is we take the current position of the input and we basically say that's the current X. Now inside the update, what we can do is we can say if they're dragging the card, the screen X, which is basically the position of the card on the screen, is the current minus the start. That's basically how far they've moved. And we can apply the transform to account for that. Ta-da! Now when the user stops interacting, we actually have to make a decision. If you remember over in Theory Corner, we said if the user is past that 0.35 marker, so it's a sort of a 0 to 1 range, 1 being the full distance of the card, 0 being not at all. If they go past 0.35, which is what I've chosen, but you could choose a different number, what we want to say is they are dismissing the card. And we do this by setting a target X, which we use later on in the update. And here we do screen X plus equals the target minus the current screen X over 4. What this is going to do is it's going to ease the card to that final position, which will either be the center or it'll be off to the side, depending on whether we've decided that they've gone past the point of dismissal or not. Then there's a little bit of tidy up that we do here. We basically normalize the drag distance and we use that to set the opacity so that the further across you get, the more fadey the card is. Ta-da! So far, so good. So the last little bit is what we do when you dismiss the card, because what we want to do is we want to slide all the other cards into place. And we do that with this animate a little.
Well, hi everyone. My name is Malta, and I'm the tech lead for the AMP project for Google. Tech lead means that I kind of manage the team that works full-time on the AMP open source project for Google, and I kind of also wrote like some of the code, I guess, which is important because we kind of want to dive into how AMP works today and how it achieves its speed. And so even if AMP might not be for you because you're working on an online banking app or whatever, you can still take advantage of the techniques that we use and make your own thing way faster than it might be right now. So I said AMP. It stands for Accelerated Mobile Pages, which is kind of stupid, and I'm never going to say again, but now you know what it means. And it's really all about super fast content on the web. Now, AMP is an open source project, and it's launched inside Google in our search engine, which most of you probably use every so often. And we have this carousel, and here, it just boom, goes up. So load times are way, way, way faster than we see on the normal web. And you can swipe between results, which is also not something that you can do with an everyday web page. Right? So that's AMP. It's, you can go to your browser, search for something newsy, and you should see these AMP results. So, AMP's pretty fast, but we haven't talked that much about how fast it is. And we frankly didn't know. It was an experiment, but it's been out there for a while now. And this is what we're seeing across all traffic where Google search is leading to AMP results. And so the median load time is under 1 second. The exact number is actually 711, so it's pretty substantially under 1 second, which, if you've heard about rail, and that's really where you want to be. But one important part of performance optimization is that you can't only look at your median user. That's important because 50% have an even better experience, but 50% are worse. So what we typically do is we look at the 99th percentile. So that are your users that have a really bad internet connection loading the biggest web page, right? And so for them, we're still seeing load times faster than 8 seconds, which might seem slow, and I find slow, and I'm not happy with. But if you look at the control group of similar pages that are not AMP, they have an average load time of 22 seconds. So the 1% worst AMP loads are still much better than the average non-AMP loads, which I think is pretty exciting. And all of this, like the 1 second that we see at the median, is obviously not instant. But through a technique that I'm going to explain today called pre-rendering, you go from fast to instant. A number that we mentioned yesterday is that there's quite some momentum around AMP. And so looking at the Google Search Index, there's the crazy number of 125 million docs and growing every day. And obviously, this could be only Wikipedia, but what I find more exciting and actually pretty humbling is that there's apparently 640,000 web pages already, different domains, who in some form or another implemented AMP, which I think is really, really cool. And as I alluded to earlier, it's an open source project, and we are shipping new releases every week. Very recently, we finally supported menus, which I agree as everyone else is kind of an important feature. We're currently working on forums, and we're supporting all kinds of features that are pretty advanced, like client-side templating. Now, on the next slide, this is actually my favorite analogy about AMP, is looking at this auto race. There's the average mobile site, and it's kind of in the back. It's definitely not winning. And what I find important to emphasize is that if you're hand-tuning your site, you are going to win this race, right? AMP is not about winning this race, but AMP is about being up there in front. And more importantly, all AMP pages are pretty uniformly up there in front. And I think if there's any secret sauce to how this works, is probably my answer is going to be the AMP validator. So that's MK, he's on my team. It's not actually the AMP validator, but this is how this really looks. So you can go to every AMP page and add hash development equals 1 to the URL. And then you will get these error messages, or hopefully none. But they're just like compiler errors. And because we're developers and we're used to this, for us, it's just like a to-do list. And we're like, oh, cool, yeah, I'm just going to fix them. That's awesome. The other effect this has, and I might just speak from personal opinion, that sometimes you might have some disagreements about what the right thing to do is. And so, in this case, the AMP validator can just come in and say, like, no, that's not a good idea. Cool. So going from like this basic stuff, let's go into how AMP works. So obviously, we developed this radically new rendering engine for documents, which, no, we did not. Because why would you? I think it's amazing. We're in 2016, and there are all these browsers, and they're all great, right? And looking back 10 years, that was not the case. So I think we're in exciting times for web development where, you don't really have to worry about browsers anymore. And so AMPs, they're just web pages. There's, they don't have a special rendering engine. There's, they're just web pages. And that is why everything that AMP is doing internally to gain its performance is basically equally applicable to all non-AMP web pages. Diving into what's going on there, I want to first talk about font loading, or rather font loading. And I have to tell you a secret. And I hope my friends on the Chrome team aren't mad about me, but here it is. Browsers really hate web fonts. By the way, this is my son, and he's extremely unimpressed with the web in general. You'll see him throughout this presentation. So here's what's going on. That's why I'm saying they hate web fonts. So apparently, developers sometimes put font face annotations in their CSS that they don't really use on the page. So browsers are really careful about downloading fonts. In fact, what they do is they look at your CSS, and then they look at all the other CSS, and then they look at all your JavaScript, and then they apply the styles to the page. And at the very moment where they could have rendered the page, they go, oh, OK, I'm going to go to the network and fetch the font. And Chrome, Firefox, and Edge will wait 3 seconds for the font. Safari, for example, will wait forever. And so the font is entirely in the critical path for rendering your page. So getting that optimized is extremely critical for good web performance. Summarizing, all your style sheets and all your synchronous scripts that are in the head block font download. In code, that means if you have link rel style sheet or you have a script source, those will slow down fonts from even being started to put on the network. Now, AMP has certain rules about how it likes HTML to look. And for this reason, what we say is you can have style sheets, but they have to be inline in the style tag. And yes, there can be script tags, but they do need to have the async attribute, which then takes it out of the critical path, and browser will happily try to render the page and download the fonts. And the result of that is that AMP can, obviously having downloaded the document, which is kind of important for rendering it, initiate the HTTP request for those fonts with 0 HTTP requests in the critical path, which is a big improvement for performance. So there's a problem, though, and that is why this slide exists. This slide is actually trimmed down. It looks much, much worse in reality because there's window prefixes going on. But so every AMP document contains this bit of boilerplate. And while I think it's a pretty cool technique, it has some problems. So what's going on? Because all the script tags have the async attributes, but some of them are actually needed to render the page, you would get an incomplete render early in the life cycle, which looks not very good. And so one common technique to avoid that is to manually hide the page by saying, for example, visibility hidden. And then when the script loads, say, OK, now it's visible. So while that works, it has one important downside. If, for example, your network fails at that millisecond and that script never downloads, it could happen that the page just stays completely blank because it says you should be blank. And that's why I think this is such a brilliant idea, which came from some person commenting on a GitHub issue. Why don't you use a CSS animation as a timeout mechanism? So what's going on here is that AMP will go and after 8 seconds, show the page if the JavaScript fails to load. So typically, the JavaScript, as we see, is much, much faster and actually very likely to be in cache. So you would never reach that 8 seconds. But it's very important that you have this extra robustness where the page will eventually show if there's no JavaScript. Great. So with that, I want to talk about my favorite topic, which is static but responsive layout. So for this, I'm going to show you a little video, and I'm just going to ask you to read the text. Please read me. I'm a paragraph. How about not knowing this when element? Right? So when I was first thinking about AMP, I had this, one idea that this is really the worst thing on the internet. And if I would do anything at all in AMP, I would make it so that this would just never, ever happen. And now I'm going to explain to you why it can't happen. And it's, again, pretty simple. So in AMP, every single element has to have its size defined in the markup. And it's much easier to see what that means in code. So in AMP, you use this web component called amp-image to load images. And while on the normal image tag, you can leave out the width and height, it's mandatory on this web component. So what will happen in the browser is when it has an image tag and there's no width and height on it, it will say, it's probably 0 pixel high, right? And then it will go to the network, fetch it, and it comes back, oh, it's not 0 pixel high, because why would an image be 0 pixel high? And then everything moves down, right? And so with mandatory width and height, the browser can put a box and then fill it in when it's time to have the image back from network. Now, with this requirement to put the width and height in the source code, you might ask, how does this work together with responsive design? And I really want to emphasize that AMP is from the ground up designed with responsive design in mind. So here's the answer. And that's actually a great example of how web components can be really, really nice in web development. So all you do is you put layout equals responsive on the element. And what AMP will then do, it will say, thank you for the width and height. I'm going to use that to calculate the aspect ratio. And I'm going to size the image to the available space horizontally and make the height based on that aspect ratio. So coming from this, there are those situations where you can't predict the size. And again, this is also a nice example of the collaboration on the open source project, where I initially was like, you're out of luck. You can't do anything. And then publishers were, well, sometimes we do kind of need to resize things. And so we gave in and came up with, I think, a pretty good model to make it work nonetheless. So when AMP thinks about a page, it considers things based on where they are relative to the position of the viewport. So the viewport is what you currently see. So there's the stuff in viewport. And if you already scroll down, some stuff's above. And if, there's always probably, if the page is longer than a viewport, there's going to be something below. And so if something's below the viewport and it says, I would like to be a bit bigger than originally planned, then AMP says, that's cool, because that can't really affect what's in the viewport. Similarly, but slightly more nifty, if it's above the viewport, you can still allow resizing, because you know how the height changed. You can just subtract that from scroll top, and you end up having everything that's in viewport staying at the exact same spot as before. But finally, we come to stuff that's currently in viewport. And there, AMP is, again, pretty opinionated and says you cannot resize it. That is until the user actually interacted with that element. So what you can do, for example, if you need to resize, AMP will just say no, but you can show a little button to say, allow resize, and then AMP will say, user agreed, that's fine. And then from that moment on, that thing can change its size however it wants. Great. So from that, I want to talk about the next topic. So AMP is designed in a modular fashion. So basically, it knows very little about how to do anything. It can load images and simple videos and text, obviously, but that's about it. And for everything else, there's extensions, which are just web components you load. You think about tweets, Instagrams, YouTube videos, all kinds of stuff. There's dozens of them. And so to load them, you put the script tag on your page. And again, it has the async attribute so that it doesn't block the page. And then you put this, in this case, amp-YouTube tag on your page. It has the width and height, which is pretty predictable for a video typically. And then the video ID. But the thing with web components is when a browser sees a custom element like amp-YouTube, and it hasn't actually learned what it means, it will go, let's draw it like a span. Like, I don't know what width and height means. Let's make an inline element, right? And that is not the best default, and it leads to the same kind of effect of the page jumping around. And it's so bad that there's even a name for it. So it's the flash of unstyled web components. And there's several ways how to work around it. The easiest way is to just wait for the extensions to load. That would actually be similar to the technique we're using to wait for the main script to load, which is the visibility hidden and visible thing that I explained. But we wanted to do better, because if some more complex pages might have like 10 extensions, and now you have the HTTP requests that have to actually finish for something to be shown. They pile up. So instead, AMP can render the page before all extensions are loaded. And here's how it works. So the core AMP JavaScript library, the one that is blocking page layout, it knows how to lay out elements, even though it has no idea what a YouTube video is. So it goes and says, OK, I actually know what width and height means. I know what layout responsive means. I know what layout fixed height means. There's several of them. And it will draw a box. It's not actually gray by default, but you can make it gray in CSS, obviously. And then eventually, that YouTube extension downloads. And then that YouTube extension will say, and fill in that box. And that is a load behavior that we're all used to, because that's how images, for example, usually load on the web. And I think people really perceive it as a decent experience. So to summarize, in AMP, the extension sizing is independent from their implementation. So you don't have to know what YouTube is to make a box for a YouTube video. The extensions are loaded with an async script, so they don't block anything. The box is reserved immediately, and then they're filled with content when the extension loads. All right, coming from this pretty AMP-specific thing, I want to come to a topic that is really applicable to every single web app out there, and that is DOM mutation batching. So there's a simple rule that everyone should follow, which is that you should not interleave reading and writing to the DOM. Unfortunately, it's actually really hard to do this in practice. Here's a contrived but not that unrealistic example about how you would do this. So your code might say, like, window.getComputedStyle measures something. And then based on that, it would set the height of something. And I would say, hey, how high are you? And then you say, like, oh, this other thing has to be sized as well. And then what's your height? Like, so this, you might not write code like this. But if you have a team of more than one person, and there's more than one thing on the page going on, you're quickly getting into a situation where in each animation frame, you might do these various operations that are acting on various parts of the page. And it comes with a big problem, which is that browsers, when you read from the DOM, or you say, like, what's your height, or what's your width, or any of these things that require laying out the page, they trigger recalculation of style, which means that they figure out how does their CSS affect the page layout, all those DOM elements. And so those reads trigger the style recalculation. And if you want to make an application that runs at 60 frames per second, you might be able to afford 2 of those, even though you really shouldn't. But at 3, your mobile device is going to pass out and say, like, I'm going to jank the hell out of this. Fortunately, there's a very easy way to make this much better, which is to slightly change the order in which operations are executed. So like here, if you first do all the writes, and then you do all the reads from the DOM, there's exactly 1 style recalculation triggered. And as you can see, it's pretty easy to imagine that this essentially scales to an unlimited number of operations. Now, it's really, really hard to manually write an application that's larger than 1 file to adhere to such a strict rule. So that's why there are helper libraries that make it relatively easy. So if you're ever looking at the AMP source code, it has a library called vsync, where you can say, like, I want to measure something, I want to mutate something, and then that library says, OK, I'm going to execute all the measures, and then I'll execute all the mutations. And outside of AMP, there's a very popular library called FastDOM that does a very similar thing. And it really helps with an easy API to make the DOM operations execute in an ideal order. With that, I want to move on to the next topic, which is analytics. So obviously, analytics is really important. Like, you want to know how many people come to your app, what they're doing, where they're clicking, how much time they spend, how they scroll. And that's really great. But what happens is sometimes, more of them come in. And I actually have this, went through this myself, where you would talk to the salesperson from the analytics vendor, and they would say, we have this awesome new metric, and I'm like, yay! And so we're switching to them, and then you realize that with a new vendor, that's one thing you always reported to your manager slightly dipped. And then you do a lot of research, and you realize users, there's not less users, it's just that that new vendor interprets that metric slightly different. And so you panic and you put the old thing back in. And so in practice, that happens all the time. And so we're seeing sites that have 5, 10, 15 of these. And it turns out that basically too much of everything is really bad for performance. However, we kind of challenge ourselves thinking there's really very little you can do about this being a problem. So would there be a way how you can have both? So essentially, all you can eat analytics and still have good performance. And the solution that seems relatively obvious in retrospect is to separate instrumentation from reporting. So in AMP, the instrumentation, so the thing that measures your scroll progress, that measures clicks, exists only once, and it's built into AMP. And then it can report stuff to however many times you as a developer choose. So basically what is the deal is that AMP knows how to talk to major analytics vendors, and then just basically pings them, says user scrolled, and they interpret that information. And if you have, for example, in-house analytics, or AMP doesn't directly support your favorite vendor, you can add configuration yourself. In fact, this is how it looks in the open source project. So just randomly chose ComScore. And this describes how to create a request when you track a page view with ComScore. So essentially, there's just a rule saying, use this host, and then this base URL, and then put this stuff on the back. And so it basically you just have this configuration that says, given an event like a page view, how to construct a URL so that then ComScore tracks that as a page view. And this file is pretty long, and basically for every major vendor and all the events they support has this small rule set. And that is how you can talk to them all, but only pay the cost of figuring out when you need to talk to them exactly once. With that from analytics, I want to go to the final topic. And it's slightly different because it doesn't necessarily apply to the general web, and that is instant loading. So as I already talked about very quickly at the beginning, instant loading is achieved through pre-rendering. And pre-rendering means that you render something before the user said, I want to go there. So on a Google search result, that would mean we think they probably click on the first result. It's not the worst guess. So let's render that already. And that obviously comes with some problems, right? Because the user might not go there, but now you already used that bandwidth and that CPU, and a mobile CPU means battery, and that RAM to render the page. And that can be really problematic. And it was, in fact, so problematic that the native version of rendering, which is link-rel pre-render, is essentially unusable on mobile. Now, to solve this problem, we went through a series of insights that led us from it being essentially impossible to working really well. And the first insight, which is, by the way, the most important insight when you think about performance optimizations in general, is that humans are actually kind of slow. And I mean that in the best possible way. So our reaction time is in the order of 2 seconds. So from that, you can say, in order to appear instant, you only have to appear instant. You don't have to be actually all the way done. And here's what that means in practice. So this is a typical website, right? No, it's actually not a typical website, because this is a typical website. It's really long. But for something to appear as having loaded instantly, the only thing that's really important is that the thing that I actually see when I go to the page is already done. Everything else, because reaction time is low, like I can start downloading all the other images, for example, that instant where I show the page, when the user actually clicks it. So what AMP does when it's in pre-render mode, it will go and say, any resource that isn't visible by the user the instant the page is actually shown to them will not be downloaded at all during pre-render mode. And so that saves all the bandwidth that wouldn't have been necessary in the case where the user never goes to that page. And it's pretty typical for a page that maybe have like one image or two images in the first viewport, but overall the pages have many, many more images, and so not downloading them obviously saves a lot of bandwidth. That leaves the harder problem though, which is CPU and RAM usage on mobile, which is a big, big, big problem. And in AMP, AMP is relatively well optimized, and so we're pretty confident that CPU usage of AMP itself is okay. But AMP allows loading all these embeds, and so might be YouTube videos, Instagrams, etc. And so first of all, AMP doesn't control them, and to be honest, some of them actually do use a lot of CPU. And for this reason, AMP does this. Was that all the way clear? Can do it again. So when AMP pre-renders a document, it will not actually load any of the extensions implementation. So in the YouTube case, you can actually do really well, because you can guess their poster URLs. And so AMP will put a poster on the page. And so it really looks complete. But the expensive part, which is the YouTube iframe that loads like 500 kilobytes of JavaScript, isn't actually loaded. And so when the user then expresses intent that they want to go to the page, and will immediately go and say, like, OK, well, you'll load the YouTube iframe, because now they might want to actually watch the video. But again, the page looks pretty complete. And so that user gets that gratification that everything's done, even though, in fact, not everything's done. And so with these two techniques, only loading stuff that's actually visible, and only loading stuff where we know that the CPU usage and RAM usage is relatively minimal, you get the capability to pre-render pages on mobile where it's really basically infeasible with a general web page. And so again, like you have seen initially with the development equals 1, again, you can put a fragment parameter on any AMP document. You can try this in a browser and say pre-render equals 1. And that puts any AMP document in pre-render mode. And you'll see it's not really useful for yourself, because there won't be any images loaded that aren't in the initial viewport, so you can scroll down and nothing loads. Same with all the embeds, they're going to be missing. But the page, as far as the first viewport goes, looks very complete. And then there's an equivalent post-message API where you can tell the page, you're now actually being shown to a person, go load everything else. And that together gets that, that's how basically Google Search works. So in Google, it would load an iframe with the AMP page and tell it you're in pre-render. And then when the user clicks, it sends a quick post message to the iframe saying, like, now you're actually being shown, go crazy loading everything you need. And with that, that was kind of all I wanted to talk about in terms of optimization. I wrote this blog post a while ago. It's under j.mp/amp-speed, and I do have the URL again at the end, which goes through the entire list of optimizations that all AMP pages have. And I like to say they cannot not have it, because AMP really guarantees that those optimizations are applied. But I think it can also be used as a really nice resource, just as all the things that might apply to your non-AMP web page. Still, I'm personally very impatient, and I'm not satisfied at all with the speed of AMP. So what is, your favorite AMP site is still too slow. Like, it might use an extension that's not very optimized, or you might find that you find some edge case in AMP where AMP is slow. And I think that's actually the most exciting thing about AMP, which is that you can actually help. You know, as an open source project, you can send a pull request, and we're shipping every week. So I think it's actually pretty amazing that you have this level of impact, because every AMP page runs the latest version. So if you send a page to AMP and you saw there was like 460,000 domains using it, a week later, they will all run your pull request. And so you can really make a big difference. And what I like to say is that this has been working so far, and we really want to thank all of you for sending these contributions. So AMP went into GitHub last October, and we've so far gotten to 1,950 pull requests. But what's even nicer is that it comes from 160 different contributors. And so, you know, I have a team, but it's not 160, not even close. So it's been a really, really cool collaborative effort. And again, thank you all, because we wouldn't have been able to do it without you. Few more things in terms of bookkeeping, because I really want to point to this. It's not actually a book, but I thought it was funny. So there's a website called ampbyexample.com. And so I'm personally, you know, I know JavaScript, not the best web developer, and this basically just has like examples for all the things you might do in AMP. And you can just, it has like both the output and the source code, and you just copy paste yourself to happiness. It's really useful if you want to get started with AMP. Another shout out is that Google actually yesterday launched an API called the AMP URL API. And so this is applicable to you not if you want to make AMP pages, but if you have either a web app or a native app that has links. And you might want to say, it'd be good for our users if we pointed them to the AMP version of those URLs. And you can, so you can call this URL and say, hey, is there an AMP version for this? And it will say yes or no, basically. Coming from this, it was first shown yesterday, and it's a topic I'm super excited about. So my talk is almost over. I would ask all of you to go to the amphitheater after this, 3 p.m., where Alex Russell will talk about how AMP relates to progressive web apps. And it turns out that those work really, really well together. There was a nice demo yesterday by Washington Post, which totally impressed me. And it's an anagram if you turn around the W. Anyway, that's really all I have. Here's a link to our docs, our GitHub, and again, the blog post. Thank you very much.
Hi there, I'm Timothy Jordan, and you're watching The Developer Show, a special Google I/O 2016 On Location edition. In this episode, we're going to check out the cool stuff going on at the Google Cloud Platform tent. Okay, now I'm at the Google Cloud Platform booth, and I'm about to play Query It with Felipe. And just before we start, I'd like to ask the crowd, is Felipe going to win? No. What about me? The crowd's on my side.
Get ready. Jeter, all the news in the world, everything that is happening from 30 years ago until the last 15 minutes. What country besides the United States was mentioned with Greece the most last year?
Oh yeah, I know that one.
It's Turkey. Not close.
Turkey?
I think you might be right, but...
You're just screwing with me now. Don't let me
They're
win,
super
Felipe.
close. SQL query, analyzing all of the news from last year. This is a real-time query.
So cool. It's also beautiful.
Yes.
I mean, the cool part is how fast it's querying. It's also beautiful.
I do love this animation. 20 gigabytes, analyzed in 20 seconds, over a million. Germany. Turkey. Oh! Turkey was the second one.
Okay, now I'm here with Brett, still in the Google Cloud Platform tent, and we're going to take a look at the Cloud Vision API. But first, we need to take a few photos. All right, Brett, so this is the Cloud Vision API detecting facial emotions. Tell me all about it.
So the Vision API does a lot of things, one of which is emotion detection. So it's actually analyzing these faces, and it's going to get us a likelihood of different emotions. So joy, sorrow, anger, and surprise. And it does it by looking at different facial features. So like where your nose is, position of your mouth, position of your ears, and so forth. So we can see in these, it's going to color it appropriately. So this is very likely to be joy, so you can see that there's like yellow on it. This is angry, so it's red, and sorrow, so it's blue. So our photos are starting to come in now, you can see.
That's an angry Timothy.
I would say that is very likely to be angry. Surprised. And then, what is this one? Joy. All right, so it's actually zooming in, and you can see all these dots are actually spots recognized by the Vision API. So midpoint between the nose and eyes and so forth.
That's amazing.
And there's a whole lot of things that the Vision API does. It can analyze images to see what's in a photo. It can tell you, for example, this is a photo of a dog or furniture or chair. It can do text extraction, so you can upload an image and it can read street signs, for example. Take a picture of a page in a book and it'll give you the text back. An interesting thing is it can do safe search detection. So you can upload an image, tell you if it's not safe for work. It's powered by the same algorithms.
That's really useful.
Yeah, it's powered by the same algorithms that power Google Safe Search on the web. Yeah.
That's really cool.
So you can plug them in to anything that can make a REST API call. So you can use it from your Android app, you can use it from your web app, from your iOS app. We also have Speech API, which if you use like Google Now and as you talk, like it sort of transcribes your text as you go. So we have a version of Speech API. We've got a Prediction API, Translate API, and a lot more on the way.
Awesome. Thanks, Brett.
Yeah, you bet.
Hello, I'm Timothy Jordan, and you're watching the Google I/O 2016 live stream. It's been a great day so far, and there's lots more to come. Stay tuned on all 4 live stream channels for sessions throughout the day. We'll also be on the ground and behind the scenes finding the coolest and most innovative things to share with you right here on the live stream between sessions. And if you want us to track down somebody with your question, use the hashtag AskDevShow. Hello and welcome to the Developer Show. I'm Timothy Jordan, and I'm standing here with Mary Grove, Director of Google for Entrepreneurs.
Hi, Timothy.
Hi, Mary. How are you?
I'm great. Thanks for having me.
Thanks for being here.
Absolutely.
Okay, let me jump to a question about Google for Entrepreneurs. It's been on my mind for a little while because developers ask it, and I think it's fair, and I think we should give them an answer. Why is Google doing this?
It's a great question. I'm glad you asked. So there's 2 ways that I look at that. One is if you look at Google's own history, our own journey as a company, entrepreneurship is such a core part of our DNA, right? Google began as a startup in a garage now almost 20 years ago. We are a company founded by entrepreneurs, built by entrepreneurial people, and then it makes sense that we are passionate about empowering the next generation of startups like Google to become successful, to launch, to use the internet to grow their business. So that's the first reason. The second reason, though, is actually an economic one, right? We believe that by investing in communities, long-term investing in startup communities, these are the next set of companies who are going to come online, use the internet, leverage Google's products as well. So really it's this notion that all boats rise, and long term it's also going to benefit our own business too.
Now, before you were the director of this huge, amazing thing, you were a BD principal at Google. And I'm curious, what did you learn doing those global partnerships that brought you into this new job?
Sure. So my personal story with entrepreneurship begins with my parents. So my parents are both immigrants from Thailand, and they moved to America, sort of personify the quintessential American dream. They were entrepreneurs and really showed me firsthand that you can really, create whatever future you dream for yourself. So at Google, fast forward many years later, I was working in new business development, as you said, looking at emerging markets for Google. And everywhere we worked, we looked for 3 things. 1 is how can we increase access, so internet and mobile penetration. 2 is how can we increase content created from these regions. And the third bucket, which was my personal sort of passion, was entrepreneurship. So how can we work with students, developers, any emerging entrepreneur ecosystem to really help them create the next generation of companies and really create and grow their own economies.
So let's say you're a budding entrepreneur out there with an early stage startup. What's your first step getting help from Google?
There's many ways to look at that, right? There's so many amazing groups and networks that Google has. Of course, Google developer groups being one of them, Women Tech Makers being another great example. We, at the heart of it, are a technology company, so we hope that our products, our platforms can help you be successful. Beyond that, in the Google for Entrepreneurs umbrella, our mission is really about bringing together startup communities. So working with partners of all types, whether that's physical space, co-working, tech hubs, to accelerators and educational curricula. We try to knit together this global partner community of about 50 organizations who are supporting entrepreneurs. So we encourage you to get involved with one of them. For example, Techstars is a global accelerator running all sorts of programs ranging from Startup Weekend to their vertical accelerators. And you can find all these resources on our website, which is google.com/entrepreneurs.
Awesome. Is there anything else that you'd like to say about the program that you don't often get to talk about?
You know, I think that we're based here in Silicon Valley, but Google is truly a global company. The internet has really democratized access to entrepreneurship, right? You can launch a company from Sao Paulo, Brazil, and have users in Seoul, South Korea instantly. And so what I would say is we passionately believe that entrepreneurship's thriving all over the world. It's about getting more access, getting more opportunity, and helping companies really go global from day one and think about their market opportunity as not just their city or their country, but really the whole world.
Mary, thanks for joining me today.
Thanks, Timothy. Thanks for having me.
For more information about Google for Entrepreneurs, make sure to check out the show notes for all the links that you need. I'm Timothy Jordan, and I'll see you next time.
We all know from experience that people love to share things about themselves, such as photos, videos, and GIFs that express their feelings. So what do you do to let them store and share these files through your app? That's where Firebase Storage can help. Our storage API lets you upload your users' files to our cloud so they can be shared with anyone else. And if you have specific rules for sharing files with certain users, you can protect this content for users logged in with Firebase authentication. Security, of course, is our first concern. All transfers are performed over a secure connection. Also, all transfers with our API are robust and will automatically resume in case the connection is broken. This is essential for transferring large files over slow or unreliable mobile connections. And finally, our storage, backed by Google Cloud Storage, scales to petabytes. That's billions of photos to meet your app's needs, so you will never be out of space when you need it. So give your users space to share their lives with Firebase Storage, available right now for iOS, Android, and web applications. And to learn more about Firebase Storage, check out the documentation available right here.
So service workers are powerful for offline caching, but they're also really good for giving you instant loading performance benefits when it comes to repeat visits.
Yep.
Right. And you can achieve that using an application shell architecture.
Yeah.
Now,
so that's kind of the idea of kind of separating content from the actual visual UI. So in my head, it's kind of like native apps. You always have the banner, you've got the navigation drawer at the side, you might have some other bits. That could be common through like 90% of your app.
Yeah.
You always want it there.
So when we talk about the shell, we're talking about the HTML, the CSS, and the JavaScript that's making up the bulk of your UI.
Yeah,
Stuff that, you know, if you cache that, you can still just like load up content in the very middle.
Yeah.
And save yourself having to constantly reload that stuff, right?
Yeah, and it's super nice when it comes to like, let's say they're visiting a page they've never been to before. If you know the layout's always going to be the same, you can still load that while you go and get the content in the background.
And it just makes sure that your user has like really good perceived performance.
Yeah.
So the first time your app loads, you're going to have to render the shell itself. You'll cache that in your service worker. And you might show like a toast just to let them know, hey, this application now works offline.
Yep.
And that means that when they come back another time, like let's say they're in airplane mode, that shell will load up really, really quickly, and then it might go to the network to fetch the rest of the content. You can then cache that content so that that entire view is then available whenever they try accessing it without a network connection.
Yeah, exactly. Spot on.
We've got some performance testing we've done with the application shell model. This is using web page tests. So on first visit, we've got a relatively fast time to first meaningful paint.
And this is super important because I think that there can be scenarios where someone might take advantage of Service Worker to be like, don't worry about your first load, but I'm just going to serve up like megabytes of stuff that I'm going to cache. Afterwards, you'll be super fast. But that first load, if that takes so long to the point where the Service Worker doesn't even get registered, that's pointless. And plus, for other browsers that don't support Service Worker, you're then kind of just damaging yourself.
Yeah, that's going to make your users go and cry in a corner.
Exactly.
You don't want that.
So you still want to be serving up just that static render of your site, just so then it just loads up as fast as humanly possible, and then progressively enhance with Service Worker to then use the app shell model.
And if you are using the app shell model, as you can see here, we've got really good, we've actually slashed our load times for first meaningful paint on repeat visits. Speaking of like actually taking a look at what impact server-side rendering has on this, you don't have to use Service Worker to actually be able to get good gains. If you're building with the app shell model in mind, with server-side rendering in mind, you will get like a really good first paint, even in like Safari and like mobile Safari on iOS.
Yeah, all the other browsers that just don't have Service Worker.
Yeah. Now, if you're wondering, okay, well, should I be using the application shell model on all of my applications? There are going to be types of apps, like super simple apps. This might be overkill.
Yeah.
But if you're building something that's a little bit more complex, a little bit more dynamic, this type of model makes a ton of sense. At Google, we're using it for things like Inbox, and it's working really well there.
Yeah, I think it's one of those things you end up falling into the sit there and figure out whether it makes sense for your site or not. But I think it's a good overall model that works for a lot of different scenarios.
There's a whole ton behind this model that we way too much to explain in just one video, but we wrote up a pretty amazing article on this, if we do say so ourselves.
Well, you wrote it up and I just read it. So
you just added your name to the end of it.
Yeah, that's how I roll.
Pretty much. Impact. That's worth checking out.
That's the format of this
It's
show,
a mediocre article at best, but it's got pretty graphics.
Yes, it does.
People should go check that out.
Yep.
Learn more about App Shell.
And then there's also the Getting Started guide for your first progressive web app, where it actually talks about the application shell model, how you can take advantage of it, as well as how it applies to the demo app that you can build in this lovely code lab.
Yep. And in that article, we also link out to tools that can help you get started with the application model like really quickly that we're working on. So check that out.
Yeah, build a weather app.
So what if I told you there was a way you could compress nearly any stream of data by a factor of 10x or more? Wouldn't that be something you'd be interested in? Yeah, I thought so. Let's find out more on this episode of Route 85. So I want you to take a look at this array of numbers here. Imagine that we wanted to send this array of integers from a server to your user's device. Looks like just a bunch of random numbers, right? Well, that word random is actually the key to compressing these in an incredibly efficient manner. As you probably know, a random number generator isn't truly random. Supply a random number generator with the same seed, and you'll get the same results out every time. And we can take advantage of that fact to recreate that list of integers using a random number generator. You see, all I need to do to regenerate that array on a device is to supply 3 parameters: the seed for an agreed upon random number generator, an upper bound to apply to these results, and the length of the list. I simply supply those numbers to a method that looks a little like this, and I can recreate that original number stream. Just like that, I've built my array of 30 integers using just 2 integers and an int 32. That's a 92% compression rate. Now granted, finding that initial seed did take some work, but you know what? That work can happen in the cloud, so it doesn't really matter. What's important is that on the device, I'm able to decompress that number stream in order and time. And then, of course, once you start looking around, you can see that there's a ton of data you can compress this way. I mean, need to compress a text string? Well, what's a string but a stream of encoded integers? Once I have my stream of integers, I simply figure out what seed I need to generate them, and voila, I've compressed my string down into just 3 numbers. It's a pretty amazing savings, right? Anybody with the username of stidjexmisdizixgoodquibpubpa will be singing your praises in their reviews. And my gosh, if you think about it, an image is really just a stream of numbers broken out into several channels. Take a look at this image here, and you can see how, using our random number generator, I've been able to replace it with just 3 sets of integers for the red, green, and blue channels, respectively. Now, once again, finding the right seed can take some time, and I haven't found the perfect seed just yet. So if you look at the results carefully, you can see that this is not quite a lossless compression scheme. But I think you'll agree that for this kind of savings, these trade-offs just might be worth it. Anyway, I hope you consider using this technique the next time you have data that needs to be compressed. Remember, the more efficient you are with your users' data, the more they'll love you. Thanks again for watching. Be sure to check out other episodes of Route 85. And remember that, as my coworkers on the Android team like to say, perf matters. All right, thanks guys. I think we're done.
Who let him into the studio again?
I couldn't say no to Elijah Wood.
But that's...
Elijah Wood.
Hello, I'm Timothy Jordan, and you're watching the Google I/O 2016 live stream. It's been a great day so far, and there's lots more to come. Stay tuned on all 4 live stream channels for sessions throughout the day. We'll also be on the ground and behind the scenes finding the coolest and most innovative things to share with you right here on the live stream between sessions. And if you want us to track down somebody with your question, use the hashtag AskDevShow.
Last episode, we used a decision tree as our classifier. Today, we'll add code to visualize it so we can see how it works under the hood. There are many types of classifiers you may have heard of before, things like neural nets or support vector machines. So why did we use a decision tree to start? Well, they have a very unique property. They're easy to read and understand. In fact, they're one of the few models that are interpretable, where you can understand exactly why the classifier makes a decision. That's amazingly useful in practice. To get started, I'll introduce you to a real dataset we'll work with today. It's called Iris. Iris is a classic machine learning problem. In it, you want to identify what type of flower you have based on different measurements, like the length and width of the petal. The dataset includes 3 different types of flowers. They're all species of iris: setosa, versicolor, and virginica. Scrolling down, you can see we're given 50 examples of each type, so 150 examples total. Notice there are 4 features that are used to describe each example. These are the length and width of the sepal and petal. And just like in our apples and oranges problem, the first 4 columns give the features, and the last column gives the labels, which is the type of flower in each row. Our goal is to use this dataset to train a classifier. Then we can use that classifier to predict what species of flower we have if we're given a new flower that we've never seen before. Knowing how to work with an existing dataset is a good skill, so let's import Iris into scikit-learn and see what it looks like in code. Conveniently, the friendly folks at Scikit provided a bunch of sample datasets, including Iris, as well as utilities to make them easy to import. We can import Iris into our code like this. The dataset includes both the table from Wikipedia as well as some metadata. The metadata tells you the names of the features and the names of different types of flowers. The features and examples themselves are contained in the data variable. For example, if I print out the first entry, you can see the measurements for this flower. These index to the feature names, so the first value refers to the sepal length and the second to sepal width, and so on. The target variable contains the labels. Likewise, these index to the target names. Let's print out the first one. A label of 0 means it's a setosa. If you look at the table from Wikipedia, you'll notice that we just printed out the first row. Now, both the data and target variables have 150 entries. If you want, you can iterate over them to print out the entire dataset like this. Now that we know how to work with the dataset, we're ready to train a classifier. But before we do that, first we need to split up the data. I'm going to remove several of the examples and put them aside for later. We'll call the examples I'm putting aside our testing data. We'll keep these separate from our training data. And later on, we'll use our testing examples to test how accurate the classifier is on data it's never seen before. Testing is actually a really important part of doing machine learning well in practice, and we'll cover it in more detail in a future episode. Just for this exercise, I'll remove one example of each type of flower. And as it happens, the dataset is ordered so the first setosa is at index 0, and the first versicolor is at 50, and so on. The syntax looks a little bit complicated, but all I'm doing is removing 3 entries from the data and target variables. Then I'll create 2 new sets of variables, one for training and one for testing. Training will have the majority of our data, and testing will have just the examples I removed. Now, just as before, we can create a decision tree classifier and train it on our training data. Before we visualize it, let's use the tree to classify our testing data. We know we have one flower of each type, and we can print out the labels we expect. Now let's see what the tree predicts. We'll give it the features for our testing data, and we'll get back labels. You can see the predicted labels match our testing data. That means it got them all right. Now keep in mind this was a very simple test, and we'll go into more detail down the road. Now let's visualize the tree so we can see how the classifier works. To do that, I'm going to copy-paste some code in from Scikit's tutorials. And because this code is for visualization and not machine learning concepts, I won't cover the details here. Note that I'm combining the code from these two examples to create an easy-to-read PDF. I can run our script and open up the PDF, and we can see the tree. To use it to classify data, you start by reading from the top. Each node asks a yes or no question about one of the features. For example, this node asks if the petal width is less than 0.8 centimeters. If it's true for the example you're classifying, go left. Otherwise, go right. Now let's use this tree to classify an example from our testing data. Here are the features and label for our first testing flower. Remember, you can find the feature names by looking at the metadata. We know this flower is a setosa, so let's see what the tree predicts. I'll resize the windows to make this easier to see. And the first question the tree asks is whether the petal width is less than 0.8 centimeters. That's the fourth feature. The answer is true, so we proceed left. At this point, we're already at a leaf node. There are no other questions to ask, so the tree gives us a prediction, setosa, and it's right. Notice the label is 0, which indexes to that type of flower. Now let's try our second testing example. This one is a versicolor. Let's see what the tree predicts. Again, we read from the top, and this time the petal width is greater than 0.8 centimeters. The answer to the tree's question is false, so we go right. The next question the tree asks is whether the petal width is less than 1.75. It's trying to narrow it down. That's true, so we go left. Now it asks if the petal length is less than 4.95. That's true, so we go left again. And finally, the tree asks if the petal width is less than 1.65. That's true, so left it is. And now we have our prediction. It's a versicolor, and that's right again. You can try the last one on your own as an exercise, and remember the way we're using the tree is the same way it works in code. So that's how you quickly visualize and read a decision tree. There's a lot more to learn here, especially how they're built automatically from examples. We'll get to that in a future episode, but for now let's close with an essential point. Every question the tree asks must be about one of your features. That means the better your features are, the better a tree you can build. And in the next episode, we'll start looking at what makes a good feature. Thanks very much for watching, and I'll see you next time.
So constraints. They're a great way for you as a developer to deal with the ever-expanding number of screen sizes, device rotations, and new form factors like slide over in the iOS world. But one unfortunate casualty in this brave new world of alignment has been the way we animate views. See, it used to be we could go around setting a UI view's position or frame with a fun little UI view animate with duration method and watch our view scoot around the screen. Well, that was fun. Hi, everybody. Hey, we got all right. Let's do it again. Hi, everybody. Woo! Wow, like last session on the last day, and we still have people that are awake. That is fantastic. So yes, congratulations. We made it to like the last session on the last day of the conference. I don't know about you, but I kind of feel like this guy. Maybe you feel like this guy too. Either because your brain is full, or you partied too hard last night, or like me, you woke up at 4 in the morning and then couldn't go back to sleep because apparently my brain hates the rest of my body and wants it to feel terrible. But either way, congratulations. Thank you for being awake and alert, and hope a good audience. I already can tell you guys are going to be a great audience. So let's talk about Firebase. As you may have heard, Firebase is a suite of integrated products designed to help you develop your app, or grow a user base, and earn money. Maybe we've mentioned that before. Yay! And we've been kind of calling it a suite, but for a lot of these talks, I feel like we've generally been talking about Firebase's features in isolation. And for this session, what I'd like to do is actually kind of show you some of the cool tricks that you can do when you have some of the various features of the new Firebase platform all working together in a few hypothetical scenarios, and a presentation I like to call 5 neat tricks you can do with the new Firebase platform. So let's look at those now. We're going to start off with trick number 1. I'm with the band, or dynamic links plus notifications plus Firebase Cloud Messaging plus Firebase Analytics equals notification goodness. And let's start off by talking about our brand new ticket app, Ticket Picker. They're the quicker ticket picker. And they're the hot new way for you to get tickets for concerts, baseball games, and what have you. And they've decided, as sort of a good little marketing ploy, as a way to draw users into their app, they're going to set up a companion site, right? This is a site where you can read like news and gossip and tour information and get some tour dates about your favorite bands. And sort of as a way to draw people into their app, they decide on all these pages they're going to add in a nice little button that says, hey, if you're interested in getting tickets for the Rolling Stones, then why don't you click on this button and try out our app. By the way, I would like to point out that it is incredibly difficult to draw a scone. I know this just looks like sort of a really sad pancake, but that's why I'm a developer advocate and not an artist. But anyway, so this kind of sounds like a situation for dynamic links. If you know what Firebase dynamic links are, they're basically mobile deep links that work the way you want them to. So basically with one link that we can put on our site, we can either take the user to the iOS or the Android version of their app if they have it installed. And if they don't have the app installed, we can take them to the App Store or the Play Store, depending on the platform. More importantly, if the user had to install our app first, Firebase Dynamic Links can retrieve that original link context. It can remember what link the user clicked on to get them into the app in the first place, so that we can actually deliver the user a first-time experience that is relevant to the link they clicked on. So rather than just showing a boring old homepage, we know that they installed our app because perhaps they're interested in Rolling Stones and getting tickets, and maybe we can show them or information that's relevant that way. So the link to try out to get into our app would probably look a little like this. And I can kind of break it down for you if you're not super familiar with Firebase Dynamic Links, and you probably aren't because we just announced it 2 days ago. First, we'd add in these entries for the appropriate Play and App Store IDs, as well as your iOS bundle identifier. This basically lets us know, which place in the Play Store or the App Store to redirect the user if they don't have the app installed. We're also going to add in these UTM tracking tags. And if you don't know what they are, they're basically sort of a hierarchical way of representing any kind of marketing campaign. So you've got like your Uber Spring 2016 campaign, and then within that, you have your various sources like the companion website or maybe an email blast and that sort of thing, and various content and medium. You can kind of break it down in different ways. Different people like to do this in different ways. And all that information will get captured in Firebase Analytics when the user clicks on this deep link. And then we have the link parameter itself. And this is the information that gets passed into your app when it first opens up. And in this case, we've decided that we're going to capture the band that the user was browsing when they decided to click on this link. So we know that the featured band here happens to be the Rolling Stones, and that we'll be able to realize when we sort of process this URL. And so by analyzing this link information, when we first open up the app, instead of our boring old sign-in page, our app can analyze that link parameter, and it'll say, OK, the user was interested in our app because they were looking at a page for the Rolling Stones, so maybe we should show them some relevant info, right? And then we can show the user a bunch of Rolling Stones tour dates when they first open up our app instead of that sort of blank sign-in screen. And this is important. Like, the user has said, I am willing to go ahead and install your app because I am super interested in this data, so why not make sure that they can get that data that they're interested in right away? And so this is dynamic links, and maybe you know about this if you saw our other presentation. But we can also do a lot more with this incoming link and knowing sort of what that featured band was. For instance, our app can automatically subscribe the user to the Rolling Stones Firebase Cloud Messaging topic. If you don't know what topics are, they're basically ad hoc groups that any client can subscribe to on the cloud messaging server. So basically, we can tell the cloud messaging server, please send this message to any client that has subscribed themselves to this topic, the Rolling Stones or any other band. Firebase Cloud Messaging has kept track of which clients have subscribed themselves to that topic, and it can send the information off to all those devices without your having to keep track of it in your own database on your server somewhere. So when the Rolling Stones decide, hey, we're going to start a new tour and we're going to make some new ticket sales available, you can schedule a future message through Firebase notifications. You can see here that in addition to sending a message right away, we can schedule a message to be sent at a particular time. We can schedule messages to be sent at a particular time in the user's specific time zone if we want. In this case, because tickets are going on sale at 9 a.m. All across the world globally, we can make sure that that notification gets sent out globally so that everyone has a chance to get those tickets before they sell out. And then you can see that we are sending these these set of notifications to devices that have subscribed to the Rolling Stones topic. And then we can also capture conversion events here. So various events in Firebase Analytics that are super important to your app, like being able to purchase a ticket. You can tell Firebase Analytics, let's make these conversion events. These are events that we really care about. And so you can then track whether a notification has led a user to complete one of these events. And this is really important for determining whether your notifications are are they effective or are they spammy? If it turns out that a lot of people are receiving the notification, but very few people are opening them, and very few people out of that group are actually going ahead and completing a ticket purchase, well, maybe it's spammy. On the other hand, if you've targeted your notifications correctly, then the percentage of people who get the notification, open it, and then go ahead and complete a purchase will be much higher, and that's sort of a good way of judging whether or not these notifications are effective. And gosh, this incoming band, this also seems like a pretty good starting value for like a user property of the user's favorite band. Maybe we can change that on the app later, but this seems like a pretty good starting point. And then we can do a lot of reports in Firebase Analytics based on the favorite bands of our users, right? So we can take a look at any report, like the number of people that said, why, yes, I'm interested in reviewing this app. And we can filter that by various user properties, including their favorite band. So we can take a look and see, for everybody who listed the Rolling Stones as their favorite band, well, how many of them went ahead and decided that they were OK reviewing my app? So we can get a better idea of how these different fans of different bands behave. And if we say, wow, we really need more people reviewing our app, and it turns out that fans of the Rolling Stones are more likely to review our app than fans of W2, they're sing a lot about filling out tax forms, we can figure that out in Firebase Analytics. And then because we used all of these UTM tags to record all the deep link info, we can evaluate the performance of the entire companion site, right? We can basically look at all of the companion site users and see how they behave. Not just, did they click on these links to get into our app, but are they more or less likely to perform these important conversion actions like buying a ticket, like subscribing to our newsletter, like signing up for the premium service, like sharing the app with our friends. So when our CEO comes by and says, gosh, we seem to be spending an awful lot of money on this companion site, is it worth it? We can actually have the data to back it up. And we can say, why, yes, it's not only getting us users, which we know, but we can also decide that it's getting us users that are valuable to us because they are buying tickets or sending the app to their friends. And maybe it's because that nice deep link experience is giving them a better experience and they're more interested in our app in the first place. So that's an awful lot that you can do just by adding in one dynamic link into your banners. So I'm going to move on to trick number 2, birds of a feather, or Firebase authentication plus the real-time database plus storage equals some group photo sharing. This one gets into some kind of crazy rules here, but stick with me. So this is our fun bird watching app, Birdie Hunt. And they've decided they're going to add a new feature for their users to be able to share photos of birds that they found, with the public. Like I found a really good picture of a chickadee, and I take it and I say, hey, everybody, check out this picture, and maybe everyone can ooh and ah over it. So clearly, this seems like a good use case for Firebase storage, right? That's a place where we can store all of our members' photos in the cloud. That's what it was made for, is storing, large blobs of data. Apparently, people used to like base 64 this data and stick it in the real-time database before. Hey, all right, guilty. So do this now. It's better. It's way better. Now, when we do that, when we basically add a, when we upload a file to storage, in the completion handler, what you're going to get back is some metadata. And among that metadata, one of the most important things you're going to get is a download URL to that file that you just uploaded. It's basically the URL of the file plus some tokens that you can revoke later if you need to. But this is what you're going to have to be able to download that photo. And then, we can store these URLs in the Firebase database, right? We can create an album photos object, and under there we can create a different object for each different album, and within there we can create various photos with like the name and the URL. And just like that, people can kind of see our photo albums, which sounds great. But it turns out, I didn't know this, bird watching groups, very cutthroat, very competitive, and they didn't want other bird watching groups to see the photos that they took. They only wanted to share it with other people in their bird watching group. So who knew? But we can still do that, partly by taking advantage of Firebase sign-in, or Firebase auth, I should say, which allows you to sign in your user from a number of different providers, right? We have Google and Facebook and Twitter and GitHub, as well as letting your user provide their own email and password, and we handle that for you, so you don't have to deal with storing passwords on your end. So when we use Firebase auth, what we get back is a unique ID for each user in our app, no matter how they've signed in, right? You sort of get back a consistent Firebase user object that has its own unique ID that you're sure aren't going to have like name collisions across the different sign-in providers, which is nice. Now you can take that and you can store basically the members who can view the various albums in our album members sort of album ID section. We can basically stick our various user IDs into this object and maybe list some administration roles. Some people are owners, some people are editors, some people are viewers. So once we get that in there, well, now we need to write some rules. We need to tell the Firebase database, OK, for someone to see this photo here, their user ID must exist in the corresponding album object. Does that make sense? All right. So how do we do that? We do that with these rules, which I know look a little complicated at first. But if you break it down, what you can actually see is basically we're just going up the tree a little bit. We're saying, OK, for any object in the album photos object, so to go up the tree a little bit and go down and find the corresponding album members object. From there, if there is a child that has the same user ID as the user who's currently signed in, well, then they're allowed to read this album. And if it turns out that the value of that object happens to be editor or owner, then they're allowed to write into this album. And that's basically all we're saying here with this code. But wait, how do we know how to put those user IDs in there in the first place, right? Well, we can actually have rules for that as well. Let's say we want to have a way for members to request that they join a particular album, right? I say, yeah, I would like to view this album. Please let me in. And so we can create an album joiners object where people can add in their own user IDs so that they can make these requests. And then the owner of any particular album has the power to remove people from the album joiners object and put them into the album members object. So let's look at the rules needed to do that. First, we need to say that anybody can add their own user ID to a joiners object. It's basically just a request to join, and sure, anyone can do that. Doesn't mean it'll get approved, but anyone can. So we would do that with this rule. Basically, within album joiners, for any arbitrary album, for any arbitrary user ID, you are allowed to write your own user ID. So that's basically all we're saying here. Next up, we need to say that anybody, well, basically that we could say that if you want to alter anything in the album joiners object, besides the process of writing your own user ID, well, you need to be the album owner. And so we kind of do that using this same sort of, let's go up the tree and then down the tree to the corresponding album members object and look in there and see if the signed-in user is listed as the owner. And if you are, then congratulations, you can read and write to this album joiners object. And then we also want to say, well, album owners can alter anything in their own album members object, which is actually a much simpler rule. We just say, well, if you're listed there as an owner, then you can write in here. And then finally, for brand new albums, we'll say that anybody can create a brand new album as long as they list themselves as the owner. And that's the kind of thing you can do here. Basically, we're saying you can create a brand new album members object as long as it doesn't, it doesn't already exist, and you are listing yourself as the owner. So maybe your first reaction upon seeing all of this is, well, I'm going to give up and just make my entire database world readable and writable, because this seems really kind of strange and weird. And it is. It's kind of strange and weird at first. I certainly wasn't able to figure this out without sort of having a Firebase engineer next to me. I know all of you don't have the advantage of having a Firebase engineer sitting next to you, but I can give you the next best thing, which is his phone number. This is Frank. He is totally willing to help out and answer questions. And I'm sorry? Oh, it's sarcasm. Oh, okay. Apparently that was not a sincere. I'm just going to move on. And instead, I'm going to say that you can get the next best thing, which is this cool tool that Firebase has, where you can basically pretend to sign in as any arbitrary user and then try and simulate any kind of read or write call. And what will happen is Firebase will go through all of the rules in its database and let you know which ones it's applying, whether they evaluate to true or false, and then tell you whether this operation would have succeeded or not. So it's actually kind of cool. Like, that's how I was able to verify that all these rules on my slides were legit, was by sort of going through all of these simulated reads and writes and making sure that yes, someone can, an owner is allowed to remove somebody from the joiners list and so on. So I encourage you to give this a try. It's available. It's the UI has actually improved just a little bit as well. It's available in the database in this little button on the right that says, I forget what it says now, like experiments or something like that. So, because these rules, they are a little weird at first, but they're also incredibly powerful. And once you start playing around with them, they can also be kind of fun. And I know, security isn't supposed to be fun. It's supposed to be very serious and all of that. But, it's fun. It's kind of fun to play around with. So let's move on to trick number 3. We test in production, or using remote config plus Firebase crash reporting plus analytics plus notifications to turn disasters around. So let's revisit Ticket Picker. They're the quicker ticket picker, as you might recall. And one day their CEO comes in and says, listen, I have this great idea for a new ticket auction feature, right? Instead of just kind of selling and buying tickets, we'll let people put their tickets up for auction. Everybody can bid, and whoever the highest bidder is will get the ticket, right? Doesn't this sound fantastic? It does sound fantastic. Well, I'm glad you agree, because I kind of told our investors we have it ready for them by next week. But don't worry, I have a plan. See, I've been analyzing all the work that we do when we write our code. Turns out, basically, it breaks down into 4 things here. We develop features, cool new features. We write unit tests. We add in some sweet animations, and then we compose some very funny release notes. Right now, we're doing a whole Calvin and Hobbes fan fiction thing. It's very popular. And so we sort of analyzed this stuff, and we found out that people love the features and the animations and the release notes, right? Totally fun, really interesting. But I realized writing unit tests, so boring. I looked at all the time our engineers spend writing these, and not one good feature has come out of them. So here's the way we're going to get this feature done. Just skip writing unit tests, right? It takes up a bunch of time. There's no user-facing value, and I'm an organizational genius. Well, Karen from engineering was not super impressed. And while the CEO did decide to push forward with his whole no unit test plan, he did make one valuable concession, which is this. All right, let's roll it out gradually. So the first day, we'll kind of roll it out to a very small percentage of the population. And then, we'll kind of expand it. And maybe in a couple days, we'll go to 15% and so on until the entire world is full of our red auction feature of goodness. So here's how they did it. Here's how you would do a gradual rollout using Firebase. First off, they added a ticket auction enabled value in Firebase remote config. So this is basically a value that you can read in from remote config that says, should I enable this auction? And what you can do in remote config is create conditions, certain groups of users for whom certain values apply. And one thing you can do with conditions is create random groups of users. So what they said is, we're going to create a ticket auction experiment condition, which will apply to 10% of the population, right? Or this can be whatever we want. We'll start with 10. And so basically, we'll set this value to true if they are in the ticket auction experiment, and otherwise, we'll set it to false. And because Karen is super paranoid, she said, you know what? Let's also suppress that review dialog for anybody that's in that experiment, because I'm not entirely sure we want to encourage reviews from people that are in this thing yet. I'm not super I'm not super confident yet in our auction feature. And so that's something you can also do, pretty easily using remote config is, change when do you want to show that please review our app dialog to your users. So then in their code, it's pretty simple to use remote config to check whether or not to enable this feature. This is Swift. It looks pretty similar to most other languages. And then basically, you can also report back through Firebase Analytics the experiment type that the user is in by setting a user property. So we're going to create a user property called is this user in the auction experiment. And we'll set it to either 1 or 0 if they're in the auction. And then in Firebase Analytics, while we're at it, let's create an audience based on people for whom this experiment type is equal to true. So for anybody who has the user property of I am in this experiment, we will add them to a Firebase audience. And the way Firebase audiences work is they build up over time. This work is distributed to the client. And so as people start using the app and the client realizes that they are in this auction experiment, they will get added to this audience. So our app is updated, released to the world, and we decide to gradually turn on this feature by changing the percent in the experiment. It'll go from sort of 2% to like 10%, and then to 20%, and so on. And when we change these random values, don't worry, it's that same random group of 10% plus the next random group of 10. It doesn't pick an entirely different 20% of the population. And so we gradually roll it out to our users, and then we decide to see how things are going. So we go over and look on Firebase crash reporting, and oh my gosh, this is terrible. And in fact, if we look below, we can see that the biggest culprit here seems to be this method, start new auction. So apparently that might be the culprit. And even worse, we can go and break out our spending reports by this user property. And we can see that people who are now in the auction experiment aren't spending everything. And this is terrible. And our CEO goes to engineering and says, how could you have let this happen? And Karen sighs and says, don't worry, we got a plan. So first of all, we can use remote config to very quickly shut down the experiment, right? We change this condition back to 0, and soon the auction disappears from everybody's app. More importantly, we have an audience full of everybody who is in this experiment, and we can apologize to them. And it's amazing how much goodwill you can gain when you apologize when you mess things up. Sorry about the lines on Wednesday. Anyway, we can use Firebase notifications to send an apology to everybody who's in that audience, basically saying, hey, sorry, we've had some issues with our auctions. We've turned off this feature, and maybe as an added little bonus, here's a little coupon code or something in the notification. And because it's being targeted to just this audience, the other 80% of the population using the app isn't going to be like, what are they talking about? I've never even seen this auction thing. And again, this sort of thing can be really useful. It's sort of a good way of turning a negative experience into a positive one, and a way to kind of show that you care. So Karen once again saves the company, and everything is good with the world, for now. Stop coming up with ideas. They're all terrible. All right. Let's move on to issue number 4, or trick number 4, the Dreamy Boys storefront, or analytics plus AdWords plus remote config plus Firebase hosting equals some promotions to swoon over. So let's talk a little bit about Chat 'em Up. It's a fantastic new chat app that makes most of their money selling stickers in their in-app store. Well, now it just so happens that the lead biz dev person at Chat 'em Up is really good friends with the manager of the hot new boy band coming out of the UK, the Dreamy Boys. So they're the hot new band with the hit new song, You Can't Debug My Love. It's a freaky looking boy band. And so anyway, they say, hey, you know what would be great? What if we had like a Dreamy Boys branded section of our sticker shop, right? That would be fantastic. And so they go off and start negotiating deals and royalties and all that. We decide we want to make this thing a success as soon as it launches. So as early as we can, we're going to start creating a few audiences in Firebase Analytics. First, we'll kind of target their initial demographic, females in the UK. And then their second demographic, males in Switzerland over 55. I'll be honest, this one kind of took marketing by surprise, but there you go. And then while we're at it, let's also target our heavy sticker users. These are people who have purchased a sticker from our in-app sticker store, right? That's probably an audience we've created already because we care about them. Very, very clearly, the people that are going to most likely to purchase stickers in the future are people who have probably purchased stickers in the past. So this is definitely a group we want to kind of capture in a Firebase Analytics audience. So let's fast forward to a few months later. The deal is signed. We have our great new storefront. And we say, hey, that's fantastic. We got to get the word out about this. And so because we've connected Firebase and AdWords, we can use these audiences directly in our remarketing campaign. If you've done a remarketing campaign in AdWords, you might know that you're allowed to basically target specific remarketing lists. And these can be, everybody who's ever used your app ever. But now that you can connect Firebase and AdWords, you can also target audiences that you have built up right within analytics. And that actually turns out to be really useful, right? Like, we can actually target just the people that have purchased stickers in our app before with remarketing campaigns. Or we can also target our women in the UK and our older Swiss men. And so those people will start to see remarketing ads designed to get them back into their app, where hopefully they'll be making some more purchases. It turns out we can also use remote config to display a welcome message to our sticker audience, right? We can also not only create conditions based on random groups of users, or your device type or your country, but we can also target certain Firebase audiences. So we could add a welcome message for all our sticker purchasers to let them know about some recent new addition to our app. And honestly, this is a really good application for remote config, is any kind of message of the day feature, right? You can sort of immediately push out any new message that you want to send to your users using remote config. More importantly, with conditions, you can target just specific groups of users who you think might be interested in this. So not everybody is getting all these sort of message of the days all the time if they don't want them. And we can also do things, as long as we're using remote config, we can change the banner image for our sticker store so that it can be something special, again, for that group of users who have purchased stickers from us in the past. Maybe we say, instead of using whatever local image we would normally use on the device, let's grab something remotely. And so we can go from our boring old sticker shop banner to whatever you would call this. That's Evan. He's the rebel of the group. I hear he might also be a vampire. So. Anyway, we were going for smoldering, but I think we just ended up with tired, because that's what happens when you take pictures the week before I/O. Everyone looks tired. Anyway, but that's the kind of thing you can do with remote config. And by the way, I don't know if you noticed, but the URL for that fancy new banner image is being provided for us by Firebase hosting. And that's sort of the best place for you to put kind of static images and that sort of thing that you want to retrieve by using plain old HTTP calls. Oh, yeah, that's a good question. So yes, you may have noticed there's sort of two ways to retrieve images, right? You've got Firebase storage and Firebase hosting. Both are good. Generally speaking, you want to use Firebase storage for user-generated content, right? Images that your users have taken and uploaded, recordings, audio recordings, that sort of thing. For what I call read-only assets, like your website or images and data that you want your app to download later, hosting is much more appropriate. That kind of gets it out to the world across our CDN everywhere and makes it super fast and easier for you to download. Also free, I believe, which is nice. So let's move on to trick number 5. Are you ready for this jelly? Or basically remote config plus dynamic links plus the Firebase database plus Firebase analytics for replays that matter. So let's talk about Jelly Matcher Gaiden, the latest match 3 puzzle game. The developers have decided they want to add a let's share my level feature, or share my replay, so that if you've had a really great replay, you can send it off to your friends. They can try the exact same level as you, see if they can beat your score, and maybe even watch your replay later, right? Sounds like kind of a cool way of doing it. So again, this seems like a pretty obvious use case for dynamic links. Whatever email this app ends up generating and sending off, or whatever post or however we want to share this replay, we probably want that link to get into our app to be a dynamic link, right? So we can kind of click on that link. We'll take them into the app and immediately load up the level by analyzing that link parameter. And again, they don't have the app installed. Well, we can take them to the Play Store or the App Store. And yes, by the way, we could totally store all that replay information in the Firebase database. Seems like a really good place to put it. But there is one big question. So typically, if the user doesn't have the app installed, the default dynamic link process is to take users directly to the App Store or the Play Store and wait for them to install the app. But we also have another option when dealing with Firebase dynamic links. We can send people to a fallback page instead. This could be like a marketing page where we tell them a little more about the app and tell them how fantastic it is and get them excited about it before we then send them to the App Store, where they're given the option of whether to install it or not. And there's sort of advantages and disadvantages to both, right? The first way is one fewer click. You can immediately get right into the App Store or the Play Store. But the other way, maybe gives the user a little more context before we ask them to install something. So which is better? Well, this seems like a very good opportunity for an A/B test. And so that's also something we can do with remote config. We can set up a test condition like this, again, delivering to a random group of users. And this time, we'll kind of look at 50% of our users instead of doing a gradual rollout. So we can kind of do a true A/B test. And then we can set our value of replay uses marketing page to either be true or false, depending on whether the user is in this experiment. And then basically within whatever code we're going to be using to build out this dynamic link from the app, we can look and see, is this value true? If so, then let's add on these 2 extra parameters, the AFL and the IFL parameter, to our dynamic link, which basically tells Firebase Dynamic Links what web page to send the user to instead. So for half of our users, the link they're going to share with their friends looks a little like this. It's a dynamic link without any fallback pages. And the other half will have a link that looks like this. It's basically the same link as before, but now we have these fallback page URLs specified. And again, with a little tiny bit of JavaScript, that marketing page that we then have that tells the user how fantastic this app is, and now don't you really want to go and install it? Well, when they click on that link to go ahead and install it, we can still kind of generate our own dynamic link so that when the user finally does open up that app, we've remembered through the entire process what that replay was and take our user right into that replay as soon as they start up the app. And how do we actually track this? How do we see which is successful? Probably the easiest way is just kind of adjust those UTM parameters that we talked about earlier. We can sort of create that for each link. And then we can start tracking conversion metrics. Like who made an in-app purchase based on did you visit the fallback page first, or were you taken there directly from the email? So not only can we see which users clicked on which links the most, but also see which users then stuck around and actually made a purchase and really got into it. Maybe the marketing page got you more psyched to actually try the app and stick with it, because chances are you're not going to win that replay if this is the first time you've ever tried the game. So that's valuable. And by the way, we don't need to stop with just kind of testing a single page or not, right? Like, it's very easy to kind of A/B/C test different pages. We can create conditions for 33% of our users and 66%, and then kind of set different options of which marketing page do we send people to, or maybe we don't send them to one at all. Again, based on all these conditions. And if we think about it, if this email content is being generated on our client, well, that has to come from somewhere too. So why not kind of use remote config to, again, test what emails we're going to send, and test what screenshot the app is going to put in there and what the button is going to say. All that stuff, again, fairly easy to set up and A/B test using remote config. So there you go. 5 ways you can use elements like storage and analytics and notifications and remote config and auth all together to make a more compelling app. Now this might shock some of you, but these were somewhat contrived examples with fake companies. I know, right? Surprising. But probably some of this does apply to your situation, right? Maybe you have a companion site where you're trying to bring users into your app, and you want to make that a little more powerful. Or maybe you have a feature that you're not super confident in, and maybe you kind of want to try a gradual rollout first. Maybe you have your own set of deep links or sharing emails, and you want to A/B test that stuff. So think about it. Maybe a couple of these examples, they might not be exactly pertinent to your situation, but maybe they'll inspire you to think of something similar that will be cool. So basically, I know at this point, I'm like the teacher on the last day of class, and everybody's just kind of waiting for the bell to ring. Maybe some of you have planes to catch. But I just want to say thank you very much for coming to I/O. Every year, the week before, I'm always up super late and not sleeping and trying to get all this stuff done. I'm like, is this really worth it? But then I come to these events, and I talk to people who are super excited and positive and a little bit nerdy, sort of like me. And it's just really nice. It's just, it's really nice to be able to sort of chat with all of you and sort of meet other people. And, please just continue to be positive and a little bit nerdy, because I think that's great. So anyway, sorry. If you want more information about Firebase, here's the website. We got a support page. We got a YouTube and a Twitter feed and all of that. And with that, I'm going to say, are we done? Are we actually done with I/O? We're done with I/O, everybody. Thank you for coming.
Hi, I'm Timothy Jordan, and you've been watching the Google I/O 2016 live stream. Thanks for joining us. I hope that you've had as much fun as we have. If you want to make sure not to miss a single session, head on over to the Google Developers YouTube channel. The playlist is now live.